Hi and welcome to the Blender 3D animation course. Animation is the heartbeat of Blender, and without it, the 3D models are just lifeless. Mastering 3D animation opens the door to creating stories, games, films, and powerful visuals that move and captivate. But being honest, animation isn't really that easy. It's not just about dragging the keyframes, it's more about patience, planning, and execution. And this is where this course is designed to help you. In this course, we'll be creating two animations. The first one will be of this basketball, and during the process of creating this first project, we'll understand about the 12 principles of animation that are extremely important to understand how animation works and what actually is the correct way to animate things. Then we'll begin with the second project where you will make a little robot waking up in a sci-fi lab, then it will shatter the glass and escape from the glass capsule. This entire course is split into multiple modules so that you learn one topic at a time and master the full animation pipeline step by step. From modeling your robot to rigging its arms, animating its moves, creating and applying the textures, everything will be covered in this course. So if you follow this course till the end, you will have a portfolio ready animation. And the best part about this course is that it's for anyone who has even a very basic knowledge of Blender, because we'll start from the scratch. First we'll download the Blender software, then we'll understand the basic navigation, some modeling tools and techniques, and then we'll move to the first project where we'll cover the 12 principles of animation, and then we'll create the second project where we'll cover things like modeling a robot, rigging and animating, setting up the scene, importing assets, animating each and every part of the scene, and then finally rendering the scene into an animated video. By the end of this course, you won't just know about animation, but you will have a full production skill set in Blender, ready to take almost any 3D project with confidence and professionalism. Before we begin with the first chapter, here is a note about the version of Blender that we are using. So at the time of making this course, the latest version is Blender 4.4, but everything explained in this course do apply to other versions as well, like Blender 4.5, 5.0, and any version that comes after it, and even the previous versions of Blender. So now let's begin with the first module of this course. Welcome to the first module of the Blender 3D animation course, and over here I have downloaded and installed the Blender 3D software, and you can also see a lot of things like the screen in the middle, a 3D scene behind it, and some settings on the right hand side. We'll get into all these things one by one in detail, but before that, if you don't have this Blender software installed in your PC, then you can follow the installation steps that I'll now be showing you in order to get the latest version of Blender right there in your device. So first of all, you have to visit this website, which is blender.org. Then it will take you to the home page of Blender, where you can read about the latest version of Blender, any latest news related to some development or some projects, and exciting new features. But the reason why we visited this website right now is to download the latest version of Blender, which at the time of recording this video is Blender 4.4. So I'll click on this download button, and yes, it might be possible that when you're watching this video, Blender might have come up with a more updated version of Blender. So if that happens, it will show you that particular version over here, but you would need to follow the exact same steps for downloading Blender. So once you click on this download button, you will arrive at this download page, and if you're using a Windows PC, then you can just click over here to download Blender for the Windows device. But just in case you're using some other operating software like Mac OS, Linux, then you can just click on this drop down and download the required version depending upon your operating software from this list. Also, if I just click on this requirements option on the top, then here we see this page which tells us about the system requirements for Blender, and if I scroll down, then here you can see the CPU, RAM and the GPU requirements, both the minimum as well as the recommended ones. So before downloading, at least make sure that you have the minimum requirements fulfilled. That is, if you're using the Windows operating system, then you should have at least Windows 8.1 installed, which you must obviously be having, then a CPU with at least 4 cores and 8 GB RAM, and a GPU of at least 2 GB of VRAM. Now coming back to the download part, I'll click over here to go back to the download page, then download the Blender software by clicking on this button. Then this will take us to this page and the downloading will start. Then once it is downloaded, you have to open that particular folder where you saved the installer file. For example, here I have the Blender installer file saved in the downloads folder. So from here, I'll double click to open it, and then it will show this installation window where first of all I'll click on the next button to start the installation process. Then it will ask me if I want to change the installation folder or basically its location in my PC, and in my case, I'll be going for this default location only, but if you want to change it to something else, then you can click on this change button and select that particular location. Then again, click on the next button and then finally click here to install. Then the installation will begin and it would then take some time to complete the entire installation process. And once it is done, you will get to see this completion window where I'll click on the finish button. Now we are done with the installation part and we are back in the Blender software. In the middle of the screen, we see this window with some settings, and this is known as the splash screen of Blender. Now one thing to note here is that this particular splash screen that you are seeing on the screen will only be visible when you open Blender for the very first time after downloading any of its version, because once you start using Blender, it will show you a different splash screen where you have things like some recent files, the option to create a new file, or to open an existing one. But assuming that you have downloaded Blender for the very first time, or at least this particular version for the very first time, and then you open the software, then you must be seeing this particular splash screen, where first of all you have the option to change the language, which I'll be keeping to English. Then you have the option to select the theme, which by default is selected to the Blender Dark, but if you want, you can change it to Blender Light if it suits you. It basically gives the feel of the old Blender versions, which used to have a light theme, but for me, I'll be changing this to the Blender Dark. Then after this, you have the option to select the key map. By default, it will be selected to Blender. And yes, for those of you who don't know what key map means, it simply means that the shortcut keys will be as per the selected type. By default, Blender is selected here, which means that the key map is selected as per this latest version of Blender. Then you have the second one, which is basically as per the older versions of Blender. And at last you have industry compatible, which could be useful for those 3D artists who already have some experience in some other 3D software, let's say Maya or something else. So for such people, this industry compatible option can be useful. But for now, we'll be keeping with the default settings only. So I'll select the Blender, then the mouse select will be left and the action for the spacebar will be set to the default play. Now after we are done with all these settings, let's click on the continue button to enter the 3D world of Blender. Now this is the other splash screen that you will always be seeing after the first time. On the left hand side, you have the options to create a new file, where mostly if you have to work in 3D, then you will be choosing the general new file. Other than that, if you want to open any existing file on your PC, then you would be using this open option. And currently on the right hand side, you have some self-help links like the manual and the tutorials. But once you start creating something in Blender, these will get replaced by the recent files that you have created or opened in the Blender software. So for now, you can either click on this general option in the new file, or else even if you click anywhere else on the screen, then it will land you into this Blender 3D viewport. Now we have a lot of things here. For example, this biggest area where you will be working for the majority of the time is the 3D viewport. By default, it has these three objects and these will appear every time you open a new file in Blender. This highlighted one in the middle is a cube object. This one is a lamp, and then on the left hand side, this particular object is the camera. You can select any of the objects by simply left clicking on them like this, or else you can left click and drag like this in order to select one or multiple objects together. Now whichever object is selected in the 3D viewport, its name will get highlighted in this area which is known as the outline editor. Here you will find every single object's name which is present in the scene, and this eye icon that you can see after every object's name will simply hide or unhide that particular object in the scene. This feature will be useful when you're working on a very large scene with a lot of objects, and in that case you might want to hide some particular object, and you can do that directly from the outline editor. Then here you have the properties editor at the bottom right corner, and this region will basically give you the settings that you would require to control different aspects of your object, the scene, lighting, rendering. So this is more like a settings panel, and after that on this bottom side where you have some numbers is basically the timeline editor. To see this properly, you can simply take your cursor over here till you see this double headed arrow, then left click and drag it like this in the upward direction in order to expand this area, and now you can see the timeline editor in a much better way. Now this editor will be useful while we are animating the objects in the scene. It shows you the frame numbers and some other very important things that you will understand later on if you continue watching the course. Now with my cursor in the 3D viewport, if I press the N key, then this will open this side toolbar which has many settings which might not be of much use to you right now, and also in your Blender software you would not be having this last one, which is the screencast keys, and this is because I've separately downloaded it in my Blender, and it will basically be used to display whatever keys I press here itself on the screen. So if I just go to the screencast keys tab and turn this on, then first of all on this bottom left corner of the viewport you see a mouse icon, that will display the left click, right click, and the middle mouse button action. And for the other keys, let's say I press N, then this will get displayed like this because of the screencast keys. Now again I'm telling you, you can ignore this part of the screencast keys because I have already downloaded and installed this extension in my Blender software, and unless and until you're recording your Blender work just like I'm doing here, there's no need to have this extension. And throughout this course, I'll be keeping the screencast keys on so that it'll be convenient for you to know the exact steps that I'm doing each and every time. Now before moving forward to the part where we'll interact with different objects in the 3D viewport, let's first see how you can save a file or open an existing file from your PC. So to save any file, you just have to use the regular shortcut, which is Ctrl S. Then this window will appear where you have to select the particular folder or the location where you want to save the Blender file. For example, I've created a folder which is named as Blender 3D Animation Course. So I'll double click on it to open it. Then I have another folder created with the name Module 1. And since right now we are in the module 1 only, so I'll open this by double clicking, and now I can save my file in this particular folder. But before clicking on save Blender file, you can rename your file by left clicking here and typing any name. Let's say I want to name this file as intro to Blender, so I can type it, and then if I press enter, then this will automatically add .blend at the end of the name, which is due to the fact that .blend is basically the file extension for the Blender files. Now after that, you can either click on the save Blender file button or you can press the enter key again, and this will save the file at the particular location. One more important advice is to keep saving your Blender work after every 5 to 10 minutes by simply pressing Ctrl S, and this will save all the changes that you have made, because if you do not do this, then it might be possible that your scene becomes quite complex and sometimes the software can even crash. So in such cases, it's always better to have your work saved rather than doing all that work again. Apart from this, if you ever want to open an existing file, you can use the shortcut which is Ctrl O. Then you can open the required folder and select the file that you want to open, then press enter. Now after we have seen and understood the basic interface, let's now see how we can move around or basically navigate in this 3D viewport. So you'll have to use the middle mouse button. If you hold it and then move the cursor around, then this will rotate the view like this, and then if you release the middle mouse button, then this rotation or basically this view will get fixed. Other than this, let's say you scroll up and down, then this will simply zoom in and out in increments. But if you want a smoother zoom in and zoom out, then you can hold the control key and the middle mouse button together, and then if you move the cursor around, like if I move the cursor up, then I can smoothly zoom in, and similarly if I bring the cursor down, then this will smoothly zoom out. And finally you can even pan the view by holding the shift key along with the middle mouse button and moving it like this. So if you're new to all these shortcut keys and the navigation tools, then try to practice each one of these for a few minutes till you feel confident enough to move ahead to some new concepts. Now let's come to the main topic of this course, which is 3D animation. So the first question is, what exactly is an animation? So animation is basically an illusion of making the objects depicted in a still image appear to move. In Blender, 3D animation is accomplished by creating data which displays on the computer screen. This display is programmed to change over a period of time, which is controlled with a timeline and then captured by a camera at regular intervals, producing the frames of an animation. Each of the frames is then rendered, which means that the Blender data is correlated and turned into a series of digital images. Finally, the images are compiled into a video clip or a sequence depicting an animation. If all this was too much for you, then you don't need to worry. We'll dive deep into these concepts like the frames, frame rate, timeline, rendering, when we actually create this scene in this Blender 3D animation course. Now let's take a look at what we see in this 3D viewport. Apart from these three objects, that is the cube, camera and the light, we have this 3D grid and these two lines which are intersecting at a particular point, and the color of these lines is also different. This red colored line basically represents the x-axis in the 3D space, this green line represents the y-axis in the 3D space, and there's also a blue colored axis which won't be visible right now because by default it is hidden in Blender and it represents the z-axis. If you want to view it in your 3D viewport, then you have to click here. That will open the settings for the viewport overlays, and here you have the option to hide or unhide any of the three axes. So if I turn on the z-axis by left clicking here, then this will enable the visibility of the z-axis in the 3D viewport. Also, you can confirm the relation between the color of the axis and their names using this thing on the top right corner of the 3D viewport, where this red line is representing the x-axis, the green is representing the y-axis, and the blue is representing the z-axis. And yes, you can also see that if I keep my cursor over here, then this will show the negative x, the negative y, and the negative z axis opposite to these ones. For now, I'll be hiding the z-axis from the viewport by again going to the viewport overlays and left clicking here. Now this point at which all the three axes intersect in the center is basically known as the world origin, and by default you have a kind of symbol here which is nothing but the 3D cursor. There can be multiple uses of this 3D cursor. For example, whenever you add a new object in Blender, it gets automatically placed at that specific position where the 3D cursor is located. So we'll get into the functions of 3D cursor and how can we move it in some other module, but since this is the first module of this course, so let's not get deep into that. Until now, you have a basic knowledge of what exactly is Blender, how you navigate and do some basic things, and you also understood the very basic meaning of 3D animation. And this finally marks the end of the first module of this course. This was just the beginning of this course because now we'll proceed to the next module where we learn about the Blender basics for animation, where we learn some modeling tools, the object mode, edit mode, the various concepts of timeline like frames, playback, auto keying, and how the keyframes work. Welcome to the second module, Blender Basics for Animation. Here, I have created a new Blender file with the default layout, and the first thing that we learn in this module will be about some basic modeling tools and understanding the different modes like the object mode, edit mode, and how each of these works. So here on the top you can see that we are currently in the object mode, which basically means that in this mode, you will not only see the objects that you have in the scene, but you can also select them by left clicking like this, and other than that you can move them by pressing G, or rotate them by pressing R, or scale them by pressing S. Now the three things that I just did, that is moving, rotating and scaling, are used for most of the times in Blender while you're setting up your scene. Let me explain it to you one more time. If you want to move this object, then you first need to select it by left clicking like this. Let's say I want to move this cube, so I've selected it here. Then I'll use the shortcut, which is to press G, and G here stands for grab, which basically means the same as move. So after pressing G, if I move the cursor, then the cube will move along with the cursor. If I left click, then its position will get fixed in the 3D space, and if I wanted to get back to the original position, then I can press Ctrl Z to undo this movement. Now it might be possible that you want to move it slightly above, and for that if you try to press G and move it like this, then it might also change its position in the y-axis, which is represented by this green line, and maybe slightly in the x-axis also. And in order to avoid this problem, Blender also allows us to move an object in a particular axis. And to see how it works, I'll simply press G to move, and just after that if I press the X key, then the object will move only in the x-axis because we have restricted its movement by pressing the X key. Similarly, without left clicking, if I now click Y, then the x-axis restriction will go away and the object will now only move in the y-axis. Similarly, if I press the Z key, then we can move the object, that is the cube, only in the Z axis up and down. Then you can either left click like this to fix the position, or else let's say you already pressed G to move it, but you do not want to finalize this position but return back to the original one. So you can directly press the right click mouse button while the grab tool is still enabled, and this will make it return back to the previous position. Now just like we can grab an object and place it anywhere in the scene, we can also change the rotation of this object, and for that the shortcut key is to simply press R. So if I press R like this, then the cube will begin to rotate. But right now the rotation is happening in all the three axes together, which you can also check here on the right hand side. But suppose you want the rotation to happen only in a particular axis, let's say the X axis, then for this, after pressing R, you have to press the X key, and now the rotation will happen only in the X axis. Similarly, if I press the Y key instead, then the rotation will be restricted to the Y axis, and the same is the case with the Z axis. Then in the end, the third main operation is the scaling, which basically controls the size of the object. So to change the scale, you just have to press the S key and move the cursor, and this will change the scale or the size of the object selected. Then to finalize, you just have to left click, and here the cube is scaled up. Now just like the grab and the rotate tool, if you want the scaling to happen only in a particular axis, then after pressing S, you can press that letter, let's say X or Y or the Z axis, and then the scaling will happen only in that particular axis. Another thing that you can do in the object mode is to add more objects in the scene. So let's say I press Shift A, then this menu will appear because Shift A is basically the shortcut key to add any new object in Blender. This will give you a list of different types of objects that you can add. For example, mesh includes plane, cube, circle, UV sphere, and other mesh objects. Similarly, you have curve, surface, metaball, text, volume. Then if you come down, you have image. Then you can add some lights, You can even add camera, just like you have in the scene right now, the force field for the wind and turbulence effects. But most of the times, you'll be getting into the mesh object category only because that includes the basic primitive shapes or the basic 3D objects that you can use to model anything in Blender. So let's say I select any of these objects, for example a cylinder, then this will get placed at the position of the 3D cursor, and to view it properly I think I should move it in the Y axis. So I press G, Y and place it over here. And basically this is how you can add a new object in the object mode of Blender. Then suppose you want to delete an object, let's say I select this cube, and if I want to delete this, then one of the ways can be to directly press the delete key and the object will vanish from the scene, or else I'll just press Ctrl Z to undo this deletion. And then the second way to delete the object, which is much more preferred, is to use the shortcut key, which is to press X and then delete. This will delete the object from the scene that we had selected. Now this was all in the object mode. Obviously there are more things also like lighting, the camera, but since we're covering the basics in this module, so we'll not get into that because we have to understand the difference between the object mode, edit mode and some modeling tools also. So for now, in order to enter the edit mode, we first have to select at least one object in the scene, and it should be such an object that you can edit, like you can control its size or make it smooth. So obviously you can't go into the edit mode with this camera because the maximum you can do with this is to move it around or rotate it, or maybe you can even scale this up and down, but that won't make any difference because the camera will be used to record the scene and it is not really an object that can be modeled to make something. Similarly, this light also, you can move it around and do other things with it, but this is also a helping object only because it will emit the light for the other objects in the scene. So basically you can understand all this in this particular way, that you will have two kinds of objects in the scene. The first category will be the primary or the main objects that you will model to make something, and these will be the objects that will appear in the final renders. Meanwhile, the second category, as we can call them as helping objects, they won't be directly visible in the final renders, but their effect will be seen. For example, the placement of the lights and the camera will definitely impact how the final renders will look. So coming back to the concept of edit mode, we have to select that particular object whose geometry will be changing. So in this scene, we have the cylinder whose geometry can be changed to create something else out of it. And to enter the edit mode of the cylinder, you can either click here on the top left corner and change this to the edit mode, or else you can use the tab key to toggle between the object mode and the edit mode. Now once you get into the edit mode, we can still see the other objects. However, if I try to left click to select them, then we won't be able to do that because only that particular object that you selected before entering the edit mode will be active right now. And you can see that in the cylinder, which is the active object, if I left click anywhere, then we'll be able to select its vertices which have formed its geometry. You can even select multiple vertices by left clicking and dragging like this, and you can even select all of these vertices together by using the shortcut, which is to press A to select all. Apart from the vertices, you can even select the edges or even the faces of this mesh object, and in order to do that, you have to change the selection mode from these three options on the top left corner. The first one, which is selected by default, is the vertex selection mode, and that's why you were able to select the vertices. Then you have the second mode, which is the edge selection mode, which means that if I left click, then I'll be able to select the edges of the mesh object. At last, we have the third selection mode, which is the face selection mode, and as the name suggests, it will allow us to select the faces of the mesh object simply by left clicking like this, and we can even select multiple by left clicking and dragging like this. Now instead of always clicking these buttons to switch the selection mode, we have a better method, which is to use the shortcut keys. So if I press 1, then this will enable the vertex selection mode. If I press 2, then this will enable the edge selection mode, and if I press 3, then this will enable the face selection mode. Now in this edit mode, here on the left hand side, we have a lot of tools that allow us to model different objects by changing the way how these appear, and we won't be understanding each of these right now because most of these modeling tools are needed in very rare cases when you're modeling something very specific. But yes, there are some common tools too, like the extrude tool or the loop cut tool. So we'll get into these basic ones right now, understand their usage with examples, and for the other tools that we have here, we'll be understanding these practically as and when they're required in this course. So the first tool that we're going to use is the extrude tool. Now one of the ways to use this tool can be to select the extrude tool from here by clicking on this icon, and then let's say I select this face on the top. Then if I left click on this yellow thing and drag it up, then basically it has created an extension of this face. In other words, the face that we selected basically got duplicated or it moved upwards and while still being connected to the original geometry. But instead of using this method to extrude, we'll be using another method, which is to simply use the shortcut or let's say multiple faces and then to press the E key to extrude the faces. Now see, this is the simplest way how you can extrude any faces, but Blender also allows you some other ways to extrude that will provide you different results. So let's say I select some other three faces. Let's say I select these three and then I will have to open an extrude menu from where I can select the type of extrusion that I want. So to open that menu, the shortcut is to press Alt E and this menu will appear. Here the first option is extrude faces and it's basically the same as the normal extrusion tool that we just used over here. So for now I'll press Ctrl Z to undo this and again press Alt E to open this menu, and on the second number we have extrude faces along normals, and if I select this and move the cursor up, then in this case the result that we get is slightly different from the one that we got with the default extrusion. You can clearly notice that this time the faces are extruded in the direction of the local normals and not just a basic extrusion. Other than this, let's say I select these three faces over here, then press Alt E to open the extrude menu again and select extrude individual faces. Then I'll move the cursor up and as the name suggests, this one basically extruded the faces individually along their normals and not together like we had in the previous two examples. Then for the last one, I'll be selecting this particular face on the top, then press Alt E to open the extrude menu, and here we have extrude manifold. If I select this and extrude it like this, then you will notice that this time the loop that we had here disappears. To explain you the difference, I'll select all this by pressing A, then press Shift T to create a duplicate and I'll place it over here and left click to finalize the position. Now if I select this particular face on this model on the left side and press E to extrude, then basically this loop that we have here is still visible just like before. But let's say I select this face, then press Alt E and in the extrude menu select extrude manifold and then extrude it like this, then this loop will disappear or basically dissolve, and this is how the extrude manifold is different from the default extrusion option. Now moving ahead, suppose I select these two faces on this left model and I want to extrude them out. So I can press E to extrude them like this and left click. So this was a very simple thing that you can do. But let's say I ask you to do the same thing on this right side model. Now you will notice that the main problem here is that this particular loop that is present over here is absent in this model, and so if I try to select any of these faces, then complete faces will be selected and there's no way we can select a part of the face like this. And this is where we'll have to learn the second tool, which is one of the most commonly used tools in the Blender 3D modeling, and it is the loop cut tool. As the name suggests, this one will help us to create a loop anywhere in the model, and to see how it works, we'll have to use the shortcut to insert a loop cut, and the shortcut is to press Ctrl R, and then if I keep my cursor anywhere after pressing Ctrl R, you will notice that it will show us a highlighted loop that we can insert anywhere. So let's say I want that over here I should have a loop cut, or let's say I want 3 to 4 loop cuts. So we can increase the number of cuts also by using the scroll wheel. If I scroll up, then the number of cuts will increase, and if I scroll down, the number of cuts will reduce. So you can set the number of cuts. Let's say I keep the number of cuts to something like 3 or 4. Then once the number of cuts are finalized, I left click. Then it will give us the option to position the loop cuts. And if you want them to be in the middle, then you can simply right click. Otherwise, you'll have to click the left mouse button. Now let me deselect these loop cuts by left clicking somewhere else. And then if I press 3 for the face select mode and select any two faces, then press E to extrude. Then in this way, we were able to create a result similar to this one just by using the loop cut tool to add some loops in the model. Now we have understood the two basic modeling tools, the extrude and the loop cut tool, and both of these are used almost every time you model something in Blender. And with this much knowledge, you have now understood what exactly the object mode is for, what is the edit mode, how we can use the modeling tools to create some different shapes, some basic shortcuts like E for the basic extrusion, Alt E for the extrude menu, Ctrl R for the loop cut, the tab key to switch between object mode and the edit mode. And after all this, we'll now enter the object mode again and understand another basic thing, which is that in this 3D viewport that you see, we have these two shapes, but if I try to select just one of them, it won't be possible, as you can see that both of them are highlighted and also they are being represented by a single object cylinder in the scene collection. Now you might think that why exactly is this happening, and the reason for this is very simple. If you add an object while being in the object mode, let's say I press Shift A, then go to mesh and select any object, let's say UV sphere, then that particular object will be mentioned separately in this window and will be treated as a separate object. However, if we try to add any object or create any duplicate while being in edit mode, Let's say right now I'm in the edit mode of this UV sphere, and so if I press Shift A and let's say I select the cube object to be added and move it in the x-axis, then in this case, even though we are having two different objects, that is a UV sphere and a cube, but since we are in the edit mode of the UV sphere, so both of them will be treated as single object under the name sphere in the scene collection. So do ensure that if you want to add any object in the scene, then you must do so while being in the object mode and not the edit mode. Now we have already understood the basic meaning of animation in technical terms and how it relates to the frame number, the frame rate and the other things. But now let's practically understand it with the help of an example, that how exactly does animation work in the Blender software. So to understand this, I'll first select both of these objects and press X to delete them. Then we'll add a new object by pressing Shift A, then go to Mesh and select a UV sphere. Let's move it up in the Z axis and I'll place it over here. Another important thing is to notice that right now this spherical shape or the UV sphere is not very smooth. As you can see, these square shapes, which are nothing but the geometry of the UV sphere that you can also see in the edit mode. But let's say I want the surface to be smooth, so what I can do is to right click while being in the object mode and select shade smooth or shade auto smooth. So I'll select this for now and this will give me a smooth surface. After this, let's say I want to create an animation where it falls on a plane object and then it bounces a few times. So to create such an animation, let me also add a plane surface that will act as the bottom or basically the floor. So press Shift A, then go to Mesh and select the plane. Now to scale it up, I'll go to the edit mode, press A to select all and S to scale it up like this. Now let's return back to the object mode, and to create the animation of this ball moving up and down, we need to take the help of this timeline editor window which is at the bottom. So to expand this window, I'll take my cursor over here, which will then turn into a double-headed arrow, then left click and drag it above, and you can see some numbers on this timeline editor which are nothing but the frames. And as I explained before, an animation can be of any number of frames, and per second of an animation can also have any number of frames. Usually, for simpler animations, a frame rate of 24 frames per second or 30 frames per second is desired. And so if you're planning to create a 5-second animation clip, the total number of frames will be 120 or 150 respectively. So now let's say I want that initially at the first frame, the ball should be at this particular location. You can also see this in the properties editor, that location in the z-axis is somewhere around 5 meters. So let me round it off to 5, and to fix its position for this particular frame number, we need to insert something which is called the keyframe. It basically tells the software or this timeline that at this particular frame number, a particular property of the selected object was fixed, and then we can change it at some other frame number to animate the property. To see how it works, let's insert a keyframe for this UV sphere. So the shortcut to insert a keyframe is to press I, and after inserting the keyframe, you will notice a yellow colored diamond shape appearing on the frame number 1. Now let's say I drag this pointer and I place it somewhere around frame number 25, and at this particular frame I want that the ball should touch the ground. So what I'm gonna do is to move this ball down in the Z axis, but to see the plane properly, I think that we should change the view to the front or the side view. So if I press 1 on the numpad, then this will take me to the front view. Then I can zoom in, move this downwards in the Z axis like this, and now if I press I to insert another keyframe at the frame number 25, then this will mean that a particular property, which was location in the Z axis in this case of this UV sphere, changed from 5 meters at the frame number 1 to something around 1 meters on the frame number 25. And this also means that if I try to play the animation by taking the pointer back to the frame number 1 and pressing the space bar, then now the ball will be animated and will move down. Similarly, let's say I now take the pointer to the frame number 45 and I want that the ball should move up around 3 meters. Then I can press I to insert a keyframe here. Then I'll take the pointer to, let's say, frame number 65, and here I want the ball to move down again. So one of the ways can be to push it down by pressing G and Z and place it over here and then inserting a keyframe. But a better way is to select this keyframe that we added at the frame number 25, because at this frame the ball was touching the plane or the ground. So to select this keyframe, just left click and drag like this, press Shift T to create a duplicate and move it over to the frame number 65. Now to see the complete animation that we have created till now, I'll take the pointer back to the frame number 1 and press the space bar. Now another interesting thing that you can do while animating anything in Blender is to use an option which is called the auto key. So to see how it works, I'll first take the pointer to frame number 80, and at this frame, let's say I move this up again over here, and now I don't want that every time I do some changes in the location, I should manually press the I key to insert a keyframe, but instead it should automatically insert a keyframe whenever I make any changes. And to make this happen, I have to click here on this tool, which is for auto keying. So if I turn it on, and now whatever changes I'll make, let's say I move it up in the Z axis, then it will automatically add a keyframe at the particular frame number. Similarly, if for the frame number 90, I want this to come down towards the bottom, then I'll move it down like this and it will automatically insert a keyframe here. So this was a very basic example that you can use to understand how animation works in Blender, how you have to work with frames, keyframes, the auto key feature, how the timeline and the playback works. Although there is still a lot to discover in this course about animation, but you now must be having a basic understanding of how all these different things work together. And so the second module now comes to the end. Welcome to the module number 3, Advanced Animation Concepts. In the previous module, we started with the understanding of some basics like some modeling techniques, edit mode, object mode, and how we can animate the objects in the scene with the help of this timeline editor. But now it's the time to step ahead and learn some new things which form the core of animation in Blender like dope sheet, graph editor, interpolation types, and other related concepts. So to begin with, I have this cube selected in the scene, and let's say for the frame number 1, I'll move this cube in the y-axis by 10 meters in the negative direction. So after pressing G and Y, I'll type -10 and press enter. Then to insert a keyframe for this particular position of the cube at the frame number 1, I'll press the I key. Then I'll take the pointer to somewhere around frame number 60. And now to bring this cube in the direction of the positive y-axis by 10 meters, one of the ways can be to move it by pressing GY and typing 20 because the difference is of 20 meters, or the other way can be to directly go to the properties editor, then ensure that the object properties is selected here, and in the y-axis location type 10. Then press I to insert another keyframe, and in this very simple manner we were able to create a basic animation of the cube moving in the y-axis. Now there was nothing new in all this because we have already discussed how to do this in the last module. But suppose I ask you that just by looking at the keyframes or this timeline editor, is there any way you can know that what exactly are these two keyframes representing? Is it the change in location? Is it the change in rotation or the scaling, and in which particular axis? So right now there is no way we can just look at these keyframes and analyze these things. But if I just click on this arrow button over here like this, then this will display a sidebar which has something called summary, and if I click here again, then this will display the name of the object which is selected, which is the cube in this case, and after that there is something called cube action, and if I open this, then it says object transforms. We'll understand what it means in a little while, but before that, if I again click on this drop down here and scroll down, then this displays us many different things like X location, Y location, Z location. Similarly, we have the rotation in XYZ and the scaling in XYZ. And currently, for all of these parameters, we have both the keyframes added, even though we only made the change in the y-axis location, but it's happening because for any particular frame, if I simply click the I button, then it basically means that it is fixing all the three parameters, meaning the location, rotation, and the scaling in all the three axes at this frame number. As a result, we have a keyframe inserted for all these values here. But let's say I want that it should not store information about the rotation and the scale values for this particular frame number in the form of a keyframe. Then in order to do this thing, I'll take a look at this sidebar and I'll see that the rotation is represented by these keyframes. So I'll select these by left clicking, and if I keep on selecting these, then all of them will get selected like this. Then if I click the delete key or the X key, then these particular keyframes will get deleted. Now what's happening here is that till the frame number 60, we have the keyframes in all three parameters in all three axes, but beyond that, we are having the keyframes added only for these three parameters, which are basically the location in X, Y, and Z axis. A better way to understand would be to just select all these keyframes by pressing A, then press X to delete all of these, then take the pointer back to the frame number 1, and now let's say I want an animation where the cube will rotate around the y-axis and I don't want any of the keyframes added for any parameter. So what I'll do is with this cube selected over here, I'll go to the object properties, then in the y-axis rotation that I have over here, I'll keep my cursor over it, and if I click I, then this will insert keyframe for all three values of rotation, that is in the x-axis, y-axis, and the z-axis. To cross-check this, if I go to the timeline editor, then in object transforms, I am having three kind of parameters: X rotation, Y rotation, and Z rotation. But if you remember before, I told you that we need the keyframes to be only added for the Y-axis rotation. So to make this actually happen, I'll again go back to the object properties and I'll click this icon which is diamond shaped, which is basically responsible for inserting the keyframe. So if I click this for rotation in X-axis, then the keyframe will get disabled here. And similarly, I'll do the same thing for the Z-axis. And by doing this, we only have the y-axis rotation turned yellow in color, which is representing the addition of a keyframe, and you can see the same thing in the timeline editor, that in object transforms, which basically means the change in object's position, rotation or scaling, we only have one single parameter, which is the rotation in y-axis. So we have a keyframe added over here, and then let's say I take the pointer to the frame number 80, and in the viewport, if I press Y to rotate this in the y-axis and type 180, then press enter to confirm, then I'll go to the object properties again, and to insert the keyframe for this particular rotation value in the y-axis, I'll click on this icon, which will again fill this diamond shape, and it will mean that we now have the keyframe added for the y rotation. Now I'll take the pointer to the frame number 1 and press the spacebar. And in this way we got a basic animation with the cube rotating in the y-axis, and that too without the unnecessary keyframes being added in the timeline editor. Now before moving forward, you might think that how does it really matter? Even if all of these keyframes were added, there was no such difference because the other values still had to be constant throughout. Well, this would be correct to say if the scene is very simple and you have very few objects and animations, but when you're building a huge scene where you have multiple objects and each object has a separate animation and that too in different parameters, then it can become quite difficult to understand why you added a particular keyframe if you do not follow this approach of inserting the keyframes for the particular parameter. And yes, you might also want to create some other animation later on to the same object, which can be in any other parameter here, and in that case also having separate keyframes for each parameter will help you. Now another important thing here is the length of this animation. Currently you can see that the animation starts at around frame number 1 because that's highlighted in this timeline editor, and this highlighted part ends between 240 frames and 260 frames, and if I take my timeline pointer over here, then it says that the animation ends at the frame number 250. Beyond that, the area is dark just like we had before the frame number 1. Now you can control the number of frames in the animation by these values in the top right corner of the timeline editor. Here you have the current frame where the timeline pointer is also located, and here you have the starting frame which is set to 1 by default, and here you have the ending frame. Let's say I change this to 100 frames, then in this case the total animation will be having a total length of 100 frames. So once it reaches the 100th frame, it will return back to the frame number 1 and will play again. Now let's just say you feel that the animation is a little bit slow, so to make it fast what you can do is to select the keyframes at the last frame, which is frame number 80, then press G to move them, and if I place them closer to the initial frame, it will mean that the animation is short and therefore faster. Another way to do the same thing would be to press A to select all, and with the cursor over the frame number 1, if I press S to scale this down, then it will bring these keyframes closer to the frame number 1. But yes, do note, when you're using the scaling down method, you keep the timeline pointer at the correct frame, because let's say I keep this to frame number 80, or let's say I keep this to frame number 70, and then if I press S, then it will take the frame number 70 as the center point or the point around which the scaling happens, and the keyframes will move like this. So by moving the keyframes, you can set the speed of the animation. Now if you remember, in the last module we created a very simple animation with the UV sphere moving up and down, but if you take a close look at this animation, it's not really very smooth. The way it stops, the way it reaches the top and slows down, it does not give it a very realistic look. And to make this animation look smooth, we'll take the help of some advanced animation tools. So what I'm gonna do is to delete this cube object from this scene, then press Shift A, go to Mesh and add a UV sphere. Then I'll move it up in the Z axis by 1 meters. Then right click to apply shade smooth. Press Shift A again to open the add menu. Then in the mesh type, select plane. This will act as the ground or the surface on which the UV sphere will fall. So let's scale this up by going to the edit mode and pressing S to scale up like this. Now press 1 to go to the front view, and currently it is fixed at this particular position where the base of the UV sphere is touching this ground or the plane. And we already know how to animate this in a simple way. Like I can just select this UV sphere, take the pointer to the frame number 1, press I to insert a keyframe at this particular position. Then let's say I move this up by 3 meters in the Z axis. But if I take the pointer now to the frame number 20, the position will reset because I've already added some keyframes here. So they will take these keyframes as default for the rest of the animation until and unless I insert some new keyframes here. So at the frame number 20, I'll move this up in the Z axis by 3 meters, press I to insert another keyframe, and then I need to bring it down to the previous position over here at the frame number 40. So I'll just select these keyframes, press Shift D to create duplicate and place them at the frame number 40. In this way we have a very simple animation created, but we didn't really learn anything new here because we already know how to do this thing in the timeline editor. Now let's say in this window, I click over here, then this will display the list of all the windows that I can switch this to. And right now the timeline is selected in the animation category. But other than the timeline editor, we also have some other things like the dope sheet editor, the graph editor. We'll be getting into these two in a little while. But before that, here on the last number, we have non-linear animation. And this is something which is pretty interesting. So I'll click on this, and this is the non-linear animation editor, which is also known as the NLA editor. Now the first question which arises is that what exactly is the meaning of non-linear animation? So non-linear animation or NLA refers to the process of moving, rearranging, manipulating and blending multiple clips of animation to produce a series of motions. To put it in even simpler words, an object can have multiple animations applied to it, and those animations combined together will result in the formation of an action, and then you can use that particular action to create some new animation sequences. Now I'll practically make you understand what I mean to say, but before that we still have to open one more window here which is important to understand the nonlinear animation, and it is called the action editor window that we can open through the dope sheet editor. So to get that window over here, you just have to keep your cursor over one of these ends, and then the cursor will change like this. Then left click and drag this window above. Now in the second window over here, which is in the middle, click on this icon, and in the animation category, select dope sheet. Then click here and change the mode to action editor. Now you might be thinking what exactly is the meaning of action. So whenever you create any animation in a Blender file, all the data related to that animation gets saved as an action. To make you understand this in even more detail, I think that we should just delete this UV sphere, then press Shift A, go to Mesh and add a monkey object. Let's move it up in the Z axis by 1 meters and place it over here. Now currently in this action editor we don't have anything because we have not yet created any animation, and so there's no such data related to that animation of the Suzanne or the monkey object. Now to give this object an action, we just have to click on this new button which will create a new action named as action. So let's say in this animation I want that at the frame number 1 the object should be placed over here. So I'll press I to insert a keyframe here, and then at the frame number 40 I want the object to move up in the Z axis by 3 meters. This thing is very similar to what we were doing with the UV sphere before. So at the frame number 40 I'll press I to insert a keyframe here, and in this way we are able to create a very simple animation of the object moving up. But again, there's nothing new here because we could already do this thing in the timeline editor. Now let's say you want the animation to also include a downward movement at somewhere around the frame number 80. So what I'll first do is to select these three keyframes over here, press Shift D to create duplicate and move it at the frame number 80. This will mean that initially the object will be at the default position, then it will move up at frame 40, and then it will move down at the frame number 80. Now even though these are two different animations, but when combined together we are calling them as action. In fact, you can even rename this action by left clicking here, and suppose I change this to up down action. So I'll rename it like this and press enter, and in fact I can do this thing with any object in the scene. Let's say I press Shift A, then go to mesh and add a UV sphere, press G to move it over here, then at the frame number 10 I can create a keyframe, and at the frame number 46 I can scale it down and press I to insert another keyframe, and this will give us a new action for this sphere, which is the sphere action 001. And yes, you can even check all the actions that you have created till now by clicking here, but this thing is not relevant right now, so I'll just delete this UV sphere and again select the monkey object. Now even if I click on this cross icon, you might think that the animation has now disappeared. It is still saved in the Blender file in the form of that action that we created, and to get it back here, I'll again click here on this icon and select up down action, and this will give back the animation of the object moving up and down. Now let's say I want to create another animation where the object will change its scale as it moves from the frame number 1 to the frame number 80. So what I'm going to do is to click on this cross icon and create a new action by clicking here, and I'll change its name to scale action and press enter to confirm. Then I'll take the pointer to the frame number 1, press I to insert a keyframe for the default scaling, and since I want the same scaling to be applied at the frame number 80 because I want the final result to be this only, so I'll go to the action editor, press A to select all, then Shift T to create a duplicate and move these keyframes at the frame number 80. Now I'll take the pointer to the frame number 40, which is in the middle, press S to scale it up like this, and press I to insert a keyframe. In this way we have another action created named as the scale action, and it changes the scale of the object where it first increases and then returns back to the original scale. Now another important thing is that in your action editor window you might be seeing the result like this, where you can only see one keyframe added over here. So just like the timeline editor window, you can just click on the summary option here, and this will display the objects on which the animation is applied, and within that object setting it will display the object transforms like the location, rotation and the scaling and the respective keyframes. Now moving ahead, we can use these actions that we have created in this nonlinear animation editor to create some amazing results. But before we do that, you need to know that what exactly is the use of the nonlinear animation editor. So it would be easier for you to understand this thing if you have ever worked with a nonlinear video editing software like Premiere Pro or DaVinci Resolve, because in such softwares you can add the clips in multiple layers and create a video out of it, and in a very similar way the nonlinear animation editor works. Instead of clips, you'll have the actions that you create in the action editor, and to bring those actions in the nonlinear animation editor, you'll have to use something called push down, and then you can move the animation around just like a clip to adjust its position in the timeline in this editor. So to practically see how to do this thing, let's say I want to bring the scale action into the nonlinear animation editor. So what I'll do is to go to this action menu and select push down action, and by doing this we see that in the nonlinear animation editor window we first have a category called Suzanne, which is basically the object name, and under this we see the scale action added. And the best part about this is that we can just select this and left click to drag it and move anywhere in the timeline. Let's say I want it to start from the frame number 21, so I can easily do this thing, and here we'll see the scale action being applied to the Suzanne object. In a very similar way, I can go to the action editor, then click here and select up down action, and now let's say I want this particular action or the animation to start from the frame number 11. So with the up down action selected, I'll go to action settings or the menu and push down action. Then in the nonlinear animation editor, first left click to select this, then drag it so that it starts from the frame number 11. But if I now try to play the animation by pressing the spacebar, then you will notice that the object only shows the up down action, and this is happening because the up down action is placed above the scale action. And just like any non-linear video editing software, the clip at the top will be shown or applied because that's how the preference works in comparison to the clip below it. But let's say you want to see the scale animation instead of up down, so you can just uncheck this box over here, and now if I play the animation, then you will see the scale action being applied on the Suzanne object. Now another thing that we can do here is to check this box again, which will result in up down action being applied. But let's say you want the scale action again, so one more way to do this thing is to click on the star icon, and by doing this you will again see the scale action being visible on this object. And now let's say I place this clip over here at the frame number 1, and then the scale action clip is placed at the frame number 80. Then I'll also have to increase the animation timeline, so I'll just go to the output properties and change this ending value of the frame range to 200. And then if I play the animation by going to the frame number 1 and pressing the spacebar, then first the object will move up and return down because of the up down action, and then it will scale up and down because of the scale action. So in this way you can use the NLA editor to easily work with multiple animations that you have for the objects in the scene, and it will be very useful for you when you have so many objects with multiple animations, and also if you like to work with non-linear video editors as we discussed before. So in short, it just makes the animation work more convenient. Now you might feel that the NLA editor is very useless because you cannot even combine two actions together, but this is not really true, because if you want we can combine multiple actions together. For example, let's say I want the up down action and the scale action to appear at the same time. So what I'm going to do is to select the scale action, left click and drag it below the up down action starting from the frame number 1. But right now only the up down action will work, because as we discussed this before, the clip added above will have more preference in the order. But if I go to this toolbar on this side, which you can make appear or disappear with the N key, and then in the active strip go to blending and change this to combine. And now if I take the pointer to the frame number 1 and press the spacebar, then in this case we see the object moving up and down, and at the same time it will also be scaling up and down. So it basically gives us a combined result of both the actions in the editor with the blending mode set to combine. So to conclude this NLA editor, I'll just mention a few key points that you can keep in your mind so that whenever you need to use this editor, you will be able to do that in a very simple way. So first you have an object which you will animate, then you save that animation in the form of an action with the action editor, and you can get this window by going to the dope sheet editor and then changing the mode to action editor from here. Then once you create a particular action, you can push it down and use in the nonlinear animation editor, where you can work with different actions, you can set their positions in the timeline, you can combine them together and do this for multiple objects in the scene. Now let's move to the next topic of this module, which is to understand the graph editor in Blender. And yes, this concept is very important if you really want to understand the 3D animation in detail, because simply inserting keyframes doesn't give you much control over the animation that you're creating, but understanding and working with the graphs would really allow you to create smooth and better animations. And at the same time, you'll also be able to see some tools like cycles, noise within the graph editor that will help us to get the desired results in a very less time. So to see how it actually works, I think I should first delete all these objects in the scene. Now I no longer need this window of the nonlinear animation editor. So what I'll do is to take my cursor over here, then right click and select join down. This will basically join the two areas together and the result will be the action editor window. Now I'll bring this down, and then to change this to the graph editor, what I'll do is to click here to open this menu, and in the animation category select the graph editor. Now we are not able to see any graph here, and the reason behind this is very simple, that we don't have any object in the scene and as a result no animation. So let's first add something in the scene. Let's press Shift A, then go to Mesh, and I'll be selecting a UV sphere. Let's move it up in the Z axis by 1 meters. Right click to apply shade or to smooth. And currently in the graph editor, we still cannot see anything. But yes, one thing is visible, which is the timeline frames. The highlighted portion starts at the frame number 1 and it ends at the frame number 200, which is because the frame range is set from 1 to 200, and it is exactly the same as the timeline editor in this case. Now to actually see the other important things like the actual graph here, we'll have to insert some keyframes and create a simple animation. So with this UV sphere selected, I'll first take the pointer to the frame number 1, then press I to insert the first keyframe, and here we notice some changes, but we'll not get into it right now because we won't be able to understand it until and unless we have two keyframes for this particular object. But yes, what we can see right now is that on this left hand side, we get this sphere, which is the selected object, and currently it has the sphere action. If you remember, I told you a few minutes ago that whenever you create any animation for a particular object, its data gets saved in the Blender software in the form of an action. And currently, the name of this action is sphere action. Now, if I again click here, then it shows object transformations. And within this, we get all the type of transformations like the change in location, rotation, and scale in all three axes. Now, as I explained you before, we are able to see all these things because we directly added a keyframe by pressing I. But instead of this, if you want the keyframe to be added for a particular transformation, let's say you want the animation to happen only in the Z-axis rotation. So you can just get rid of these unnecessary keyframes that are added to all these attributes or the parameters. So you can switch this window to the timeline editor, and then in the object transforms, you will again see this list and you can select all those that you want to delete and press the delete key. But for now, I think that I should press Ctrl Z because deleting these won't give me any benefit right now since the animation right now is pretty simple. So let's again head over to the graph editor window and complete the animation that we are going to create. We just fixed a keyframe at the frame number 1, and now I'll take this pointer to the frame number 50 and I'll move this up in the Z axis by let's say 6 meters. Press I to insert another keyframe, and here we see some changes in the graph editor. But before I explain these to you, one more important thing is that you can zoom in and zoom out into this graph with the scroll wheel, and you can even change the view or pan with the middle mouse button and moving the cursor like this. Now in this window, we are able to see a few things. We first have a blue colored graph. We have this pointer and this line with three dots, which is nothing but a handle for this point of the curve. Now see, the most important thing in this graph editor right now is this blue colored curve. This denotes the change in location of this UV sphere in the Z axis. And if you want to know how you can read this graph, then on the top you have the timeline or the frames, like the animation will start at the frame number 1 and we have this particular animation till the frame number 50, and during this animation, if I go to this left hand side, you have some numbers like 0, 5, 10, and these are representing the value of the parameter, which in this case is the Z-axis location. So at the frame number 1, the value of the parameter is above 0, which means it is 1 meters, and you can even check this thing by going to the object properties in the properties editor, and in the location in Z-axis you have 1 meters. Then you can see that around the frame number 30 or 32, this curve or the graph will cross the value of 5 meters, which again you can confirm in the object properties that the location in the Z-axis is a little bit over 5 meters. And then in the end, at the frame number 50, this point of the curve is somewhere between 5 and 10, and also it is below the lower half, so it must be between 5 and 7.5. And here in this object properties, you can see that the exact location is 7 meters. So in short, at the bottom you have this line which is denoting 0, Then we have a straight line at 1 meters because initially the object is at the default position, which is 1 meters in this case, and the animation starts from here. And beyond that point, we have a curve till the frame number 50, showing the animation of change in position from 1 meters to 7 meters. Now, before we get into this in complete depth, like understanding what exactly does the shape of the curve means, and how can we change it to see the effect real time in the animation, I first need to answer a doubt that could have come to your mind, which is that how will you identify that which of these parameters is being represented by this graph or the curve. So you have to follow a very basic rule, which is that the x-axis parameter will always be represented by the red line, y-axis by the green line, and the z-axis by the blue line. You can also check this thing over here. We have the red labeled as x, which is denoting the direction of this axis, y labeled as green, and z as the blue color. Even here, this blue curve is representing the change in location in the z-axis, and you can even confirm this thing by going to object transforms in the sphere action, and if I left click on x location, then it will get selected, and you will notice that in the graph editor no curve is highlighted, which in very simple words means that there's no change in the x location of this particular object, so there are no keyframes, and as a result no curves. Similarly, if I go to y location, we'll again have nothing highlighted in the graph editor, but if I now select the z location, then as you guessed correctly, it will show this blue curve highlighted, and then similarly the x rotation, y rotation, z rotation, and similarly the scalings also. In all the three axes, none of them will be highlighted in the form of a curve. Now let me select the z location again and return back to this curve. Now another thing to notice here is that while on one hand it might seem that for all the other parameters like x location, y location, we don't have any curve present in the graph editor because nothing is being visibly highlighted in this graph editor. But if you look closely enough, you will notice that on selecting the x-axis location, we do get a slight red colored straight line which denotes the x-axis. And yes, the straight line denotes that there is no change in the particular parameter throughout the animation sequence. And in a very similar way, if I select the Y location, then it will be colored as green, and again it's a straight line denoting the same thing, that is no change in the Y location throughout the animation. Now let's return back to the Z location, which gives us this blue colored graph or the curve. Now let's suppose I want to make this animation around 100 frames long. So for the first 50 frames, we want the ball or the UV sphere to move up, and then in the end, that is at the 100th frame, we want this UV sphere to return back to the default position, or basically 1 meters in the z-axis. So what I'll do is to go to the object properties, then in the z-axis location type 1 meters and press enter, then press I to insert a keyframe. This will give us a curve like this, where initially at the frame number 1 we are at 1 meters over here, slightly above 0. Then the curve moves up at the frame number 50. We get the peak, which is a location of 7 meters in the z-axis, which can also be seen in the graph, that it's above 5 meters and it's below 10 meters. And then at the frame number 100, we again have a point here, which is exactly same as the point that we had at the frame number 1, denoting the position in the z-axis or the location of 1 meters. Now, one particular thing that you should have wondered, especially if you're understanding the curves in Blender for the very first time, and that thing is, this curve is not a straight line, like not parallel to the zero axis, but it's still not straight. Like instead of this, we could have had a straight line starting from this particular point and ending at this one, but instead we have this strange looking curve which makes the things more complicated. And the answer for this is that the change in location that we are basically trying to animate is not constant or uniform throughout this animation sequence. To put this in even simpler words, the speed with which the ball moves up and down is not really same throughout the animation. You can even check this thing by pressing the spacebar. Then you will notice that initially the animation was a bit slow, like from the frame number 1 to frame number 10 or 20, the animation wasn't really very fast. And then after that, if I press the spacebar again, then the animation was a bit faster as it gained some speed, and it again slows down around frame number 40 till the UV sphere reaches the top, and then the same thing happens again after the midpoint, which is the frame number 50, because till around 60 or 65 the animation is a bit slow. Then beyond that point, like around frame number 70, it picks up some speed and then it again slows down in the end at somewhere around the frame number 90. Also, it would be better if you replay the animation one more time and notice the changes that we just discussed from the starting till the end. So I'll play the animation and you can see how the speed of the Z location of the ball changes. So the animation is over. And one more way using which you can confirm this non-uniform speed is that if I go to the frame number 1, then the location in the Z-axis is 1 meters. Then at the frame number 10, it increases by about 0.5 meters. But if I take this pointer now to the frame number 20, then this time the Z location has almost doubled, so we see a change of about 1.5 meters. So the first time the difference was 0.5 meters, the second difference is 1.5 meters, meaning the speed has increased. Then till the frame number 30, we reach around 4.8 meters, meaning that the Z-axis location increased by 1.8 meters, so the difference is 1.8. Then we discussed before that the speed should decrease now after the frame number 30. So at the frame number 40, we notice that the z-axis location is 6.3, so the difference will be around 1.5 meters again. And then finally at the last frame, we have the z-axis location as 7 meters, meaning the difference is around 0.7 meters. So you can see that initially the difference, or basically the speed, is increasing till the frame number 30, but after that the speed of change or the difference decreases till the frame number 50. Now here I'm giving you a little exercise that you can do in order to understand this concept in even more detail, and that exercise, or basically your homework for this module, will be to find the difference in the z-axis location from the frame number 50 to 60, then 60 to 70, and so on till the frame number 100 with intervals of 10 frames each. And then you have to analyze that how is the difference changing. As a hint, I can tell you that initially the change will be less as you move from frame number 50 to 60, then he'll keep on increasing till around frame 80 or 90, and then at the end it will again reduce. You can also simply understand it in this way, that steeper the curve, faster the speed will be, and the shallower the curve, the lower will be the speed. In fact, this is true in real life also, because if you throw a ball in the upward direction, the speed of its movement will increase before it reaches the top. Then at the top position it stays there for a little while, and then it gains the speed as it moves down. So it's not really a very difficult thing to understand. You just have to compare what we see here with real life, or even if you don't want to do that, you just have to compare the curve and its movement with the animation of the ball that you see in the scene. Now let's say for some reason you want to change how this curve looks. For example, if you want the speeds to be uniform, then instead of this curve, like you can see in this graph editor, we should be having two straight lines. First one from frame number 1 to 50, and the other one from the frame 50 to 100. And to convert these graphs into straight lines, we simply have to make these points on the curves more steep. But before we do that, we first have to ensure that we are able to hide these extra lines of the curves which are due to these other parameters. And you can do this thing by clicking on this I button. If I click this, the X location will be hidden from the graph editor. So I'll do this with all the options of the parameters except the Z location. And once it is done, we'll only be seeing this curve apart from this blue colored line, which is obviously representing 0 or the origin. Now to make this more steep, I first have to select this point over here, which is at the frame number 1. And before we make any changes, you can notice here that for any of these points in the curve, we get these two extra points attached to it, which are nothing but the handles of that point, and these allow us to change the way how the curve looks. Now let's say I directly select this point in the middle, which is basically a point on the curve, and then if I press the G key and move the cursor around, then you can see that I can change the way how the curve looks. For now, I'll right click to cancel this movement. In a similar way, if I press the S key and move the cursor around, then the graph will scale up and scale down. So let's say I scale this down like this, then this will give us a steep curve, which also means that if I now play the animation, then you will notice a much uniform speed throughout, and around the frame number 50, the UV sphere just touches the top and instantly returns back like you can see here. But suppose if I now go to the graph editor, and with this point selected, if I scale it up by pressing S and moving the cursor away like this and left click, and then place the cursor at the frame number 1, or basically the timeline pointer, and press the space bar, then this time you will notice that the UV sphere stays at the top position for a much longer time, which is happening because of the shape of curve, which is not steep this time, but rather it looks more like something horizontal. Other than this, let's also see how these handles can change the way the curve looks. So first I'll scale this down, and then after this I'll select this right handle of this point by left clicking on this, or else I can just select it by left clicking and dragging the cursor like this. Now with the right handle selected, if I press G to move it, then you will notice that it also influences the left side of the curve slightly, and a similar thing will be seen if I try to move it by pressing G. But suppose you want that this right handle of the point should only control the curve on this right side. So to do this thing, you need to change the type of this keyframe handle. And to do this thing, you have to use the shortcut, which is to press V and then this will display this menu where you can set the keyframe handle type. And let's say I select the first type, which is free, and after this if I press the G key to move it around, or if I rotate it by pressing R, then any change that I create here will not influence the curve on the left hand side. If I select this handle and press R to rotate it or press G to move it around, then this will not influence the curve on the right side. You also have some other options like aligned, which would mean that both the handles will influence each other and the curves that they are controlling. And other than this, you have vector, which will make the curve very steep at this point. And it also means that if I try to play the animation from the frame number 1, then slowly the speed will increase, then it gets uniform. But at the frame number 50, the UV sphere will return back with a very quick speed because it is only touching the top part for just a single frame. You can check this thing again by playing the animation that the time period for which it stays on the top is very small. So usually you can set the keyframe handle type to either free, aligned or vector depending on how you want the curve to be and how you would be using the handles to manipulate the curve. Now another thing that I need to tell you is that understanding these curves will be very easy for you if you have studied about graphs and curves in mathematics or physics before, because in that case it won't be difficult to understand what a steep curve means or what a shallow curve means. But even if you are completely new to this and these graphs or the curves confuse you a lot, I would advise you to either rewatch this part where I explained you what different types of curves will mean, especially the parts like shallow and steep parts, how making changes in the points or the handles can impact your curves, and how all these changes together gives the overall animation a completely different look. Now let me show you one more very interesting thing, which is known as interpolation. And instead of explaining its meaning to you theoretically, let me practically show its usage to you in the graph editor. So let's say I press A to select all the points in the curve, including all these handles. Then I right click and go to interpolation mode. Here in this mode we get several options like Bezier, linear, constant, and by default for any curve, Bezier is selected. So if I select this, then you won't notice any difference because this is the default mode. But if I right click and go to interpolation mode again, or else if I use the shortcut, which is to press T, then this interpolation mode window will appear, from where if I select the linear option, then you will notice a change in the curve. You can see that the curve has now changed to these sharp straight lines, which also means that if I now play the animation, then the speed of the sphere moving up will be same throughout. Also, I want you to observe and notice the difference between the speeds of the sphere moving up in both of these animations, that is the old one which had the Bezier curve and this new one with the linear curve. You can see that in the default Bezier curve, the speed is not uniform or constant throughout, but it keeps on changing, and we have discussed this in detail previously. But on the right side, when we are using the linear interpolation type, the speeds are constant throughout. Now in a very similar way, if I press T again while being in the graph editor for the interpolation mode window and change this from linear to constant, then this gives us a new graph or a curve that's different from the previous one, and the animation that we'll get will basically look like an on and off animation. Like initially for the first few frames, like till the frame number 50, the ball will be at the rest position or default position, meaning at 1 meters in the z-axis, but then instantly it will reach at z equal to 7 meters starting from the frame 50. Then again at the frame number 100, it will return back to the default 1 meters, and then it will be like this for the rest of the animation. So let's see how this looks by taking the pointer back to the frame number 1 and pressing the space bar to play the animation. So first the ball moves up at frame number 50 and then it stays there for some time and then it returns down at the frame number 100. Now let's say you want this ball or the UV sphere to move up and down, but in such a way that it looks as if it's bouncing. So to do this thing, let's first look at the manual way, and then we'll take a look at a very interesting way that will allow you to create that animation of the UV sphere bouncing up and down with just a single click. So first for the manual method, what I'll do is to delete all these keyframes first by pressing X and selecting delete keyframes. Then I'll go to the viewport, and with the sphere selected at the frame number 1 with the Z location set to 1 meters, I'll press the I key to add a keyframe. Then I'll take this pointer to around frame number 30 because I don't want the animation to be very long, otherwise the bouncing will look unrealistic. So at this frame I want the UV sphere to be at the top, so I'll move this up in the z-axis by let's say 7 meters. So the final location in the z-axis will be 8 meters because already it was 1 meters above the origin. Then I'll press I to insert another keyframe and then at the frame number 60, I want it to return back to the default position, which is 1 meters above origin. So I'll go to the z-axis location type 1 and press enter and press I to insert a keyframe. This will give us the default curve. And now to create the bouncing effect, I simply have to select these 2 points together, that is the one in the middle and the one at the end. Then we need to create their duplicates and we'll place them for the future frames to create the bouncing effect. So to create their duplicates, press Shift D, and if I move them like this, then once it crosses the timeline pointer, or basically the frame number 60, we'll be able to see them on the other side. And to ensure that you don't move them up and down, you can click the X key, and after that I'll just ensure that the middle pointer stays at the frame number 80 and then left click to confirm. Now you might have noticed that in the first bounce, I made the top part appear at the frame number 30, so the total time duration was 60 frames. But then for the second bounce, I have set the top position just after 20 frames, which means that the ending frame should also appear 20 frames after 80. So with this point selected, I'll press G and X and move it at the frame number 100 and then left click. Now the curve isn't perfectly ready, but I think that we should take a look at how the bouncing animation looks right now. So I'll take the pointer to the initial frame and press the space bar. So the ball reaches the top, then it comes down at the frame number 60, and then again the same thing happens, but with a much faster speed. Now the only issue here is that the second time the ball moves up, it reaches the same height as the first time. But in reality, when a ball bounces, then the second time it moves up, its maximum height will be less than the first time. So what I'll do is to select this pointer at the frame number 80, press G and move it down to something like 5 meters, and you can confirm this thing with these values on the left side, or else you can go to object properties and set the z-axis location to exact 5 and press I to insert a keyframe. Now if I take the pointer back to the frame number 1 and press the spacebar, then this is how the animation looks. The ball moves up and down, and in the second time the maximum height is reduced and the speed is increased. But even right now it doesn't look realistic, which is happening because of inconsistent speeds. And I have explained this to you before that to fix this thing, you just have to change the position or the rotation or the scaling of these keyframe pointers or their handles. So what I'm going to do is to select this particular handle, which is on the right side of the first point, then press R to rotate it like this to make the curve more steep. Then I'll select this point, press S to scale it up, and this will make the ball stay at the top position for a little while, making the animation look better and realistic. Then for this third pointer, I'll select this left handle, press R to make this steep. Also I'll press S to scale this slightly down. Then if I select this pointer on the right side and try to make any changes, you will notice that it's also affecting the curve on the left side. And to avoid this thing, I have to change the handle type to free. So we have learned to do this before as well. You just have to press the V key, then you can set the handle type to free, and then if I press R to rotate it like this will give us a steep curve. Now I'll select this point, press S to scale this up just like before, then select this one, press R to rotate it like this. And this time I guess that the animation should look more or less perfect. So let's press the space bar to see the animation. And this is how it looks. The ball moves up, down, and then it repeats the motion, and this was how you can manually create the bouncing effect. But in this manual method, there are two problems. First problem is the accuracy, because you can keep on tweaking these curves as long as you want, but even in the end, it might be possible that you cannot get perfect results. Like, I still think that in the end, the speed of the ball was a little fast when it went down. So even though I can again make the adjustments and get the perfect results, but it's still very time consuming. And the second problem is that when you're working with complex animations, you won't be having the time to animate each and everything manually. There you will feel the need of having some tools that you can use to quickly create effects like bouncing a ball or other similar things. And to see how we can automatically do this thing with a tool, I'll first select these 2 points over here, press X to delete the keyframes, then select this point or the keyframe, press T to open the interpolation menu, and in the dynamic effects, you have the option to create a bounce effect. So I'll select this, and we notice that the curve will change. But right now if I take the pointer to the frame number 1 and press the spacebar, then first the ball will move up, but after that point, the speed with which it comes down and bounces will be very fast. And to fix this thing, I'll select the second pointer over here, press G, X and move it to somewhere around the frame number 90 so that we can have a slightly long animation, or else I think that I should keep it to frame number 100 and then replay the animation. So first the ball moves up, reaches the top, then it returns down, and again bounces a few times with lesser maximum height each time to create a bouncing effect. Now in a very similar way, if I again press T, then you can see that we have some more dynamic effects like back, and if I try to play this animation, then the ball moves up and then it gives us this weird result of slowing down, and before ending the animation it reaches the bottom and comes slightly above. In a similar way, we also have one more dynamic effect which is elastic. So let's see this one also, where the ball moves up and then it instantly reaches down and shows a kind of vibrating effect at the default position. So the one that is most useful is the bounce effect, because you can use it to animate a ball or anything which falls down and you want it to have a little elasticity and a bouncing effect. Other than this, you also have some options like sinusoidal, quadratic, and all these are basically mathematical curves that are very accurate and smooth. So you can try all of these if you want, depending on what you're trying to create. Like I can select this pointer, press T, and I can select the quadratic curve to get a curve like this. Similarly, we have sinusoidal curve, which is basically the curve for sine operation. We have exponential and other things. But again, it will depend on what exactly you're trying to create. But all this information that you now have after this module will help you to work with the graph editor without being afraid that you don't know how to use these curves, what these handles are, what does interpolation do, how you can manipulate the curve, and also at the same time how you can create smoother animations. Now let's take a step ahead in the module number 3 and understand one more advanced concept in the graph editor, which is the use of modifiers. So to see how all that works, I'll first have to unhide all these graphs other than the Z location, then press A to select all, and I'll delete all these keyframes. Then I'll take the pointer to the frame number 1, go to the object properties and change the Z-axis location to 0. And this time I'll be taking the example of the UV sphere moving in the X-axis. So for the first frame, I'll press I to insert a keyframe, then take the pointer to the frame number 40, and let's say I move this object in the X-axis by 8 meters. So at the frame number 40, I'll press the I key to insert another keyframe, and this will give us a very simple animation, and we'll be using this particular animation to understand the use of modifiers. So here on this right side, you see we have a panel which offers some options like F-curve, modifiers, and view. And if you're not able to see this panel or this sidebar, then you just have to keep the cursor in the graph editor and press the N key to toggle this sidebar. Then go to the modifiers, and in the add modifier you will find a list of all these modifiers, but out of all these we have two which are the most important. The first one is the cycles and the second is the noise. So let's first select the cycles and see what it does. So as the name suggests, it basically creates a cycle or repetitions of the curve or the animation throughout the timeline editor. You can control how many repetitions of the cycles you want by going to the after mode count, and if I change this to 2, then the animation or the curve will repeat itself 2 times, and you can control this number to anything, but if you keep it to 0, then it will continue to repeat itself infinite times. To see how it looks, I'll take the pointer to the frame number 1 and press the space bar. So the ball moves in the x-axis, and after reaching the maximum point, it will return back to origin and form a loop animation. So this thing will be useful for you if you make any animation in the scene and you want it to appear simultaneously by repeating itself. So you don't need to copy paste the keyframes each and every time. You can just use the cycles modifier and it will allow you to make the necessary repetitions. Apart from this, we also have one more modifier, which is the noise modifier. So to see how it works, I'll first remove the cycles modifier by clicking on this cross icon, then go to add modifier and select noise. Now what this does is that it basically adds noise to the curve which is selected, but right now I think that all of the keyframes were selected, so it is giving us some weird results. So I'll press Ctrl Z to undo this, and then I'll select only the x-axis curve, then go to modifiers and select the noise modifier, and now we see that some noise is added to this curve, meaning that if some value was going to be 1 meters, it will be 1.0 something meters. Similarly, if the value at a keyframe was going to be 1.5, then instead of the exact value, it will be something below or above it depending on this noise that is added here. And to see how this appears, I'll go to the frame number 1 and press the space bar. We'll be able to see some random zigzag movement in the x-axis, but the net result will be the object moving towards the right side. Now you might be thinking that exactly where is this thing useful? So as an example, you can see these two videos where in the first one, the liquid flows on the monkey object, but the liquid looks very static and very lifeless. but the second time I have applied some noise to the surface tension of the liquid, which is making the liquid look more alive and interactive, as it's not just in a constant path moving down, but it's slightly changing its position and the weight falls down because of the noise modifier. So this was all you need to know about the graph editor in Blender, different animation tools, how interpolation works, how you can smooth the graph, usage of some modifiers, the keyframe handle types and how you can control them, the non-linear animation editor, and all these together give you the understanding of advanced animation concepts. Welcome to the module number 4 of the Blender 3D animation course. Till now we have understood the basics of Blender as a software, like we covered the modeling tools, we understood the interface of Blender, then coming to animation, we got to know about its meaning, the basics of animation like the keyframes, frame rate, timeline, and then we covered the advanced animation concepts including the graph editor, curves, and now in this module we'll start with the 12 principles of animation, and we'll not just discuss them theoretically, but our purpose will be to understand them practically with the help of an example in the Blender software, as we'll create an animation of a bouncing basketball using which we'll understand the principles of animation. Now before we start with the practical part, let's first see where these 12 basic principles of animation come from. So basically, these 12 principles of animation that we're talking about were introduced by two animators of Disney in one of their books, The Illusion of Life Disney Animation. This book is so well known that it's even referred to as the Bible of Animation, and its principles are even used by animation studios. Now, during the time when these 12 principles were introduced, only hand-drawn animation used to be popular, that is the 2D animation, and that too non-digital. But now we see both digital 2D animation as well as 3D animation. And in all these cases, these 12 principles of animation do apply perfectly even today. Now to understand this concept practically, I have opened a new Blender file, and what we're gonna do is we'll create this basketball bounce animation. First we'll model the ball, set up the scene, and then while animating it, we'll understand each of the 12 principles one by one in detail, and we'll use them in the animation that we are creating. So to begin with, let's first start with the modeling of the basketball in the scene. So the shape of a basketball resembles to that of a UV sphere. So the base object that we're going to use will be the UV sphere in this case. But before adding it, I'll press A to select all, X to delete. Now press Shift A to open the add menu, then go to mesh and select the UV sphere. Now if you don't do anything else right now, then just after adding an object, Blender gives you an option or a menu to control the number of segments and other basic properties related to the object. And to see that menu, you basically have to see this bottom left corner where you see add UV sphere written, and if I left click on this, then this menu will expand, and from here you can control the number of segments, rings, radius, alignment, location, and the rotation. And for now I think that the number of segments should be set to 16 because we don't want it to have so many vertices, and the rings are also fine at 16, and the remaining things can be adjusted later on also, like the location, rotation, and the radius, or basically the scaling. But for controlling the number of segments and rings for this UV sphere, the best approach is to use this menu after adding the object. Now you can see this image of the top part of the basketball that we are trying to create, and to create a similar thing from this UV sphere, we'll first have to go to the edit mode, and we'll have to make some changes in this top part because currently we have a single vertex which is being connected to this complete outer ring of vertices. So what I'm going to do is, with this top vertex selected, press X to delete and select delete vertices. Then go to the top view by pressing 7 on the numpad, and now we have to select this entire outer loop of vertices. And one of the ways can be to hold the shift key and left click to select each of these, but a better way will be to hold the alt key and left click anywhere on this loop of vertices, and this will select the entire loop. Now we want to connect these vertices in a certain way that fills the faces with the vertices on the opposite side being connected to each other. And to do this thing easily, we have to deselect two vertices, that is this one and the one at the bottom. So hold on the control key and then select this vertex to deselect, and let's do the same thing with the bottom one. Now if I press Ctrl F, then this will open the face menu that you can use for changing the faces of your object, but what we are going to select is the grid fill. The grid fill tool basically fills the selected region with a quad grid. Like you can see over here that all the faces that are formed are basically quads, and for those of you who don't know what quads are, then you can understand it in this way, that any face that is made of 4 vertices or 4 points that you can see in this geometry are known as quads. And in Blender, or in fact any 3D software, it is always suggested to use the quad faces as far as possible because they're generally easier to work with, especially if you have to shade it smooth or you have to work on the texturing part. And overall also, the geometry looks smooth and consistent if it is made with quad faces. Now another thing to notice here is that in the face menu that we can see by pressing Ctrl F, you have two fill related options. The first one is the normal fill and the second one is grid fill. The first one will simply fill the edge loops and form a face, and it might not result in the quad faces. To confirm this thing, I'll press Ctrl Z to undo this grid fill, then press Ctrl F and select fill. But it's not working right now because it requires a complete loop to be selected. So I'll hold Alt and left click here to select this complete loop, then press Ctrl F again and select fill. Now you can see that even though it creates a closed face, it doesn't really have a good topology or basically the arrangement of vertices, and on top of that, the faces that are formed here are not quad faces. Instead, each of these faces is formed with 3 vertices, which means that these are tri-faces, and in terms of geometry or topology, the tri-faces are not the first preference or the best thing you can have in your model. So now I think that I should undo this, then go to the top view, select these 2 vertices on the top and the bottom, then press Ctrl F and select grid fill. Now we are done with the top part of the basketball, and similarly for the bottom part, I'll select this vertex in the middle, then press X to delete and select delete vertices. Select the entire loop of vertices by Alt and left clicking like this. Then to see the bottom view, you can use the shortcut which is to press Ctrl and 7 on the numpad. Let's zoom in, deselect these 2 vertices, press Ctrl F and select grid fill. Now if you look closely at the overall geometry of this UV sphere, you will realize that it's not really very smooth and uniform. Like specifically in this area, if you notice closely, the geometry can be made a little more smooth. For example, this loop of vertices that is coming from here can be made to appear curved, something like this, as it joins the other end. Similarly with this one also, we can make it look like this, and then we can do the same for the lower parts also. And this thing will basically make the loop of vertices look slightly curved, and the overall geometry will look better with some smoothness added to it. So what I'll do is to select these vertices over here in the middle, then I'll press S to scale these down and left click. And what you can do is you can go to this resize menu over here on the bottom left corner, and in the scale value you can set a fixed number like 0.65, so that later on when we do the same thing for the other side also, we can simply use these exact values. So for the other side, I'll change the angle, then select these vertices, and yes, you can even select all the vertices between 2 points by first selecting one of them and then holding the control key and selecting the other vertex. Now press S to scale these down, type 0.65 and press enter. Now if I press the tab key to enter the object mode and take a look at this UV sphere, then you will notice that its top and the bottom part are very flat and not rounded or curved, especially if I go to the front view by pressing 1 on the numpad, or if I go to the side view by pressing 3 on the numpad, then this thing will be visible in a much better way. Like the sides are properly curved, but the top part and the bottom are completely flat. And in order to fix this thing, we'll go to the edit mode again, and with these vertices selected on the top, let's go to the front view, let's zoom in properly, and we'll push them slightly up in the Z axis by pressing G and Z. Let's also go to the side view to see this properly. I think we should slightly push it down to make this appear more smooth like this. Now in a similar way, let's select the same vertices on the bottom side. So I'll select these vertices over here. Then again go to the side view, zoom in to see everything properly. Press G then Z and push them down. Finally left click. And once it is done, we'll have a nice looking ball ready in the scene. Now this thing looks very simple right now. And to make it actually look like a basketball, we'll be using some extrusion effect on some of these loop of vertices in the edit mode. But before that, in order to make this look more smooth and not have these flat faces, I'll right click and select shade auto smooth. Then again, let's go to the edit mode and press 7 on the numpad to go to the top view. And now what we are going to do is that we'll select some of the vertices here. For example, with the Alt key holded, if I left click here, then this loop of vertices will get selected. And now along with the Alt key, I'll also hold the Shift key so that I can select multiple loops together. So now I'll left click here to select this loop, then I'll select this one and this one. So we have selected 1 out of every 2 loops on the basketball, and we'll use these to create the pattern that you see on the basketball. So to create that pattern, we'll have to add an extrusion effect, but before that, I'll press Ctrl B to add some bevel. But if I take the cursor far away, then you will see that the geometry will begin to distort. So to avoid this thing, you can press C before you finalize the bevel, and then the clamp mode will be enabled, and you can use it to accurately adjust everything. And you can even use the scroll wheel to increase or decrease the number of loop cuts. or basically the segments. Then if I left click, then this will get finalized. But before you do anything else, this bevel menu will appear here on the bottom left corner, using which you can make any final adjustments that you want, like you can round off the figures or set the number of segments. Now after this thing, we are going to use these strips that we have created in order to create the pattern on the basketball. So first of all, let's enter the face select mode by pressing 3 on the numpad, then deselect everything by left clicking somewhere else in the 3D viewport, and after that let's go to the top view so that we can see everything properly. And what I'll do is to hold the Alt and the Shift key, then left click here to select this face loop and the one on its right side. Then similarly I'll select the two over here, do the same thing with this middle one, let's select this one also, and at last I'll select these and this one as well. So if you notice closely, we basically selected the two face loops out of the 4 strips that we created using the bevel tool. And now with all these selected, if I click S to scale these down, then you can see that it's giving us this pattern that we wanted. We won't scale it down too much. I think that this much should be fine. Or maybe you can change these values to something like 0.975 to have a little more effect. And yes, if you don't want to use this scaling down method, then another way to do the same thing will be to press Alt E and use the extrude faces along normals. But for now we have got this result that we wanted. Now let's go to the object mode, and the basketball is almost ready. But if you actually see this, then it doesn't really look very realistic because it's very hard and low resolution. And the reason why it's happening is that we don't have a lot of vertices or geometry in this 3D model. And to solve this issue, Blender gives us a modifier known as the subdivision surface modifier. To use it, just go to the modify properties. Here you will see the smooth by angle modifier already added, because previously you right click and used shade auto smooth here. Now let's go to the modify properties and click on add modifier. Then in the generate category, you will find the subdivision surface modifier. And as soon as you select it, you will see that the basketball looks much more realistic than before. We have the smoothness and a soft look which adds to the realism. Here in the levels viewport, if I set this to 2, then it will look much better than before. And this levels viewport or the render value will basically control how much subdivision will be applied to the object. If both of these values are same, that is 2 in this case, then you will see the subdivision level set to 2 in both the 3D viewport and also when you finally render the scene. But if you want, you can increase the render levels to 3 and keep the levels viewport to the value of 2, because then it would mean that you won't be working with such a high poly mesh, which might make the things a little bit slow in some of the cases, but the render will still be of high quality. But since this is not a very complex shape, so you can even consider setting the levels viewport to 3 in this case. And I think that this is giving the basketball a very nice appearance. Now what you're seeing right now is in the solid mode. Like you have 4 options over here. The first one is the wireframe mode that displays the object as wire edges. The second one is the solid mode where it won't display any color and every object appears with this white color only. Then the third one is the material preview mode, which as the name suggests allows you to preview how your materials will look, but still it won't be the same as the final output. It only gives you an idea about how the material can look. And then you have the fourth one, which is the render preview mode. This will show you how your object will actually look once it is finally rendered in the form of an image or a video. Now the reason why you are not able to see anything in the render preview mode is that we don't have any lights in the scene. You can check this in the scene collection that we just have the UV sphere, which we are going to use as the basketball. But if I now press Shift A, then go to light and select a point light, let's say, then I'll move it up in the Z axis, you'll begin to see some part of the basketball being visible, and currently the power of the light is very low. So to increase this power, you can just go to the object data properties in the properties panel and increase the power from here. Then you can press GX and move this over here, create its duplicate and move it in the X axis like this, and then you can continue doing this thing, like you can create some more duplicates, rotate them and bring them in the Y axis like this. But for now I think that instead of doing all this, a much better way will be to get some fake lighting in the scene, which we can use to set the colors and to see how the object will finally appear. So to do this thing, you have to click on this drop down over here and turn off the scene lights and the scene world. This basically gives us a fake lighting and fake world around, which you can control by changing the environments from here, which will also change the way how the lights appear. And for now I think that we should go with the default one only, and this is how the basketball appears. Now to give this ball some colors, I'll first select it, then go to the material properties and create a new material. Now in this material you will find several settings, out of which only a few are useful in most of the cases. Like the most important important one is the base color, which as the name suggests will allow you to set the color for the object. So let's say I want the color to be something like orange. So in this color wheel I can set that particular color that I want. You can just left click and drag the cursor to select any color, and then if I move the cursor away, then the color wheel disappears. Now once you're done with this, the next thing that we'll work on is these details or the loops that we have scaled down to create this pattern. We'll give this some black color, but before we do that, there's one more thing, which is to set the render engine. So I'll first go to the render properties, and in the render engine you will see that EV is selected by default. But for much better visuals and to get a cinematic look, it is mostly suggested to go for cycles because it's good for photorealism and accurate lighting, reflections, because it uses ray tracing to give accurate and better looking results. So I'll change the render engine to cycles, and you can see that now the lighting looks a lot better than before, and the object is also looking a bit more realistic as it did with the render engine set to EV. Another very important thing is to set the device here as the GPU, because for most of you, you must be having a good graphic card in your PC, so you won't need the CPU as your device. And there's one more thing to ensure, that in the preference settings, the GPU that you're having in your PC is enabled for Blender. So to confirm this thing, just go to the edit menu on the top, select preferences, and here you will find several settings like the interface, viewports, lights, but the one that we are looking for is the system preferences. In this, you have the option to set the cycles render devices, and if you're using an RTX graphic card like the 30 series, 40 series or the 50 series, then you should select optics here and make sure that both of these options are checked. And once you make any changes in this preference settings, do ensure to click here and save preferences. Now let's close this window and let's get back to applying the material to this UV sphere. So with this sphere selected, let's again go to the material properties, and we now have to create a new material which will be black colored for this pattern. And to create a new material, we just have to click on this plus icon. This will create a new material slot, and to add a material in this slot, click on the new button, and then in the base color we have to change this to black. So we'll use this brightness slider on the right side and reduce the brightness, and now we have to select that on which particular area we want this material.001 to be applied. So to select that area, go to the edit mode, and currently I have all these faces selected on which I want to apply this black material. So I'll directly click the assign button, and as soon as I do this thing, if I go to the object mode, we'll see that we have the black color material applied except this particular part which might have been deselected due to some error. Let's also check if something else is missing, and yes, we see the same error over here also. So what I'll do is that if I go to the edit mode, then zoom in, and here I'll see that the geometry now looks very complicated, which is because of the subdivision surface modifier. So to remove its effect temporarily, you can just click on this icon which will remove its display while being in the edit mode. Then with the shift key holded, select these two faces, and in a similar way, let's change the angle to the top, then zoom in, select these two faces that we missed before, then go to the material properties and click on the assign button. Let's go back to the object mode, and this is how it appears now. Currently this basketball is having a very simple look, but we can make it even more interesting by adding some texture or some 3D effect to its material. So what we have to do is that we'll need to make some changes in this orange color material which is for the body of the basketball, and to work with the textures and other things, we need to open the shader editor. So we'll convert this window which is the timeline editor into the shader editor for our usage. Let's click on this icon, and from this list of all the windows that you can change this into, select the shader editor. Here you will have the same options that you had in the material properties on this right hand side, but when you're working with multiple textures and different effects, it's always better to use the nodes because you can easily understand the workflow. So if I press Shift A, then this will open the add menu, and in this, if I go to texture, then this will display the list of all the textures. And since this is not a materials course, so we won't be going into each one in detail, but the one that we have to use is the Warner texture. So let's select this by left clicking and place it over here. After this, since we're going to use this node to create a 3D effect, so we'll have to use another node to create that effect, which is known as the bump node. So press Shift A, then go to vector and select bump. Let's place it over here, then take the normal socket and connect it to the normal of the principal BSDF, and then this bump node will need the input from the Warner texture. So I'll take the distance socket and we'll connect it to the height in the bump node, and this gives us some weird results. So to fix this, we'll have to change the parameters in the Warner texture and the bump node. The first thing that we can change is the scaling in the Warner texture. Like we want a highly scaled texture. Let's say we can set the scale value to 20, and we can also work on the strength of the bump, but we'll look into this later. But I'll turn on invert option so that we can have that bump effect that we need. Other than this, I can control the randomness, and I think that we should keep it very low or maybe 0. But right now it's covering the entire area, and that too in the cubes form. So it looks very weird, and to fix this thing we'll be using the color ramp node. So press shift A, then go to converter and select the color ramp. Let's place it after the Warner texture, and then by using these pointers we can control the way how the texture will appear. So I think that I should place this one somewhere over here and this one over here. Also I think that we should increase the scaling. So let's keep this to 60 to get a highly scaled texture, and let's keep changing the position of these pointers till we get the perfect results. Also I think that we need to add the input node and the vector mapping node so that the texture will be properly applied. So while being in the shade editor, press shift A, then go to input and select the texture coordinate. Let's place this over here, then press shift A again, go to vector and select mapping. Let's place this one over here. Then I'll take the vector socket in the output and connect it to the vector of the Warner texture. Then for the input, I'll first take the object socket and connect it to the vector, and this is how it appears. If you want, you can try other things also like UV or the normal or maybe generated, but currently I think that the object one looks fine. Other than this, I think that I should increase the scaling to let's say 90 so that the texture will be even more detailed, and I should also move this black pointer slightly towards the left and the white one over here, and this is how the basketball looks. We have this beautiful texture all over the basketball properly applied, which is giving it a very realistic and a decent look. Apart from this, I think that we can give this an even better appearance by increasing the scale to something very high. Let's say I change this to 200, then the scale will be very high, but in that case I'll be going for the UV socket in the texture coordinate, and this is how the texture looks. Let's change the scaling to 250 this time, and let's also increase a little bit of randomness so that the entire detailing doesn't look exactly the same. So let's keep this to 0.3, and this is how it appears. I think it looks much better now as compared to the one that we were having before. Now the next thing that we'll do is to go to the side view or the front view. Let's zoom out, change this to the solid mode, and we'll now be adding a plane on which this object or the ball will fall. So let's first move this up in the z-axis by 1 meters, then press shift A, go to mesh and add a plane. Let's change the angle, go to the edit mode, and let's scale this up and left click to finalize. Now to give this plane some material or some color, let's go to the render preview mode, and currently it is white colored. So to give this some material, I'll directly go to the shader editor this time, then click on the new button, and currently we're not able to see the nodes. So one of the ways can be to use the middle mouse button and move the cursor around till you find the nodes, or else a better method is to use the numpad period key in order to get the nodes in just one click. Now in the material.002, which is for the plane, I'll first go to the base color and reduce the brightness because I want the material color to be dark. Then I'll change the color to something like the blue color. You can set any color that you like, it's totally up to you, but I like this color for the plane, so I'm going for this one. Also I think that I can slightly increase the roughness value so that there will be lesser reflections when we later on work with the proper lighting system. And now I think that there's nothing else left in setting up the scene. Now to actually begin with the principles of animation and understanding it with an example of this ball bouncing up and down, let's first switch to the solid mode, and let's also change this window, which is the shader editor right now, into the timeline editor. So I'll click here and select timeline. Let's take the pointer back to the frame number 1. And now the first principle of animation on our list is timing. So timing refers to the number of drawings of frames for any given action, which obviously controls the speed of the action. Also, correct timing makes the objects appear to obey the laws of physics. Now this was the theory of the first principle, but to actually see it practically, let's say I keep this UV sphere or the ball about 5 meters above the initial point. Now I want this to come down and touch this plane, basically have a fall down or a bouncing effect, and for this a very simple thing that I can do is to insert the keyframes. So let's go to the object properties here, and in the z-axis location I need to insert a keyframe. So you can either press the I key to insert a keyframe, but if you want the keyframe to be added only for this particular parameter, then with the cursor over the z location value, I'll right click and insert a single keyframe. And now you will want this ball to fall down and touch the ground, but before you do that, the first principle of animation that we discussed, that is the timing, will come into play. Like you need to ask yourself how long the animation will be, because see, let's say I make it to 60 frames. And at this particular frame, I want this ball to touch the ground. So I'll go to the Z-axis location and change this to 1 meters. Then to insert a keyframe here, I'll right click and insert a single keyframe. By doing this, the total length of our animation where the ball will move downwards is 60 frames. But to know if it's actually correct, we'll have to play the animation. So if I press the spacebar to play the animation, you will see that the speed of the ball is really very slow. And if you remember, I just told you that correct timing is important so that the objects appear to obey the laws of physics. And in real life, you won't actually see any object moving down with such a slow speed. And this also means that we have to fix this thing right now. And for a correct timing of the animation, we can basically do two things. The first one is obviously to reduce the number of frames in which the animation will play. For example, with this keyframe selected, if I press G to move it and place it, let's say at the frame number 30, and then if I play the animation this time, then it will be much faster than before. But this is not the only way by which you can solve this thing, because you also have another method, which is to control the frame rate. So if I press Ctrl Z to undo this, so that the animation will again be of 60 frames, and then if I go to the output properties here and change the frame rate from its default value of 24 frames per second to, let's say, 60 frames per second, then this will mean that our animation will now have a total of 60 frames in a single second. And to see the difference, and press the spacebar. This time, because of a higher frame rate, the speed of animation will be a lot faster than before. Now, just because you can use either of the two methods, it does not mean that both of them are exactly the same. Because if you change the frame rate, then it will mean that in a single second you are able to see a much higher number of frames, which up to a certain extent will obviously improve the quality of the animation, especially if you have too much movement in the animation. Because if I just zoom in here and show you how little is the change between each keyframe, or basically the location of the ball between each keyframe in the animation with 60 fps. So yes, the gap is very less, and so you will see better quality animation, but along with that you will have to render more frames, and so it will obviously take more time to render the animation. In addition to that, in most of the cases people prefer to go for either 24 fps or maximum 30 fps, although there is no hard and fast rule for this. But this is what most of the people like to go for. So if you're going for a lower frame rate and you need to speed up the animation, then obviously you will have to reduce the number of frames by moving the keyframe like this. And now if I play the animation at 30 fps, then this is how it looks. Now after this, let's see what exactly is the second principle. So the second principle on our list is anticipation. Anticipation is basically preparing the audience for an action that will happen in the future, and it makes the action appear more realistic. You can understand this easily with the help of this example of the Tom and Jerry cartoon, where in this particular scene you can see that Tom is holding a tomato in his hand, and even though we have not seen what will happen after this particular frame, we as the audience do get an idea that he's going to throw it. And why is that happening? It's happening because of the simple reason that the animators used a small action, that was picking up the tomato and running with it in his hand, in order to indicate that a major action is about to occur, that is throwing of the tomato. Now to see something similar in this animation that we are preparing, what we have to do first is to question ourselves that how we can tell the audience that this ball is going to fall down before it actually begins to do it. So one of the ways that I can think right now is that before it falls down, we can maybe show it like it first moves up and then falls down. But it will start from this particular point only. To make this practically happen, I'll go to the front view by pressing 1 on the numpad, and for the first keyframe I think that this position looks perfectly fine. But if I now take the pointer to, let's say, frame number 5, and I want that it should have the z-axis location of, let's say, 7 meters at this point. So I'll type 7 here and right click, insert single keyframe. Now initially the object was at 6 meters in the z-axis, and then at the frame number 1 it goes slightly above to 7 meters. And now if I play the animation by pressing the spacebar, then initially we notice that the ball first goes up and then falls down. But that action appears to be very quick. So to solve this thing, I think there should be more gap between the first keyframe and the one that we have currently added at the 5th. So I'll press G to move this keyframe. Let's say I keep this to the frame number 10. And I also think that I should move this keyframe and make the animation longer. Let's say till the 40th keyframe. Now one thing that you might have noticed right now is the use of first principle, which is timing. When we felt the need to make the animation longer, I actually moved this keyframe from the frame number 30 to 40, increasing the total animation by 10 frames. So now let's replay the animation by pressing the spacebar. And this is how it looks. It's obviously not perfect yet because as soon as it reaches the top at the 10th frame, it begins to move down and does not stay there for very long, but we can fix it later on when we get into the graph editor maybe. But for now, the second principle of animation, which is anticipation, must be clear to you. To summarize this, we basically made it move up first before moving down because we want it to be presented like when you throw something up and it reaches the maximum height, the next thing that is going to happen is that it will fall down. Now the principle number 3 is one of the most important principles of animation, and it is called squash and stretch. It gives a sense of weight and flexibility to the animated object like a ball or a human character. And a very important thing to consider while practicing this principle is that the object's volume should not change when it is squashed or stretched. To understand this principle, you can take the help of this example where you can see these two bouncing balls, and in the first one, we do not have any squash and stretch, so it appears like a plastic ball is being thrown and the overall animation looks very simple and unrealistic. But on the right side, we have the ball animation with the squash and stretch effect, and that effect gives it a natural and a realistic look. And coming back to Blender, let's see how we can apply this principle to this ball in this 3D viewport. So the first thing that we have to do is to set a parent bone for this UV sphere that will allow us to basically rig this ball and apply the squash and stretch effect in an easy way. So to practically do this thing, I have taken the pointer to the frame number 10, or maybe let's take it to frame number 40 when it is touching the plane. Then I'll go to the front view by pressing 1 on the numpad, and now we have to add a bone in the scene for rigging this ball. Now you might be thinking that what exactly is the meaning of rigging, and you don't need to worry about it because we have a separate module for that where we'll be rigging the 3D model of a robot. But for now, to explain it in short, I'll explain rigging like it's a process of creating a digital skeleton inside a 3D model, and it allows the 3D model to be animated. Now to practically understand it, let's add a bone object here. So press Shift A to go to the add menu, and from this list select armature. This will add an object named as armature in the scene collection, and if you want to view it, then I can select this UV sphere and press H to hide, and this object that you see here is the armature object, or basically the bone that we'll use for rigging. Now let's unhide the UV sphere back in the scene. Now to view both the UV sphere and the bone in the scene together, one of the ways can be to press Alt C to turn on the X-ray mode and then select whatever is required, but a better way will be to go to the object properties in the properties panel, then in the viewport display, ensure that the armature is selected and turn on this show in front option. This will allow the visibility of the armature of the bone in the scene even though it's located inside the UV sphere. Now this bone or the armature is not of the correct size because we want it to be of exactly the same size as the ball or the UV sphere. So what I'll do is to go to the edit mode with the armature selected, then select this top part and press G and Z to move it up in the Z axis and left click. Then we'll return back to the object mode, and now we have to create the parent object. But before that, let me first explain you what exactly does parenting mean in Blender, and then we'll take a look at how exactly will we do this thing in the Blender software. So parenting in Blender basically creates a parent-child relationship where we have a child object and a parent object, and the object, which is the child, will inherit the transformations like move, rotate, and scale from the parent object. For example, in this scene, if I somehow make this bone as the parent object and this ball as the child, then this would mean that when I'll move this bone in the x-axis by 5 meters, then this ball will also move in the x-axis by the same distance. Similar will be the case with rotation and the scaling. But yes, this does not mean that the opposite will also be true. That is, if I'll move the ball, then the same transformation would not apply to the bone. Now to actually see it in the 3D viewport, we have to select both the objects in the scene, but in such a way that the child object is selected first and the parent object has to be selected at last. So I'll first left click to select the UV sphere, which is the child object, and then with the shift key holded, I'll select this bone that will be the parent object, and while being in the object mode, if I press Ctrl P, then this will open the parent menu that has several options like object, keep transform, without inverse, then you have some related to the armature deform. So when you're dealing with two simple objects, you can choose these options like object and object keep transform or without inverse. But when you're dealing with armature or bones, you have to select one of these options in the armature deform or the bone or bone relative. In this case, we'll be going for armature deform with automatic weights because we won't be working on weight painting right now because it's a very simple model. So I'll select automatic weights. Now if I select the bone and press G to move it around, then we see that the UV sphere or the ball is also following it. Similarly, if I press R to rotate it or S to scale it up and down, we'll see the same results. But if I now select the ball and try to do the same thing with it, like move it, rotate it, or scale it, then those changes won't apply to the bone object. Now once the painting is done, we'll now use this bone to create that squash and stretch effect on this UV sphere or the ball. So with this bone selected, let's say I press S and Z and scale it up, then this will create the stretching effect, and if I scale it down, then this will create the squash effect. But in reality, it won't be really correct to apply this principle like the way we did, because if you remember, I told you that we need to ensure that the volume of the ball does not change while squashing or stretching. And to ensure this thing, we have to use a constraint in Blender known as the maintain volume constraint. But before using that constraint, I'll first press Ctrl Z to undo all these changes. Then I'll select this bone or the parent object, then click here for the object constraints, add object constraint, and select maintain volume. This will ensure that the bone and its child object, which is the ball, have uniform or same volume no matter if you make any changes in the scaling in any of the three axes. It will automatically make the adjustments depending on the free axis which is selected here. Here I'll be choosing the Z axis as the free axis because while squashing and stretching we'll be changing the Z axis only. So I'll be selecting the Z axis here. And to see what difference it creates, let's go to the front view, and with this bone selected, if I scale this down, then you will notice that it also changes its scale in the x-axis previously when this was not added over here. And if I try to scale this down or up, then the scaling in the x-axis does not change. And yes, similar is the case with the y-axis also. Like if I just scale this down, then the scaling is changing in both x and y axis. By doing this, it basically maintains the volume of the ball that we need for properly applying the third principle of animation. So now let's use this bone to animate this ball with the squash and stretch effect. And for this, we'll first go to the front view by pressing 1 on the numpad. And before we do anything, I think that I should select this ball or the UV sphere and I should delete the existing keyframes. So while being in the timeline editor, I'll press A and X to delete keyframes. Then select the bone. Let's take it to the frame number 1, and at this frame I want this ball to be at the default location only, that is 0 meters in the Z axis for this armature or the bone. To insert a keyframe here, I'll right click and insert single keyframe. Then I want that the total length of this animation where the ball first moves up and then comes down should be around 60 to 70 frames. So what I'll do is I'll go to the end frame and change this to 70, and let's also add the same keyframe that we have on the frame number 1 for the frame number 70. So with this keyframe selected here, press Shift D and place it at the frame number 70. Then I'll take this pointer to somewhere over middle like frame number 35, and at this point we want the ball or the sphere to be on the top position or the maximum height. And for this, with the pointer at the frame number 35, I'll go to the z-axis location value and let's increase it to, let's say, 9 meters and insert a single keyframe. Now we didn't really do anything extra till now. We simply created an animation where the ball first moves up and then comes down, and the total length of the animation is 70 frames. But now let's create the squash and the stretch effect. So at the frame number 1, I won't be adding any stretching or squash effect, but let's say at somewhere around the frame number 20, I want this to be scaled up like this. So I'll scale it up in the Z axis, and then let's insert a keyframe over here. This will mean that at the frame number 1, the scaling is still the same because we have not inserted a keyframe at this particular frame number. So what I'll do is I'll change the Z axis scaling to 1 for the frame number 1, and then at the frame number 20, we have this value of around 1.6. Let me round it off to 1.5, and first I'll delete this keyframe and then insert a single keyframe. Now let's again take the pointer to the frame number 1, and if I play the animation, then this is how it looks. It basically scales up in the z-axis till the frame number 20, and after that, let's say I want this to scale down. So what I'll do is press SZ and scale this down like this, and then I'll insert a keyframe here and let's see how it looks. So the sphere first scales up and then it scales down. And the reason why it doesn't look very realistic is that we have to fix some things in the graph editor like we did before, like the keyframe handles and other things. So we'll work on that later on. But here I think that first we should make the animation better in terms of the keyframes and the scaling values. So at the frame number 35, which is at the maximum height, I think that the scaling in z-axis should be 1 meters. So I'll delete the previous keyframe for the scaling and insert this new one here. Then I'll take the pointer to somewhere around frame 53 or maybe 55, and at this frame number I'll change the z-axis scaling to 1.5, or maybe I think I should keep this to 51 or 52 so that the object is at a proper height. And at this frame I'll change the scaling to 1.5 in the z-axis and insert a keyframe. And now let's view the animation again. So the animation looks very normal, And the problem is that we only have the stretching effect right now. It's not really squashing, and in the end also, we are not yet having it squashed or scaled down in the z-axis. So let's fix all these things. So at the ending frame, I think that the value in z-axis scaling should be 1. So I'll insert a keyframe over here. And initially, I think that for the first few frames, the scaling of the object should not change. So let's say till the frame number 10, I'll keep the scaling in z-axis to 1 and insert a keyframe here. And I also think that I should keep the location value to 0, and let's insert a keyframe here as well, but this will make the animation a little slower, so we also need to adjust the keyframes to keep everything proper. So let's move these keyframes by a few frames, like 3 to 5 frames away from each other, or basically away from their previous position. Like I now have one of the keyframes at frame number 25, then it reaches the top at frame number 40, then it comes down and reaches the middle part at around 55 frame, and then it reaches the bottommost part again at the frame number 70. Let's replay the animation to see how it looks. So now it looks somewhat decent, but even till now we only have the stretching effect and not the squashing effect. So what I'll do is that at the frame number 40, I'll reduce the scaling in the z-axis to, let's say, 0.7 or maybe 0.75, so that it looks natural and not very cartoonish, and then right click to delete the previous keyframe and add a new keyframe. Let's replay the animation one last time. So I think that the scaling in the z-axis is a bit too much, or maybe the distance is very less as it reaches the top after covering the half part. So I think that for the z-axis location at the frame number 40, I'll change this to 12 meters, then delete the previous keyframe and add a new one. Let's again see how the animation looks. So let's take the pointer back and press the space bar. And I think that it looks better than before. The only thing that we can work on now is the graph editor. Like we can manipulate the curves to make the animation look a lot better than it is right now. So I'll change this window to the graph editor, and currently it will show the armature selected because we have selected the bone. And in the object transforms, we have the Z location and the Z scale. So first let's see the Z location. So I'll hide the other one. Let's zoom out to see the curve properly. And this is the curve that we have for the animation. For the first 10 frames, we don't have any change in the z-axis location, so it's a completely flat line. And then we begin to see some animation here as it reaches the top, and then the curves get reversed as the ball moves down. But the problem here is that it does not really stay at the top position for a very long time. Like it just instantly touches the top part and then it begins to come down in a very short time. So to fix this thing, I'll select this pointer here, press S to scale this part up, and now if I take this pointer back and press the spacebar for the animation, then this time the ball will stay up at the maximum height for a longer period of time. Now another thing that we should change is the speed with which it moves up. Like if I take the pointer to the frame number 10 and press the spacebar to play the animation, then the speed is very non-uniform. And to fix this thing, I think we should select this pointer over here or maybe this handle. But right now if I try to press R to rotate it to change the curve, then this will impact the other pointer as well, which is located over here. So I'll press Ctrl Z, and with this handle selected, I'll press V to open the handle type menu and change this to free. Now I'll press R to rotate it slightly like this, and let's do the same thing with this handle also for the last keyframe. So with this selected, I'll press V and free the handle type, press R to rotate it like this. Now let's see how the animation looks. So I'll take the pointer back to the frame number 1 and press the spacebar. And now I think that the overall animation looks somewhat better than before, but still it's not very perfect. Like especially the scaling part in the z-axis is a way too much at some of the frames, which is making it look like a cartoon-like animation. So I think that to fix this, I should change this to the timeline editor. And for the first 10 frames, we had no animation or no change in scaling or location. But I think that at the frame number 10, it should basically scale down in the z-axis before it moves up and reaches the top. So what I'll do is I'll go to the scaling in the z-axis and I'll change this to 0.85 for a little bit of scaling down, then right click and replace the single keyframe. Now at the frame number 1, the object will be at the default rest position. Then as it moves towards the frame number 10, it will get slightly scaled down, and it also gives us that feeling that the ball is about to move up. Then after that, it reaches around frame number 25 where it's somewhere in the middle of the path and it has the maximum scaling in the z-axis. But I think that this z-axis scaling is a bit too much and we should scale it down slightly. But before we do that, I also think of moving this pointer which we added at the frame number 25 to somewhere over the left, basically at that position where we have the z-axis location value, to somewhere around 6 meters or 7 meters. So I'll place this at the frame number 21, and at this one I want the scaling in z-axis to be slightly lower, like 1.25 maybe, because with the scaling in z-axis of 1.5 we are giving it a very cartoonish look. And if you're working on an animation where you have some cartoons, then in that case having such a high scaling value might work. But for a ball animation, I don't think that the scaling value should really be too high, so I'll keep the maximum z scale value to 1.25, then right click to replace the single keyframe. Then the ball will move up like this as it reaches the top at around frame number 40. Then it moves down, and again over here at the frame number 55, the z-axis location is around 9 meters and the scaling in the z-axis is 1.5. So I think that just like we did before, I'll move this keyframe to somewhere around frame number 58, or maybe let's place this at frame number 59. And let's also reduce the z-axis scaling to 1.25, then right click and replace single keyframe. Now with all these changes properly applied, I think we should take a look at how the final result turns out to be. So I'll take the pointer to the frame number 1 and press the space bar. And I think that the animation now looks very smooth and almost perfect. Like, you can tweak some parts of the graph if you feel some part of animation is a bit slow or fast somewhere. So you can figure that out yourself depending on your animation. But I hope that till now you have understood both theoretically as well as practically the first three principles of animation. Now the fourth principle of animation that we're going to discuss is follow through and overlapping. This principle involves adding movement after an action is done in order to create a sense of realism. See, follow through means that the loosely tied parts of a body should continue moving after the character has stopped, and the parts should keep on moving beyond the point where the character stopped, only to be subsequently pulled back towards the center of mass. To understand it with the help of an example, you can take a look at this Tom and Jerry example, where even though the character has stopped, but the upper body of the character is still in motion. It takes the character a few frames to get the upper body in rest. This is an example of follow through. And in fact, any animation where the character has stopped but some parts of his body or anything attached to the body of the character still appears to be in the motion, that would also be a similar example of the follow through principle. Now for the overlapping action, you can define it as the tendency for parts of the body to move at different rate. Now even though these two terms have different definitions, but they both mean almost the same. Like in this example, you can see that the body parts of Tom, who is the main character right now in this animation, his body parts are moving at different rates. That is, the timing of the movement of arm is different from the timing of head, and so is true for other body parts. Now to understand this overall effect in this example of the ball that we have created, I'll take this pointer to the frame number 5, where if you remember, we didn't make any changes as such in the z-axis location, but we did apply an animation in terms of the scaling in z-axis. So you can see that even though the object has not really moved yet, but still we get to see a change in size. This would be easier to understand if you see the animation in this way, that first the ball moves up, reaches the top, and then when it falls down and reaches the bottom, it takes a few frames to basically squash or scale down in the z-axis. Like, I think I should explain it to you again. So I'll increase the ending frame number to 90, then at the frame number 70 we had this, but at the frame 80 I'll again scale it down to, let's say, 0.8 for now, and insert a keyframe here. And now you will see that after the ball reaches the top position where it is slightly squashed, it comes down, it stretches, and then it reaches the bottom at the frame 70. But the animation does not stop there. Even though the ball is no longer in motion, we'll still have this squash effect being visible on the ball. And this is an example of the principle that we were discussing. So I think that ideally I should keep the starting frame at 11, or maybe I should keep it at 10, and ending frame should be 80. And now I'll take a close look at the animation that is created. So this is how it looks. Now the fifth principle of animation that we're discussing in this module is arcs. So most of the natural actions tend to follow an arced trajectory, and this principle should apply to your animation by following implied arcs to achieve realism. By showing the animation along the curved lines or the arcs, we can make the animation look a lot more natural and realistic. To practically see it over here, we'll come back to this animation of the ball But right now, in this entire animation, we only have the ball moving up and down, so there are no curves or anything. But let's say at the frame number 10 where the animation is starting, I set the X location value to 0 meters and add a keyframe, and at the frame number 80, I will increase this X location to, let's say, 6 meters, or maybe let's increase this to something like 15 meters and add another keyframe. Now if I go to the front view and with the pointer over the frame number 10, if I press the spacebar, then here we see that the object will now show three types of changes. The first one is obviously the change in size due to the z-axis scaling. The second one is moving up because of the z location change, and the third one, which is new, is the change in location of the x-axis. But the main thing that we have to see here is that this animation is following a curved path that you can see here. You can see this thing if I slowly play the animation, that the object does follow a curved path, which makes the movement look natural and realistic. This thing not only applies to objects that are bouncing or being thrown up and down, but it also applies to things like the body parts, like moving limb by rotating a joint. But yes, there can be some cases where this principle would not apply. For example, if you're making a robot and you want its arms to have the mechanical movement, so in such cases where you deliberately want the movement to happen in a straight line, only there this arc principle of animation would not apply. So to summarize this quickly, you just have to ensure that in most of the cases, the animation of the object, or basically its movement, follows a curved path for better results. Now the next principle that we're going to discuss is slow in and slow out. It basically means the easing in and out of an action to create a realistic sense of acceleration and deacceleration. To put it in even simpler words, the movement of objects in real world, for example a vehicle or any human, always needs some time to accelerate and slow down. To see it in this example, let's go to the frame number 10, which is in the starting, and let's also go to the front view by pressing 1 on the numpad. And here if I change the frame starting to 1 and then take the pointer back where we actually had the object in the initial or the rest position. And for the first few frames, like till the frame number 10, we don't really see any motion happening, like the object is not moving at all, and this is what we called easing in. Similarly, when the ball drops and lands here, then the ball shouldn't have much movement in the last 10 frames from 70 to 80, but I think due to some error, we forgot to add the X location keyframe at the frame number 70. So let's fix this thing. I'll keep the pointer at the frame number 70 and I'll change this value of x-axis location to 15. And now from the frame number 70 to 80, you will notice that we again do not have much movement. We only have a very slight animation where the ball is basically squashing due to the change in z-axis scaling and nothing other than that. And just like in the beginning we have ease in, this thing at the end that we see is ease out. You can also refer to them as slow in or slow out. And this principle does not only apply to the first few frames, but it also applies to the other frames, but it's just that the effect is more in the initial frames and that effect keep on reducing as the number of frames increase, especially till the middle, and then this effect will again increase after the frame number 40, or basically the frame in the middle. Also, another thing that this principle explains is that there are more pictures near the beginning and the end of the action. Like you can see that even though we have covered a total of 10 frames here, but we can see the animation being happen very precisely, which means that for a very small animation, we have more frames to see it slowly, and the same thing is visible at the end also. Like you can see the animation happening in slow motion due to the higher number of frames. If I see the animation after the 10th frame, then you will notice that the gap between each frame has now increased and we are no longer seeing each and everything of the animation, like the details and how that animation is happening, because lesser pictures are drawn in the middle of the animation. So this entire principle was slow in and slow out, and it can apply to characters when they are sitting down and standing up, or for a bouncing ball like we understood here. Now the next principle on our list is the secondary action. Adding a secondary action to the main action makes the scene more alive and can help to support the main or the primary action. You can understand this principle with the help of this example of the elephant. Like here, the main or the primary action is the movement of the legs of the elephant, but along with that you can see that the tail is moving and the trunk of the elephant is also moving. So these two actions, that is the movement of the tail and the trunk, are the secondary actions that are supporting the movement of legs of elephant, which are the primary action. Now the next principle that we are going to discuss is exaggeration. It means dramatizing an action to give it emphasis. The use of this principle allows the reality to be presented in a wilder and more extreme form. So to explain it with an example, you can take a look at this animation where the main character, which is Tom, is kind of being squashed, but instead of returning back to his original state, his body gets thin like paper, which obviously is not real, but the animators exaggerated the action or the element by making some alterations in the physical features of the character, and it made the overall scene look a lot more alive and interesting. Now, on one hand, exaggeration is a very good thing, especially in cartoons, if you want the viewer to get shocked or surprised, but it is also important to employ a certain level of restraint while applying the exaggeration principle. For example, if a scene has several elements, then there should be a balance in how those elements are exaggerated in relation to each other in order to avoid confusing the viewer. Now, the next principle on our list is staging. It simply means directing attention towards the focal point. To explain it here, we are back in the scene of the bouncing ball, and currently we don't have any camera in the scene. And camera is the thing that records the entire animation, and then from that view of the camera, we get the final render. So let's say to add the camera, I press Shift A, then in the add menu select camera, and by default it gets added at the position of 3D cursor. So if I press 0 on the numpad, which is for the camera view, we'll get to see this view where obviously we won't be able to see anything because it is located at the world origin or in the middle of the scene, and there's not really much that we can see here. So to make changes in the camera view, you first have to click on this lock icon, which will enable the lock camera to view. And now if I use the scroll wheel to zoom out or use the middle mouse button to make any changes in the view, then the camera will adjust to that view and we'll be able to see the changes properly. So let's say I go to the frame number 1, and here I have kept the camera view like this. So the main thing that you can see in this camera view is this ball. Like if I go to the render preview mode by clicking here, and let me also hide this bone. So I'll go to the scene collection and hide the armature. And now the main thing in the scene is the basketball, because that is the object which will be animated. And so it is important to ensure that the attention of the viewer or the audience is directed towards this ball. This can be done by doing two things. The first thing is that you need to make sure that there are no unnecessary objects in the scene which are not really very relevant for the animation. For example, along with this ball animation, if I also include a 3D character walking, then it will confuse the viewer that what exactly is the animation for. Is the viewer watching the animation of the basketball bouncing, or is it a character animation? So the purpose of the animation will get defeated. So you need to take care of this thing. And the thing on the second number is to make sure that the camera captures the object properly. Like let's say I move the camera towards slightly right, and let's just assume that I continue to do this thing for the entire animation. Like when the ball moves up, then I also move the camera up in the z-axis, but still in such a way that the ball is on the left side of the camera. Now this is not a very standard thing to do, because usually the thing that needs the most attention is at the central part. Apart from this, you also have other things to take care of, like there's appropriate lighting and the shadows, the angle and position of the camera. So basically, the summary of this principle is that staging allows to keep the focus on what's actually relevant in the scene and avoiding unnecessary detail. Now moving ahead, the name of the next principle that we're going to discuss is straight ahead action and pose to pose. Now these are two different approaches to the drawing process. Straight ahead action scenes are animated frame by frame from beginning to end. On the other hand, pose to pose involves starting with drawing the keyframes and then filling in the intervals later. Now this principle is more important in the 2D animation, but we can still understand it here just for the sake of covering it. So I'll first go to the solid mode, and let's also unlock the camera to view so that if I make any changes, the camera view won't change. Then I'll unhide the armature or the bone and select it. And for the first type, which is straight ahead action method, let's say I have this ball, and what I want to do is that I want to animate this complete motion of the ball from the frame number 1 to the frame number 80. So one of the ways can be that you first keep the ball over here, insert a keyframe, then for the next frame you will slightly scale it down if you want to do that thing, and then you will insert another keyframe, and you will continue to do the same process of making the change and then adding the keyframe for each and every frame of the animation. But see, this method will still be useful if you're drawing stuff, like if you're into 2D animation, you can draw each and every frame with all the changes in the motion and the speed of the ball, but obviously you won't prefer this method while doing 3D animation. Instead, we use the second method, which is pose to pose, where we add two keyframes. For example, at the frame number 1, we have the object at rest and we have added a keyframe here. And then at the frame number 10, we have the object slightly scaled down in the z-axis, and so we have another keyframe here. So we added two keyframes, and then in this method, you basically have to fill all these intervals, but Blender or any 3D software automatically does it for you. And that was the reason why I told you initially that this principle is more important in 2D animation, because in the 3D animation, you will obviously use the pose to pose method. That is, you will just insert the keyframes at some specific intervals instead of inserting the keyframe for each and every frame. Now the next one, which is solid drawing, is again important for 2D animation and not much for 3D, because it means that the animator should take into account the forms in 3D space or giving them the volume and weight, which also means that the animator should understand the basics of 3D shapes, anatomy, weight, balance, light, shadow, etc. So this principle can be partially useful in Blender but not very much, because everything already is 3D here. So we don't need to take care of the fact that if something looks 3D or not, because most likely it will already look 3D. But yes, one thing to take care of that is still important in 3D is the anatomy part when you're working with characters, or the lighting and the shadow part when you're rendering the scene. Like currently I have disabled the scene lights in the scene world because I have not yet worked with the lighting part in the scene, and if I turn these on, then you can see that we have a very poor lighting setup, but we can fix that later on. And when we do that thing, we'll also get proper shadows and everything else. And now the last principle on our list is appeal. This basically means captivating the audience by creating a simple, clear, and compelling animation. To put it in even simpler words, the animator needs to take care of the fact that the viewer watching the animation should feel that the main character, which can be anything like a human, a robot, or even any object, is real and interesting. Now with this, you have now understood the 12 principles of animation that a lot of people ignore because they think that it's only relevant for drawing or basically for 2D animation, but it's not really true. If you want to study even 3D animation, then it's a must to understand and study the 12 principles of animation and apply them in whatever 3D projects you make. Now before we end this module, let's finally complete this animation that we were creating, and you'll not just complete this and keep it as a Blender file, but you'll also render this in a video format file, and then you can maybe use it to share with someone or add it in your portfolio or just for the purpose of watching. So I'll first go to the solid mode, then I'll hide this bone in the scene, or maybe let's unhide it for now because we might want to see these keyframes that we have added for the animation. And here I think that for a loop animation, we should keep the starting frame as the frame number 10. So I'll change this to 10. Let me play the animation to see if any changes are required or not. So with the cursor over the frame number 10, I'll press the spacebar key to play the animation. And here I think that the animation looks pretty well. Also, I think that I will remove the x-axis location keyframes that we added, because I want the animation to be like it only moves up and down. So I'll just click over here and change this to the graph editor. Then I'll hide all the other parameters except x location. Then we'll see this curve that is denoting the change in the position. I'll select this pointer over here, press G to move it down like this, or maybe I can just select this pointer and press X to delete keyframe, and then select this one and again delete keyframes. Now let's go back to the timeline editor, and with the pointer over the frame number 10, I'll press the spacebar to play the animation. And this is how the final results look. We have the basketball bouncing animation where it moves up and down with a cartoonish effect, and we used it to understand the 12 principles of animation in this module. Now we have to render this animation as well, and for that the first thing that we'll do is to press 0 on the numpad, and we'll now have to set up the camera view. So I click on this icon to lock camera to view, then take the pointer at the frame number 10, let's zoom out like this, and with the shift key hold it, and while pressing the middle mouse button, if I move the cursor around, then I can change my view like this. So I think that I should keep this at somewhere over here like this, and let's also move it slightly in the left. Now the ball will move up, and so at around frame number 15 or maybe 18, we'll feel the need to move up the camera along with the ball. But if you do not want to do that, then you can simply zoom out like this. And another important thing before moving forward is that you can change the resolution of this camera. Currently, if I go to the output properties, then the resolution is 1920 by 1080p, which is basically the landscape mode. But if I set this to 1080p and this one to 1920. That is, if I reverse these values, then this will give us the portrait mode, which is similar to the one that you see in YouTube Shorts and Instagram Reels. So you have to enter these resolutions, that what exactly is the purpose of rendering. Like if you want to upload it as a video form, then you would prefer to go for 1920 pixels in the X resolution and 1080 pixels in the Y resolution, and the opposite if you're going for portrait video like Instagram Reels or YouTube Shorts. So for now I will be going for the portrait mode only, because this animation is also like that, where the ball moves up and down, so we won't require much of the other areas of the animation scene. So at the frame number 10, the ball is over here, that is, it is within the scene, and then it moves up at the frame number 40. And what I'll do is I'll slightly move the camera in the upward direction so that it properly covers everything like this, and I should also move this, or basically rotate it like this, and you can keep adjusting these things till you feel like you're getting the perfect results, or basically the animation looks good. Now let me take the pointer down over here when the ball touches the plane. I think I should zoom in and keep the camera to something like this. Let me again take the pointer at frame number 40 and I'll zoom out like this. Here I think that it won't be really accurate to have the entire animation with a static camera, because it would mean that we are compromising with the quality. So we won't do this thing. We'll zoom in for the first frame like this when the basketball is at the rest position over here, and I'll then select the camera, press I to insert a keyframe, and then we'll keep it at this position till around the frame number 16. So with the camera selected, I'll again press I to insert another keyframe, and then let's say at the frame number 30 we want to move up this camera, so I'll press G, Z and move this up like this, press I to insert another keyframe, and then at the frame number 40 I think that it's still okay to have this view as the camera view, so I'll again press the I key to have the same view for all these frames between 30 and 40. Then after that, even till the frame number 50, I feel that we don't need to change the view. So with this keyframe selected, I'll press G to move it and place it at the frame number 50. But after that, the ball will move downwards with a faster speed. So let's say at the frame number 70, I should move this down in the Z axis like this and press I to insert a keyframe. Now let's see if everything is proper or not. Like you can see that initially the camera view and the ball is at the bottom, but then as the ball begins to move up, the camera will also move up along with the ball, and then it stays here from the frame number 30 to 50, and then the ball and the camera both move down till the frame 70. Also, for more accurate results, what you can do is that you can select any of these keyframes that we added initially, press Shift D to create duplicate, and we'll place this one at the frame number 70 so that the camera view is exactly the same. And this will help you if you're preparing a loop animation, because in that case, even if you have a slight change in the angle, it won't really feel like a complete loop. So now if I go to the starting frame and press spacebar to play the animation, then here we have a proper loop animation, and that too without any breaks or inconsistencies. Now what I'll do is I'll go to the render preview mode, and let's also turn on the scene lights and the scene world, and we are back to the poor lighting setup that we now have to fix. So the first thing that I'll do before doing anything else is to disable this lock camera to view, because if I do not do this thing and I use the middle mouse button to change the view or something, then the camera view will also change. So I'll click on this icon to lock the camera to view, and after this we are having these 4 lights in the scene that are basically of no use to us. So I'll select these 4 in the scene collection and press X to delete, and this will bring complete darkness in our scene. So to fix this, we'll simply go to the world properties, which is in the properties panel over here. Then in the color you will see that the gray color is selected, but if I increase the brightness from here and change this to the white color, then you will notice that we get a very proper lighting here. Another method can obviously be to add the lights in the scene, adjust their positions and their strengths, but for now I think that this shortcut can work in this case, so I'll be going with this method only. And you can even adjust the strength from here, like how bright you want the scene to be. For example, I can keep this to 1.4 if I want the scene to be very bright. And after this, I'll select this plane, press tab to enter the edit mode, and we'll scale this up 5 to 10 times. Now press the tab key to return back to the object mode, and basically this is how the animation will appear. Now before you finally render the scene, a few more things to consider. Like with this plane selected, I'll go to the material properties, and here I've selected a dark purple color as the base color, and I've given this material some slight metallic look, and I've kept the low roughness value for some reflections here. And similarly for the basketball that we created, we have a higher roughness value and zero metallic nature. And other than this, we can go to the shader editor window, and you can see all these things that we have done here. Like we use the Warner texture with the high scaling, We use the color ramp and the bump node, so you can adjust the parameters if you like. But for now, I think that there's nothing else that we need to change here. Everything looks perfectly ready to be rendered. So what we're going to do next is we'll first go to the render properties and ensure that the cycles render engine is selected. Then in the render sampling, I'll go to maximum samples and change this to 1024. And yes, for those of you who don't know, a higher sample count basically means higher quality, but along with that, it will take more time to render as well. So in most of the cases, a sample value of around 100 to 200 works great. So you can keep the sample count to around 100 and disable the denoise option here. Other than this, I'll go to the output properties and we already set the resolution here, so I won't make any other changes. Then in the frame rate, I'll change this to 24. The frame range is also adjusted here from 10 to 80. You can click on this folder icon to select the location where you want to save the video after it is rendered. If you do not choose anything here, then the video will be rendered in a temporary folder which is not at all suggested. So do ensure that you click here and choose the desired location, and in the file format, change this from PNG to the video file format. After this, I don't think that there's anything else that we need to set or change, so we'll finally render the scene. And yes, I'll select this armature bone and hide it in the viewport as well as the render view by clicking on this camera icon here. And to finally render, click on render menu on the top and select render animation. This will open this render window where it displays the frame number, the time that it takes to render, the remaining time and the sample count. So you would have to wait for a few seconds for every frame to render completely, which obviously will depend on your PC specifications. And once it is done, we'll be seeing the final rendered video. Now the rendering of the video is finally completed and you can take a look at this final version. And this brings us to the end of the fourth module of the Blender 3D animation course. Till now we have covered majority of the concepts in Blender 3D animation, including the principles, and from the next module onwards, we'll be starting with our main project, which is this robot animation scene. And while making this project, we'll not just understand the new concepts, but we'll also keep revising whatever we have done till now in this course so that you can combine all these principles and concepts later on for your own projects. Welcome to the module number 5 of the Blender 3D animation course. From this module onwards, you will be creating the main project, which is this robot animation scene. And during this process, we'll not just learn some new things, but we'll also keep revising the concepts that we have covered in the previous modules. Apart from this, in this specific module, we'll be modeling the main character of the animation, which is this robot that you can see, and then we'll also work on its texturing and the materials part. So here I have opened a new Blender file where we'll be modeling the robot. But before we do that, we also need to understand that why exactly are we modeling this robot first? Why are we not modeling the scene or some other assets? So to get this answer, I'll ask you to first take a look of this animation that we are going to create, and then answer the question that in this entire animation that you are seeing, what is that one main thing or the object that is getting all your focus? And I guess for all of you, the answer will be this robot model. Even though we have other objects in the scene, but still the main thing that we have in the scene or the animation is the robot. Now, it's not really necessary that the main thing will always be a character. In this basketball example that we previously discussed, the thing that had our focus was the basketball. So it can vary from case to case that what exactly is the object in focus. It can be a character, it can be a ball or something else. So here we'll first begin with modeling the head of the robot, and for that we'll be using a UV sphere. So with this cube selected, I'll press X to delete it. Now press Shift A, then go to Mesh and select the UV sphere. Currently I think that it has a lot of vertices or basically the segments and rings. So to make it low poly for the character model, I'll go to the Add UV sphere menu on the bottom left corner, and I'll reduce the number of segments to half, like 16, and let me also reduce the number of rings to 8. It looks nice right now, but I think that I can even further reduce this to 14. Let's also reduce the number of rings. 7 looks good, but I think that we should keep it to an even number so that the symmetry will be better. So I have decided to keep the number of segments to 14 and the number of rings to 6. Now I'll rotate it in the x-axis by 90 degrees, and after this what we're going to do is we'll delete some of the faces here in order to create a shape like this that you can see in the image. By deleting the faces, we'll get the back part of the head, and then we later model the front face. So let's go to the front view, then let's go to the edit mode, And currently if I try to select any vertex, then only the one on the front side will get selected and not on the back side. But to solve this issue, what I'll do is to turn on the X-ray mode. So press Alt C, which will turn on the X-ray mode. And now if I select any vertex, then the same vertices will get selected on the opposite side. So here first of all I'll press A to select all, and I think that I should slightly rotate this in the Y axis like this. Then press 3 for the face select mode. Select these faces, 2 on the top and 2 on the bottom symmetrically, and similarly select these faces as well. After this, let's change the angle to see if everything is selected properly or not. And we can see that almost all the front faces are selected, but I think that if I go to the front view again and select these two faces also, which are at the bottom, then we can delete these two along with the other ones. Now to delete all of these, press X and select delete faces. Now for the front part of the face, we need to add a cube object in the scene. So let's return back to the object mode, press Shift A, then go to mesh and select the cube. Then go to the edit mode, press S to scale this down like this. Then press 1 on the numpad, let's move it forward in the X axis, place it over here. Then go to the edit mode, let's scale this down in the x-axis like this and scale it up in the z-axis. We'll make it scaling approximately equal to this open part of the UV sphere that we have created. So I'll scale this up slightly more in the z-axis and then push it down like this. Let's scale this slightly even more, and I think that this much should look good. After this, let's go to the top view by pressing 7 on the numpad, and here I can see that I need to increase the scaling in the y axis so that this part of the head will also be covered. So press SY and scale it up and left click to finalize. Then I'll go to the front view again, and I think that we should scale this down slightly and make this part approximately touch this particular end of the UV sphere. So let's scale it down further, press G and C and move it up like this. Now I'll change the angle, and here we see that it's very much scaled up in the x-axis. So I'll just select this face over here and bring it back by pressing G and X like this. Also I think that we can go to the front view again, select this back part of the head, press G to move it and bring it closer to the cube that we have created. I also think that we can scale it down slightly like this in order to give this a better appearance. Now I'll select this cube, let's go to the edit mode, and I think that I should slightly scale this up or push this forward. Then I'll press 2 for the edge select mode, and we're gonna select these edges on the sides. So with the shift key hold it, let's select these 4. Press Ctrl B to apply the bevel in order to make these more rounded from the sides, and we'll use the scroll wheel to control the number of segments or the cuts, and here it looks fine. So I left click. If you want, you can use this menu to make any changes, like I can make the width 0.4 or you can increase the number of segments, but for now I think that looks fine, so I won't change anything else here. After this, press 3 for the face select mode. Select this face at the back, press X to delete this. Then let's go to the front view, press A to select all, and let's scale this down in the x-axis and push it backwards so that it's close to the back part of the head. Now I'll change the angle, and one thing that we need to fix here is the number of loop cuts, or basically the geometry. Like you can see on this top that we don't have much loop cuts here. Like if I want to make any changes, then it will be difficult for me. So what I'll do is to add a loop cut here in the middle. So press Ctrl R to add a loop cut. With my cursor over here, I'll click the left click and then right click to cancel any movement. Let's now do the same for the bottom part. So press Ctrl R, then left click and right click to cancel any movement. Now to connect these two loop cuts, we'll be using a tool which is called the knife tool. To enable it, press K, and then we'll see the cursor change into a knife. Then I'll take it to this point where if I left click, and then I'll need to take it to the other point, which I guess is over here. So I'll left click again and press enter. Now I'll check if everything is alright, and here we see that the two loop cuts are now connected. Now let's go back to the object mode, and currently you will see that both of these objects are not joined together but are two separate objects. But if we have to connect them together and work on them as a single object, then we'll have to join them together, which we can do by selecting both of them with the shift key holded. And then if I press Ctrl J, then this will join the two objects together. And you can see that in the scene collection, we now have only a single object, which is the UV sphere. But if I go to the edit mode, then we can make changes in both the objects. Now the next thing that we'll have to do is to connect these edges of the two objects together. Like we'll connect this edge with this one of the UV sphere, then we'll connect this one with the one that is below it. But before we do that, I first need to move this cube object slightly forward in the x-axis so that we'll have some gap. And one of the ways to do this thing can be to select these edges or the faces one by one by holding the shift key. But a better method to select all of the edges of this cube object is to first deselect everything, and then with my cursor over the cube object, if I press the L key, then this will select all the linked edges. Then I'll go to the front view, push this slightly forward in the x-axis like this, and now to connect them, I'll first select these two, and to join them together, you simply have to right click and select Bridge Edge Loops. This will connect the two edges together. Similarly, I'll do the same thing with these two. Then I'll select these two, right click, select Bridge Edge Loops, then select this one, and with the shift key hold it, select this one, then right click and Bridge Edge Loops. Let's do the same thing with this opposite side. So I'll select these two, then right click for Bridge Edge Loops, then select these two and repeat the same process. Now let's do the same thing from the bottom. Now these three edges are remaining on the right side, and also these three edges are remaining on the left side. So we'll repeat the same procedure for these as well. Select these two, then right click, Bridge Edge Loops, and repeat the same process for the remaining ones. Now I feel like the geometry is not very proper here. Like these edge loops are way too much stretched. So what I'll do is to select this edge, then press G twice to slide this edge downwards like this and left click. Let's do the same thing with this one also, so that the entire geometry part will be a bit smooth and the topology will be better. Now we did this change on the right side but not on the left side. So you can either repeat the same process for the left side also, or another better thing that you can do is to delete this left side of the model, and then we'll use the mirror modifier that will allow us to create the same symmetrical shape on the other side. So let's go to the side view, press Alt Z to turn on the X-ray mode, press 3 for the face select mode, select all these faces over here, press X to delete and select delete faces. After this, let's go to the object mode, and to use the mirror modifier, let's go to the modify properties, click on add modifier, then in the generate category, select the mirror modifier, then in the axis, select the Z axis and turn on the clipping option. Let's see if everything is proper or not, and I think that it looks almost perfect. Now if I make any changes on this particular side, let's say I push these vertices down, then the same changes will be applied automatically on the other side. Also, I think that we can select all these faces over here. Let's press 3 for the face select mode and select these, then go to the top view and slightly push them in the Y axis by pressing G and Y. Also, while being in the top view, I'll press 1 for the vertex select mode, select this vertex and press G twice to slide it backwards. Let's do the same thing with this one, and we are doing all this in order to get a clean and better geometry. Let's check if something else is needed to be changed or not. Let's go to the front view and the side view also, and I don't think that anything else needs to be changed in the current model. Now let's go to the object mode, and currently it looks very flat and too much hard. So to give this a smooth and a realistic appearance, we'll be using the subdivision surface modifier. So you can go to the modify properties and add the subdivision surface modifier, or else you can use the shortcut, which is to press Ctrl and then whatever number you type, let's say I type 2, then we'll have the subdivision surface modifier added with the levels you put value set to 2. So it depends that how much subdivided you want the model to be and how smooth you want its appearance. Now suppose I want this front part of the character head to be completely flat, but currently if you see it closely, then it's highly curved at these ends. So to fix this thing, let's go to the edit mode, and we'll be adding a loop cut over here. So press Ctrl R, add a loop cut. After left clicking, bring it forward in order to make the front part flat. Now let's go to the object mode again, then right click and apply shade auto smooth. Now we'll fix this part of the model, which is basically the ears of the robot, or you can say that these are the speakers or something similar that we'll make. So for this, I think that first we should disable the subdivision display in the edit mode by clicking on this icon, then press 3 for the face select mode and select these faces, press I to insert and press E to extrude them back like this. But if I now go to the object mode and zoom in, then you will notice that we see some shading issues here, which are basically because the topology is not very perfect here. As you can see, all these faces are made up of 3 vertices, and so they are tri-faces. But I explained you before that we should always try to go for the quad faces, which are made up of 4 vertices. And so to fix this problem, with all these faces selected, I'll press X to delete the faces, then hold down the Alt key, left click to select this vertex loop, then press Ctrl F for the face menu and select grid fill. With this, we now have all the quad faces, meaning that all of these are made up of 4 vertices each. And if I now go to the object mode, then we no longer have any shading issues, and it now looks completely smooth and perfect. After this, the next thing that we'll do is to create an empty space here at the bottom, because later on we'll have the body of the robot and we'll connect it. So let's go to the edit mode, and in order to create some empty area here, we need to add some cuts with the knife tool. So press K for the knife tool, then left click here. Then for the second point, I'll left click over here. Then this will be the third point. This one will be the fourth point. And at last, I'll close the cut over here. So left click and press enter to confirm. Now press 3 for the face select mode. Select these 4 faces. Press X to delete faces. This way we'll get an empty space at the bottom that we can later on use for connecting to the rest of the body. Now I'll turn on the display of the subdivision surface modifier in the edit mode, and we'll take a look if everything looks proper or not, or if anything needs any changes. Like I think that this particular part of the mesh can be pushed down slightly. So let's go to the front view or the side view and press G, Z, push it down. And similarly, I think that this part can be pushed up. So let's do the same with this one also. I'll slightly rotate this to make it look better, or maybe I should select this vertex and push it slightly upwards like this. Let's select this one also, and it totally depends on your model that how you want it to appear. If you think that in your model everything looks perfectly fine and you don't need to make any changes anywhere, then it's perfectly fine, because it'll actually depend on the flow of vertices and the edge loops. So if everything looks smooth, we'll finalize this. Now let's apply the subdivision surface modifier. Currently it's only added but not permanently applied. So I think that I should set the levels viewport to a value of 2. Otherwise we'll get too many vertices. And let's even take a final look in the edit mode if it looks alright. So with the levels viewport value set to 2, I'll click here on this drop down. And to apply it, we first need to ensure that we are in the object mode and not in the edit mode. Then click here and select apply. Now if I go to the object mode, then you will notice that we now have a large number of vertices which are making this model. And even though the vertices on the side and the back look fine, but the one at the front do not really look very good. So what I'll do is, let's go to the front view and we'll select all these faces, and then we'll make them again so that they look proper and accurate. So let's select all these faces over here. Then with the shift key holded, let's select these as well like this. After this, press S to scale this down so that we'll have some more area. Press X to delete and select delete faces. Now what I'll do is to press 2 for the edge select mode. Select this edge loop, press S to bring it closer like this. Then select this one, press S to scale this down slightly. Then we can fill this face on the front, but before that we should apply the mirror modifier also. There are a few things that we need to do before that, like I'll select this vertex and push it in the Y axis. Let's do the same with this one so that it's not too much open from the back and the vertices will merge with each other like this. Let's do the same with this one also. Similarly here I'll press GY and close this one also, and similarly with this one. Then in the mirror modifier, I'll click here and select apply. Now let's go to the front view to see the front part of the character head or the robot head. Then select this vertex loop or the edge loop again and press F to fill the face. Then I'll press S to scale this down again. Select this vertex loop, press S to scale this down like this, and do the same with this one, and this is how it looks. Now for the back part, if I go to the front view, or maybe let's slightly change the angle, then you will notice that this part is not completely perfect. So we'll just push these vertices in the x-axis slightly till we get some fine results. And now it looks better. Now once the majority of the robot head is ready, we can give it some material. So let's go to the render preview mode, and let me also turn off the scene lights and the scene world, change the render engine to cycles. And for the base material, let's go to the material properties, create a new material, and currently I'll be keeping the base color as the red color. If you want, you can choose any other color of your choice here, but right now I want it to look very simple, so I'll give it the red color. Now for the face, we'll be having a screen. So let's give it some black color. Let's see the front part and press 3 for the face select mode. Select this face, and then if I press Ctrl and numpad plus, then this will increase the selection. And with all these faces selected here, let's go to the material properties and create a new material. And I'll keep it as the black color for now. We can work on things like roughness or the metallic nature and other things later on, but for now I think that this looks fine. Now let's go to the edit mode again, and I think that we should scale this down like this. Similarly, let's select this edge loop and scale this down as well. Now I'll select this outer edge loop, and I think that we should slightly move it forward to cover this green part. Let's select this one also and push it slightly forward to make this part more smooth. And let's take a look at how the character model is now looking. And I think it's a good start. We have a nicely designed model with a nice topology and some basic materials applied. Now the next thing that we'll do is to work on this circle that we created at the bottom. So I think that we should make it look more circular, because right now it doesn't really look very nice. So what I'll do is to press 2 for the edge select mode, select this part, this entire edge loop basically, and then if I try to scale it down, then the problem is that it will get too much stretch. And to solve this problem, we'll use a tool known as a proportional editing tool. So to turn on the proportional editing tool, press O, and then if I press the S key to scale this down, then you will see the circle around the scaling, which is basically the area of influence on which we'll see the scaling effect. You can control the circle of influence with the scroll wheel. If I scroll up, the area will reduce, and if I scroll down, the area of influence will increase. So we have to scale it down in the x-axis. So I'll press S, X, and adjust the area of influence. Then let's see around if we need to change anything. Let's go to the side view, and I think that we should push this part down. So I'll select this vertex and move this down like this. Let's do the same with this one also. Move this down. Then let's switch to the bottom view by pressing Ctrl and 7 on the numpad. Let's select this entire vertex loop and scale this down. Now let's check if anything else needs any adjustment. I also think that we should scale this down in the z-axis to make this look more flat like this. Let's go to the side view, make this more flat by pressing S and Z. Let's also rotate this slightly in the y-axis like this, and this is how it looks. Another thing that I can do here is to select both of these vertices, press O to turn off the proportional editing tool, and we'll bring them slightly closer by pressing S and X. And let's also move this one slightly forward in the x-axis, and this one also, in order to give this a more circular shape. Other than this, I think that we can make this part also slightly better. So I'll just select this vertex. I think we should go to the side view and see if any adjustments are needed to be made like this. And it will depend on your model and the flow of vertices or the edges if you need any changes or not. So you'll have to check this thing yourself depending on the topology and other things in your model. Now after this, we'll start with making the ears of the robot. Now press tab to enter the edit mode and change the view to see the side of the robot head. Now I'll select this outer loop of vertices, then press Shift D to create a duplicate and right click to cancel its movement. Now we have to convert this loop of vertices that we just duplicated into a separate object. And to do this, with the loop of vertices selected, press P, then the separate menu will open where you have to select separate by selection. Now in the object mode, you will see that we have a new object created named as sphere.001, which is nothing but the loop of vertices that we just separated. Now I'll go to the edit mode, press A to select all vertices. Now let's scale this down by pressing S, and then from the top view, I'll move it slightly in the y-axis. Then press E to extrude it in the y-axis, and let's adjust its positioning like this. After this, the next step that I'm gonna do is to select this outer vertex loop. With the Alt key hold it. You can left click to select it. Then I need to fill these faces, so I'll press the F key. Then I'll scale this down and apply some bevel to it so that we can get some detailing on the ears or the speaker part. After this, I'll press S to scale these up to cover this entire hollow region. Then I'll select this innermost circular loop, and to increase the selection, I'll use the shortcut, which is Ctrl and numpad plus. Then I'll extrude it backwards by pressing E, then left click, and to delete all these vertices, I'll press X and select delete faces. Then I'll select this loop and press F to fill the face, then press E to extrude it outwards like this, press S to scale it down, and then press Ctrl plus B, apply some bevel effect. Also, I think I should scale it up slightly more to make this look better, and then I'll select this loop of vertices and I'll press Ctrl B to make this look more rounded and natural. Now the next thing that I'm gonna do is to go to the edit mode, and I'll be selecting this particular vertex loop and will apply some bevel to it. So press Ctrl B and use the scroll wheel to increase the number of loop cuts. This will make this area appear rounded and smooth. And then I'll do the same thing with this boundary loop. So I'll select this and press Ctrl B. Let's apply some bevel here as well and left click. After this, press 3 for the face select mode, and I'll be selecting this face loop, and let's create some glowing material for this part. And to create such a material, let's go to the material properties, click on the plus icon, then click on the new button, and let's also go to the render preview mode. Then with this face loop selected, click on the assign button, and to create the glowing material, we'll have to use emission. So in the strength, let's say I keep it to 1, and it will give some emission to the selected area. And for the color, I'll keep this as the light blue color for now, or you can choose any other color of your choice. But I think that the light blue color will look good with the red color of the robot's head. And you might be thinking that the glow is not very properly visible. And the reason behind this is that we have currently disabled the scene lights and the scene world, which means that we are not seeing the results as per the actual lighting in the scene. So we'll deal with that later. But for now, I think that it looks very nice. And I'll do the same thing with this other part also. So let's go to the edit mode, and I have this face loop selected over here, but if you want you can select any other face loop that should be having this glowing material that we'll add right now. So with the shift and the alt key holded, I think I'll be selecting this face loop also, and then create a new slot, and in this slot let's add that glowing material and then click on the assign button. Let's take a look at how it appears in the scene, and this is how it looks. Here I think that we can make it look even better if I go to the base color and make it light blue, because this will add to the blue color of the material, and right now it looks almost perfect. One more thing that we can do here is to get this part, which is the ears or the speakers of the robot head, on the other side also. So one of the ways to do this thing can be to actually create a duplicate of this by pressing Shift T and moving it in the Y axis. Then you will have to rotate it by 180 degrees in the Z axis. But another quicker way will be to use the mirror modifier. And here in this example, I'll be going for the second way. So let's go to the modify properties, and with this selected, click on add modifier. Then in the generate, select the mirror modifier. Then in the mirror object, I'll click on this eyedropper tool and we'll select this head of the robot, and in the axis, I'll select the Z axis. Now after this, the next thing that we'll create is the eyes of the robot, and for this we'll be using a very simple structure. That is, we'll use two cylinders to create the eyes. So to see how it will work, let's press Shift A and add a cylinder. Let's scale this down and go to the top view. Let's rotate this in the x-axis by 90 degrees and then rotate it in the z-axis by 90 degrees. Let's push it forward in the x-axis and see it from the front. Then press S to scale this down like this, and I think that we should move it slightly forward like this in the x-axis, and after this press G and Y and move it over here. Let's push it slightly upwards, and again we'll scale this down. After this I'll again go to the top view, and right now it's too much forward in the x-axis, so let's push it back again like this and left click. Now for the other side, we'll be using the mirror modifier. So I'll select the cylinder, then click on add modifier, and in the generate category, let's select the mirror modifier. Then in the mirror object, let's select this robot head, and in the axis let's select the Z axis. And here we notice that the eyes of the robot or the character are very close to each other. So what I'll do is to go to the edit mode, press S to scale this down slightly and move it in the Y axis over here, and then we'll return back to the object mode. After this, the next thing that we'll do is to give this some material. So let's go to the render preview mode, and currently it is having the default white material, but we'll give it some glow with the emission material. So let's go to the material properties, create a new material, and in the emission, let's go to emission strength, and this time let's go for a much higher value. Let's say 2.5, and this will give us a lot of emission. Then in the emission color you can keep anything, but in this case also I'll be going for the light blue color only, and same in the base color. Let's switch this to the light blue color like this, and this is how it looks now. Currently it looks very simple, but we'll make it even better by adding a screen or a glass in front of the eyes. So to do this thing, let's first go to the top view to see if everything looks proper or not. Then I'll select this robot head, press 2 for the edge select mode, select this outer loop of edges, then press Shift T to create a duplicate and slightly move it forward in the x-axis. Now we need to convert it into a separate object so that our work will be much easier. So press P to open the separate menu and select selection. Then go back to the object mode, and we'll now select this individual loop, go to the edit mode, press A to select all, and press F to fill this face. But right now we are having some gap between the robot head and this screen or the glass. So to fix this thing, let's go to the top view, and we have to ensure that this glass or the screen does not actually touch the eyes of the character, because in that case the reflections won't be correct. So let's push it slightly backwards like this, and other than this, what I'll do is let's go to the front view and slightly scale this down like this. Then press E to extrude, right click to cancel, and S to scale up that part. Then go to the top view again, and I'll push this backwards in the x-axis. This will basically act as the cover or the part that will connect the screen or the glass to the robot head. After this, let's give it some material, because right now it's having the material that was the material of the robot head. So let's go to the object mode and click on this minus icon to remove all these existing slots. And for this one, we'll be creating a new material that looks like glass or some screen. So let's switch to the render preview mode, and I'll also change this window from the timeline editor to the shader editor. So click here and change this to the shader editor. Then with this material, we have the default principal BSDF node, but I don't think that we'll require it. So I'll press X to delete it. Then press Shift A, go to shader, and to make this appear like glass, we'll be using the glass BSDF node. So let's select this and connect the BSDF socket to surface, and this will convert it to the glass BSDF. Now to give it some interesting look, I'll change the distribution to Beckman or whatever it is pronounced, and let's also slightly increase the IOR value, which is basically index of refraction. So I'll keep this to somewhere around 2.2 or 2.1, but right now it appears very smooth and too much transparent. But I think that it would look much better if it had some black shade over it. So to achieve such a result, let's add some other nodes here as well. So the one that I'll be adding here will be the translucent node. So press Shift A, then go to shader and select the translucent BSDF. To see what it does, I'll just connect the BSDF socket to the surface right now, and it basically creates a translucent surface. That is, it's not completely transparent, but it's also not completely opaque. Basically, it gives a blurred vision kind of feel. In this, I'll reduce the brightness to get a dark color, and to use the glass BSDF along with the translucent BSDF, we'll have to use the add shader node. So press Shift A, then in the shader, select add shader. Let's place this over here and connect the glass BSDF node to the add shader, and this is how it looks now. Now since we are done with almost the entire robot head, so now we can move forward to the rest of the body. So let's go to the object mode, and first let's make the neck of the robot. And for this, let's get the side view, and we'll be adding a cylinder for the neck part. So press Shift A, then go to mesh and select the cylinder. Let's scale this down like this and turn on the X-ray mode, and I think that we should go to the bottom view by pressing Ctrl and 7 on the numpad so that we can see this part clearly. Let's push it slightly in the x-axis like this, and after this I think that we should scale this down, and to make this long, let's scale it up in the z-axis like this. Then let's again go to the bottom view, and I feel like we should scale this up again. Maybe previously it was slightly inaccurate. And after this thing, let's go to the front view or the side view depending on the object orientation, and let's keep this over here. Let's scale this down in the z-axis again like this. Let's change the angle to take a look at it, and it appears completely fine. Now right click to apply shade auto smooth, then again switch to the side view. Let's push it slightly downwards in the z-axis, and the next thing that I'll do is to go to the edit mode, and we'll be adding some loop cuts here because we'll be working on some details. So press Ctrl R. Let's increase the number of loop cuts to a much higher number, like maybe 10 or 16. Then left click and right click to cancel the movement. Then with all these selected loop cuts, let's add some bevel to these by pressing Ctrl B and use the scroll wheel to increase the number of loop cuts or the segments basically. After this, with all these selected, press E to extrude, right click to cancel, and let's scale these down, and this will create a beautiful detailed structure like this. Here I think that it's making it look like a spring or something, and I think that it looks very cool. Only thing is that if we could scale this up in the z-axis so that there will be more gap. Now let's give this some materials. So in the material properties, let's create a new slot, and I'll be giving this some black material. Then let's move ahead to the body of the robot. So let's go to the front view, then press Shift A, go to mesh and select a cylinder. We'll be using the cylinder to make the body by adding some cuts and defining its shape. So let's move this down in the z-axis, and let's make this slightly longer like this. Push it up slightly, then go to the edit mode. Press Ctrl R to add a loop cut here. Then let's slightly scale this up like this. Let's add one more loop cut just below it. Then I'll select this edge loop on the top, and I'll slightly scale this down, and similarly I'll select this one also and scale this down. Then with both the top and the bottom loop selected, I'll press Ctrl B to add some bevel effect to it in order to make this more rounded and have a natural look. And after this, let's add some detailing on this top part. So press 3 for the face select mode, then select this face, press I to insert the face, E to extrude it slightly downwards, press I again to insert, press E to extrude it slightly up. Let's scale this down, press I again to insert, and then extrude this down in the Z axis. Then left click, and while being in the object mode, let's apply some shade auto smooth, and let's also apply some bevel to this top part where we just added the details. And for this, I think that we need to set our focus only on the body object. And to do this thing, I just have to click this / button on the keyboard, and this will remove all the other objects from the scene temporarily, and we'll have to focus only on the selected object. Now let's go to the edit mode, press 2 for the edge selection mode, and I'll first select this edge loop, press Ctrl B to apply some bevel. Let's also select this one, apply some bevel to this, then this one, press Ctrl B and apply some bevel like this. At last I'll select this inner loop and press Ctrl B and left click. Now let's remove the focus from this object by clicking the forward slash button again, and to make this look even more interesting and detailed, let's apply some subdivision surface modifier. Currently in the modifier properties we just have the smooth by angle, and to use the subdivision surface modifier I'll press Ctrl 2 and this will add the subdivision surface modifier with the levels viewport value set to 2. Now let's go to the render preview mode, and currently we don't have any material applied on the body. So with this selected, let's go to the material properties, and for the first material I'll create a new slot, and in this I'll click here to select the red material that we created for the head of the robot. Now we won't keep this very simple. Like on this top part, maybe we can add this light blue emission material on some of the face loops. So let's zoom in, press tab to enter the edit mode, and then I'll also switch back to the solid mode, then hold the alt key and I'll select this. But before that, let me also press 3 for the face select mode, then with again the alt key hold it, select this face loop, and to increase the selection I'll use the control and plus on the numpad like this. And with these 5 face loops selected, let's apply that material of the emission. So in the material properties, I'll click on this plus icon for a new slot, then to select a material, click here, and I'll be selecting the material.002. Then click on the assign button, and to see how it looks, let's go to the render preview mode, and this is how it looks. Here I think that we should adjust the loops where we'll have this emission material. So I think I should undo this, then deselect all the face loops. Then I'll select this one, then press Ctrl and the plus icon to increase the selection. And once all these face loops are selected, I'll again create that slot with that material and click on the assign button. Let's now see how this looks in the render preview mode, and I think that it looks better than before. So we'll go with this one. Also I think that I can select some face loops over here, but before that I think that we should also disable the real-time display of the subdivision surface modifier so that we can select the face loops in a proper way. Let's try these face loops that are present over here. So I'll select this, press Ctrl plus to increase the selection like this, and go to the material properties and assign to add this material. Now it totally depends on your own preference that how you want the materials to be. If you want, you can keep the entire body as the red color, or you can select some particular faces like I did here, and you can then apply any specific material to it. So it all depends on your own personal preference that how exactly you want the model to appear. After this, I'll again go to the modify properties and enable the real-time display of the subdivision surface modifier, and this is how the basic structure of the body is now looking. Now the next thing that we'll do is to go to the solid mode, then go to the front view or the side view, and after that with this body selected, I'll go to the edit mode. And currently I think that the shape of this body is not very good. Like it's too much scaled up in the middle, which is not really giving it the look of a robot. So what I'll do is to press 2 for the edge select mode, then select these 2 edge loops, press O for the proportional editing tool, and we'll scale these down, and you can use the scroll wheel to change the size of the circle of influence. So we'll change the scaling like this, and after that we'll return back to the object mode, and now we'll work on modeling the arms of the robot. So before modeling the arm, you should first know that how we are going to do it. So we'll first have a cylinder over here, and then with that cylinder we'll connect an arm, and it will look something like this in the image. So to model this, let's first add a cylinder in the scene. So press Shift A, then go to mesh and add a cylinder. Now after this, let's go to the edit mode, and we'll rotate this in the x-axis by 90 degrees, and let me also disable the proportional editing tool by pressing O. After this, let's go to the object mode, press G to move it and place it over here. Then we'll reduce its scaling by pressing S to scale it down like this, then press G to move it, and we'll place it somewhere over here just to ensure that it's not too much above or too much below, so that we can have it at the correct arm's distance. After this, the next thing that we'll do is to go to the edit mode, press Ctrl R to add some loop cuts here. Like I think we should add 5 loop cuts here, and then we'll select this face loop over here, and we'll use this to create some empty space where the arm will be attached, and it will help the arm to rotate as well. So with this face loop selected over here, what I'm gonna do is I'll deselect some of the faces here. Like I'll be deselecting all these faces at the back because we don't want the complete loop to be deleted. The arm will be able to rotate 360 degrees that we don't want. So with these faces selected over here, I'll press X to delete the faces. Let's go back to the object mode, right click to apply shade auto smooth, and to give this some realistic appearance, let's use the subdivision surface modifier. So press Ctrl 2, and to fix these shading issues, I'll go to the edit mode, press 2 for the edge select mode, select this edge loop, and now we have two methods to fix this shading issue. One of them is to apply the bevel by pressing Ctrl B like this, or else another method can be to just press I for inset and left click. But here I think that the bevel will give it a realistic appearance, so I'll be applying the bevel tool, and this is how it looks. Now I'll again go to the front view or the side view depending on the orientation of the object, and I'll slightly push it inwards in the y-axis. Now in order to get the same object on the opposite side as well, we'll be using the mirror modifier. So with this selected, let's go to the modify properties, and in the add modifier, go to generate and select the mirror modifier. Then in the mirror object, I'll be selecting the cylinder or the body and change the axis to the y-axis. Now to model the arm, I'll go to the edit mode of this cylinder that we created or added here. Then I'll select this vertex, and with the control key hold it. If I select this one, then this will pick the shortest path between both the vertices, or it will basically select all the vertices between those 2 points. Similarly, with the shift key hold it, I'll select this point, and then with the control and the shift key hold it, I'll select this one. After this, I'll press shift T to create the duplicates, then right click to cancel the movement, then go to the side or the front view depending on the orientation of your object and other things, and with all those vertices selected, I'll press E to extrude these like this. These will actually be the arms of the robot, and to make sure that they're the correct height, you just need to ensure that they are approximately equal to 70 to 80% of the body height, because they shouldn't be very long and they shouldn't be very short as well. So you need to take care of this fact that they're of the correct height. And after this, what I'll do is I'll select this entire loop of vertices here on this part and press X to delete these vertices. Then with my cursor over this right part of the arm, I'll press the L key to select all the linked faces, press P to separate the object by selection. Then with this object selected, let's go to the edit mode, press A to select all, press E to extrude this, and we'll keep it to something like this. And the reason why it looks very weird is we don't have enough loop cuts here. So I'll press Ctrl R to add a loop cut over here, and similarly I'll add another loop cut for this particular part. After this, let's go to the object mode, press H to hide this arm, and I'll select this part again, basically this cylinder, then go to the edit mode, and you will notice that we still have some vertices selected over here. This vertex loop is basically a part of the left side of the arm that we just deleted, and if you're not seeing this as selected, like if you're seeing it something like this, then what you can do is to hold Alt key, and if you left click here, then these vertices will get selected. So these are the unnecessary vertices that we no longer need. So let's press X to delete and select delete vertices. Let's return back to the object mode, and let's also unhide the arm or basically the cylinder. Then we'll go to the top view by pressing 7 on the numpad, and I'll slightly push it backwards in the x-axis like this. Now to make the hands of the robots that you can see in this image, we need to add another cylinder. So press shift A, then go to mesh and add a cylinder object. Let's switch to the front view, press G to move it and place it over here. Then we'll go to the edit mode. Let's first rotate it in the x-axis by 90 degrees. Let's scale it down now like this. Now let's go to the side view, press G to move this, and we'll place it over here. Then we'll increase its scaling or the size. Let's change the angle, and I think that we should scale it down in the y-axis like this. And after that, we should also reduce the overall scaling like this, and we can turn on the X-ray mode to see if everything looks proper or not. And here I think that there's one more thing that we can do, which is to move it in the x-axis like this and slightly increase the scaling. Let's take a look at how the hands of the robot are looking. So I think that they look very decent right now. We'll obviously build this more, but the basic positioning and the scaling, rotation, all that looks perfect for now. Then press 2 for the edge select mode. Select this edge loop over here. Press Ctrl B to apply some bevel and use the scroll wheel to increase the number of segments. Then let's change the angle and select this edge loop. Then press Ctrl B to apply the same bevel tool over here also, like this. The next thing that I'll do is to press 3 for the face select mode, and then I'll select all these faces except the ones that are at the back. Like I'll select this one, and from here we'll need all the faces to be selected till this point. So with the control key holded, I'll select this one, but since the shortest distance is from here, so it selected all these faces instead of the ones that we needed. Let's change the technique and we'll manually select all these faces like this. So let's select these as well, change the angle, select these over here like this. Then after we have selected all these faces, the next thing that we have to do is to scale these down with some inset effect. So to do this, press I and this will insert the faces together. But if you're seeing results like this, then you need to press the I key twice so that you can get the insert effect together. Then let's right click, press S to scale this down like this. Here I think that we should slightly scale this up, or maybe we can push it slightly forward in the x-axis, then go to the side view like this, press Alt Z, and we'll move this forward in the x-axis like this and push it above in the z-axis as well. And let's return back to the object mode again, and this is how it looks. Here we notice that this part of the arm is still visible. So to fix this thing, I think we should select the arm, press A to select all, and let's slightly scale this down in the z-axis like this. Let's return back to the object mode, but because of doing this, we have some free faces over here that we can insert and scale down. So I think that we should undo this a few times before we insert the faces, and after this is done, let's go to the side view. I'll select this arm, let's enter the edit mode, press A to select all, and I've also turned on the X-ray mode here. Now I'll slightly scale this down like this and also push it backwards in the x-axis like this. Now I'll select this part, which will basically be the hand of the robot, then go to the edit mode, and after that the next thing that we'll do is to select all the faces again. You will have to check if any faces left out or not, and after this press I to insert, press E to extrude, and S to scale down like this. I think it looks very perfect, so we shouldn't make any more changes. Let's go back to the object mode, right click and select shade auto smooth, press Ctrl 2 for some subdivision surface modifier, and to make this part look more sharp, what I'll do is to disable the subdivision surface view here, then press Ctrl R to add a loop cut here, press S to scale this down. Let's add one more loop cut and press S to scale this up like this. Now let's enable the view, and this is how it looks. Also, I'll do another thing here, which is to select all these faces in the face loop. Then I should deselect these faces that were not scaled down with inset effect. So I'll deselect all these like this. And after this step, I think we should slightly scale these down in the y-axis like this. Press Ctrl and plus to increase the selection, and scale down these as well like this. Then press Ctrl R to add a loop cut here, press S to scale this part down, and whatever we are doing here is basically to create a detailing, and it totally depends upon you that how you want this model to look like. You can add as many details as you want. You can keep on scaling this down or applying the inset effect like I will be doing right now. Now I have modeled this one that I think might look best for the scene. I made some changes in the beveling and the extrusion part, and I also reduced some faces in the inset effect that we created. Apart from this, I'll now select this one, which is the arm, and you can see that it's slightly appearing out of the hand. So we can just slightly scale this down again by pressing S to scale it down like this. Let's go to the top view, select this, press G to move this over here. Let's change the angle to see if everything is proper. Here I think that I should move this slightly backwards by pressing G, X and place it over here, and this is how the model looks. Now just like we did for this arm, let's use the mirror modifier for this hand also. So with this selected, let's go to the modifier properties, click on add modifier, then in the generate, select the mirror modifier. Then in the mirror object, select the body and change the axis to Y axis. Now another thing that we can do here is to add some details on this cylinder that we added here. So what I'll do is to select this face over here, then press 1 for the vertex select mode, press K to turn on the knife tool, then select this vertex and connect it to this one, press enter to confirm, and let's create one more pattern here, or basically a line connecting from this vertex to this one. Again press enter to confirm, and this will give us these 4 faces. So I'll select all these, press I to apply the inset, but this time I want the inset effect to be applied individually. So I'll press I again, then left click, press E to extrude it backwards like this, and return back to the object mode. If you want, you can make any other changes like scaling these down, or maybe you can add any loop of vertices somewhere, or you can insert this to create some more effects. But for now I think that it looks completely perfect, so I'll not be doing all this. Then the next thing that I'll do is to fix the scaling and the positioning of this arm, because currently we scaled it down so it doesn't really fit this hollow space in the cylinder right now. So I'll go to the edit mode and make some changes. And finally, the arms and the hands of the robot are modeled here. Now the next step is to apply some materials on these. So first I'll select the cylinder over here, then go to the render preview mode, And on this we'll apply a black colored material similar to the one that we have over here and behind the screen as well, or the glass. So let's go to the material properties, create a new material slot, and in this slot I'll select the material.001, which is the black color material. Then for the arms we'll give this some red color with some stripes of the black color. So first of all, let's create a slot and fill the slot with the red color material, and then to create the black pattern we'll switch to the edit mode, and then we have to select some faces that will get the black colored material. So I'll select these faces with the shift key hold. I'll select this strip, then with the shift key hold select this one. Let's select this as well, or maybe we should select from the bottom. So I'll select these two over here. Let's select these as well. Then I'll be selecting these. Now in a similar way, let's go to the other side, and I think I should switch to the solid mode. Let's change the angle and select these parts as well so that we don't miss anything like this. Let's select this one also and the one at the last. Then go to the material properties, create a new material and click on the assign button and select this material.001, which is the black colored material, and let's turn back to the object mode to take a look at how the arms appear. So I think that they look very decent right now. We can work more on this part, but for now I think we should now work on the hands. So I'll select them and I'll give these some black material as the primary color, and then for these faces that we inset I'll be using the red colored material. So let's first disable the display of subdivision surface modifier here, and then I'll be selecting all these faces. So with the shift key holded, let's select all of these from the top to the bottom, and once it is done, let's go to the material properties, create a new slot, and in this slot let's add the red material and click the assign button. And finally, this is how the arms and the hands of the robot appear. Let's take a look from different angles to see if any changes are needed or not. For the arms of the robot, I can select one more strip over here and apply the black material to it. Similarly, let's see this on the other side also. I should select this strip over here. So let's select these three faces and assign the black material like this. Let's see if anything else is missing. Like I can select this face, or basically all these faces at the bottom also, and apply the black material to these. Let's change the angle here, and we can do the same thing here as well. So let's assign the black material. Now moving ahead, in this current model, you will notice that the red color that we added as the primary color for this entire robot model, it looks very simple and flat. So to make this texture look better, we'll make some changes in the shader editor. So let's open the shader editor window and select the red material. And currently we only have a base color as the red applied. But now since we want it to look much realistic, so we have to use some textures. But first of all, I'll reduce the roughness value down to 0 so that we have a shiny look on this surface. And now the texture that we're going to use is the noise texture. So press Shift A, then go to texture and select the noise texture. Let's place this over here, take the factor socket and connect it to the base color. And currently we see this black and white texture because of the noise texture being added. We'll add some colors to it, but before that, let's work on the scale. So we want this to be of very high scale, let's say 120, or maybe let's keep this to 130. We'll also want some high detailing, and let's zoom in to see if any distortion is needed. Like I think we should keep the distortion value to around 3, or maybe let's slightly reduce this to 2.9. And now for the colors, we'll be using the color ramp node. So press Shift A, then go to converter and select the color ramp. Let's place this over here. The black color in the texture or the material is being represented by this pointer and the white color with this pointer. So for the white pointer, which is this one, I'll change this color to the red color, and for this other pointer which is currently black colored, I'll change its color by clicking over here and increasing the brightness with this brightness slider, and let's say I choose the yellow color. Then this part of the texture will get the yellow color. Finally, this is how the material is currently looking, but we can even give this some 3D effect. So we'll add the bump node here for the 3D effect. Press Shift A, then go to vector and select the bump. Let's place this over here, connect the normal to the normal in the principal BSDF. And for the input of the bump node, I'll take the factor socket of the noise texture and connect it to the height in the bump node. Currently, the bump effect or the 3D effect is of a very high strength, and that's where the texture appears very rough and not something that we'll want for the robot body. So to reduce this strength, let's go to the bump node, and in the strength value, I'll enter a lower value like 0.2, or maybe let's slightly increase this to 0.3, and this is how the texture appears. We have a slight bump effect on the texture because of the bump node, and if you zoom in, then you will see these details which are due to the noise texture, and this is giving us a slight yellow colored pattern on the red material. After this, I don't think there's anything else that we need to change in terms of the materials. So I'll go back to the solid view, and the next thing that we'll work on is the lower part of the robot. which is basically for the movement. So you can take a look at the final version of the robot, that how the structure or the shape will be. And to get a similar shape over here, I'll go to the edit mode, press 3 for the face select mode, select this face at the bottom, press E to extrude it downwards like this, press Ctrl B to apply some bevel, then I'll select this face, press I to inset and press E to extrude it down like this. Now press E to extrude but right click to cancel the movement. Press S to scale this part up. Let's go to the front view or maybe the top view to see how the shape of the circular part is looking. So it should be slightly more scaled up as compared to the rest of the geometry, because this will be the part where we'll have the base of the robot. So let's slightly scale this up even more like this. Then press E to extrude it down. Press Ctrl B to apply some bevel, then select this face at the bottom, press E to extrude it one last time, and then press Ctrl B to apply some bevel effect. Now let's take a look at how it's appearing in the scene. Here I think that it's too much scaled up, especially in the Z axis, because it's appearing to be very thick. So what I'll do is I'll go to the edit mode and will turn on the X-ray mode. I'll select all these faces and I'll delete these by pressing X and delete faces. After this, I'll select this entire face loop over here. Let's disable the X-ray mode also. And after this, scale this part up like this. Let's switch to the front view only for now. Press E to extrude it down, and let's change the angle to see if everything is proper or not. Then press 2 for the edge select mode, select this entire edge loop, press Ctrl B to apply some bevel effect, and after this I'll select this outer edge loop, press E to extrude it, then right click to cancel and scale this part down like this and left click. Let's return back to the object mode to see how it appears, and I think that it looks very nice, except that the bottom part is currently opened, that we certainly do not want. So what I'll do is to select this inner edge loop, then press F to fill the face, and this is how the model appears. You can take a look at it from different angles, and if you want you can make any changes anywhere. Like for example, you might think that for the lower part we can add one more extrusion and then we can bevel this by pressing Ctrl B, and then the model will appear like this. Or maybe you can add some extrusions on the upper part of the base. So you can do all these things depending on what exactly is the type of model that you want. And once all this is done, we'll be applying the materials on the base. So let's go to the render preview mode for now. Then press tab to enter the edit mode. Let's also go to the solid view, and I'll be adding two loop cuts here, but individually, that is one by one. So first I'll add a loop cut and I'll left click, place it over here. Press Ctrl R to add another loop cut close to it. Press 3 for the face select mode. Select this entire face loop, and I want that this face loop should have the glowing or the emission material. So I'll select this material with the light blue color glow and click on the assign button, then return back to the render preview mode to see how it actually looks. And here I think that to make this look even better, what I can do is to go to the edit mode with these faces selected, press E to extrude these down, and let's also add some loop cuts here. So press Ctrl R to add a loop cut here, press G twice to slide it like this. Let's add one more loop cut by pressing Ctrl R, and let's place this over here so that the shape will be more refined. Now I'll go to the render preview mode to take a look at it again, and this time it appears much better than before. If you want, you can make this even more dense by going to the edit mode again, then press 3 for the face select mode, select this entire face loop, and then I'll increase the selection, press G and Z and move it down. After this, the next thing that I'm gonna do is to add some blue color emission material on this bottom part as well. So let's go to the render preview mode, select the body of the robot, press tab to enter the edit mode, select this face, then Ctrl and plus to increase the selection for 3 to 4 times, then click on the material.002 or basically the emission material and click on the assign button. Now return back to the object mode, and this is how it appears. We have the complete model of the robot ready in the scene. It has the arms, the handle, the body of the robot, a base with some emission, the head of the robot, and that too with all the detailings. And with this, we finally arrive to the end of the fifth module. In the next module, that is the module number 6, we'll be starting with the concept of rigging, as we'll understand it with the robot example that we just modeled. Welcome to the sixth module of the Blender 3D animation course, Rigging the Robot. So in the last module, we completed the modeling of this robot that you can see here, and we even applied the materials and the texture to it, and I made some changes here and there in the model, and this is how the final version looks. And now in this module, we'll start with the concept of rigging. We'll understand its meaning and how we can do it practically with this example of the robot. So to begin with, let's first understand what exactly is the meaning of rigging. We have just touched upon this concept in one of the previous modules when we were rigging the basketball, but now we can understand this in even more detail with this robot example. So rigging is the process of creating a digital skeleton for a 3D model in order to make it easy to To animate the 3D model, the skeleton can be a system of bones, joints, and other controls that can allow us to manipulate the model's movement and make it perform actions like moving, rotating, and even some complex ones like running, walking, speaking, etc. Here in this project, we see that we have the 3D model of a robot which we have to rig so that we can move it very easily. But it's not really a very complex 3D model that will require a lot of rigging, because if you look at a human model, you will have to rig the arms, the legs, the head, the torso. Basically, every part of the body has to be rigged. But on the other hand, in this robot model, the main things that we have to rig is the robot head, this neck of the robot, and the arms. Apart from this, we'll have a separate object at the bottom that we'll use to move or rotate the entire object together at once, but that will be explained later on in this module. So currently we have to focus on rigging the parts of the model, and to begin with the process of rigging, we first have to ensure that all the objects in the scene have all the modifiers applied and their origins are set to the geometry. So I'll first select the cylinder in the scene collection, and this mirror modifier is added to it but not yet applied. So to apply it, click here and select apply, and then you have to repeat the same procedure for all the modifiers in the remaining objects. Also, if you want, you can use the shortcut which is to press Ctrl A with the cursor over the modifier, and this will apply the modifier automatically. So you can use this shortcut if you want. And once all the modifiers are applied, the next important thing that we have to do is to set the origin to the geometry. Right now, I have selected this glass or the screen, but its origin is located somewhere over here, which is not on the geometry or the midpoint. So to fix this, you can go to object settings with the object selected, then go to set origin and select origin to geometry. We have to repeat the same procedure for all these objects in the scene except the camera. In fact, I'll delete the camera, so I'll select it and press X to delete. And now let's repeat the same procedure for the rest of the objects. After this, what we'll have to do is to join these objects together, like the head of the model, the eyes, the screen, the ears, and even this neck, but we'll see it at the end. So the first thing that I'm going to do is to go to the front view, then zoom in and press Alt Z to turn on the X-ray mode. Let's select all these objects, and then at last with the shift key holded, I'll select the head of the robot so that it's highlighted and is the active object. Then press Ctrl J to join these together. After this, we'll begin with the rigging process. So to actually begin with it, we have to add the armature object or the bone. So press Shift A, then go to armature. Let's enable the X-ray mode, and here we have the bone added. To change the way how this bone is added, like its location, rotation, or the scaling, we have to enter the edit mode by pressing the tab key, and this will show that this bone has two ends. One is the head, which is the first one, and the other is the tail, which is over here. And with this selected, if I press G to move this down in the Z axis, then this will come down like this. And if I press E to extrude, then a new bone will be created that I can set here for the neck. And in this way, we are able to create a very simple armature for the head of the robot and the neck. Now, what I'll do is to go to the object mode by pressing the tab key. And after that, I'll be selecting this head and the neck together, and let's join these two together as well. So press Ctrl J to join these together, and once you do this, the origin point will again shift to a new position that we don't want to happen. So I'll go to the object menu, then set origin to geometry, and after this we'll actually rig this part with the help of these bones that we added. And to do this, we'll take the help of the parenting feature in Blender, about which we discussed previously as well. So with this head part selected, I'll hold the shift key to select these bones or the armature, as you can see in the scene collection. Then press Ctrl P for the parenting menu, and the armature deform, select automatic weights. Now if I select this armature or the bones in the scene and click over here, then this will display me three options. The first one is the object mode, in which we currently are, and we can see the bones here. Then the second one that we have is the edit mode, where we can basically select the head and the tail of the bones. We can move them around and extrude them to create new bones. And at last, the third one is the pose mode. And basically this is the mode where we create the pose for the character and see what basically rigging does, and even animate the character. To explain it, here I am in the pose mode and I've selected this bone by left clicking, and now if I press R to rotate it, let's say in the Z axis, then you can see that along with the bone, the head of the robot is also rotating. Similarly, if I rotate it in the y-axis, then the head will rotate in the y, and the same is true for the x-axis. Now in a similar way, if I now select this bone and press R to rotate it, then this will rotate the neck. Similarly, if I rotate it in the y-axis or in the z-axis, then the same changes will be seen on the neck part. But mostly we'll be using this bone only for the rigging purposes because it controls the head of the robot. And if I rotate it in the y-axis like this and take a close look at the neck part, then you will notice that some part of the neck is also being affected by this bone. Now you can see that it's creating a bend like this, which was not originally present. So this is what rigging does. It basically gives a skeleton to the character or the model on which it is applied, and then you can use the bones to create any pose that you like for your character or maybe animate the character. And now after this, I'll again go back to the object mode, and yes, you can also switch between the object mode and the pose mode by using the shortcut control tab, which will allow you to toggle between the two modes. Now the next thing after this is to rig the arms and the hand. So for this, press Shift A to open the add menu, then go to armature. Let's go to the side view, press Alt Z to turn on the X-ray mode, press G to move this bone over here. Let's go to the top view, and I'll move this bone in the y-axis to place this over here. Now the next thing is to go to the side view, press tab to enter the edit mode, and with this part of the bone selected, press G to move this, and I'll place this on the other end of the arm. Then press E to extrude for the hand and left click. Let's return back to the object mode, and we also need to create the same armature for the other side. So what I'll do is to press Shift D, then move these in the y-axis and place them over here. After this, we have to parent the arm and the hand with the armature that we just created. So I'll select the arm first, then the hand, then select this armature over here, press Ctrl P to apply the parenting options. So I'll select armature deform with automatic weights here. Now if I select this and press Ctrl tab to go to the pose mode, select this bone and press R to rotate, then you will notice that we are seeing a problem that both the arms are being affected by this single bone. And this is happening because we applied the modifier, which was the mirror modifier, to both the objects, and as a result they are turned into a single object. So to fix this thing, I'll press Ctrl Z to undo all this. I'll press tab to enter the edit mode, deselect everything, then with my cursor over this arm, I'll press the L key to select all the linked parts together, then press P to separate the object by selection. After this, I repeat the same process with the hands. So I'll press tab to enter the edit mode, deselect everything, then keep the cursor over this object, press L to select the linked parts, then press P for separate by selection. Let's return back to the object mode now, and now we have to set the origin back to the geometry for all these objects. So I'll select this arm, go to object, set origin to geometry, and let's repeat the same procedure for the remaining three objects. After this, with this arm selected, I'll hold the shift key to select this, and then at last select the armature. Then press Ctrl P to apply parenting with the armature deform and automatic weights. Then I'll select the bone or the armature, press Ctrl tab to enter the pose mode. I'll select this bone, press R to rotate, and now in this case we see only this arm being rotated. So we can rotate it in the Y axis like this, and it properly rotates. And in a similar way, let's go back to the object mode, then select this arm, this hand, and at last select this armature or the bone. Press Ctrl P for the parent menu and select armature deform with automatic weights. Then select the armature, press Ctrl tab to enter the pose mode, select the bone, and if I now rotate it in the Y axis, then both the arm and the hands are rotating together. Now the next thing that we're gonna do is to create some controls to use these rigs. To explain you what I mean to say, I'll first go to the object mode, and currently if I want to make any changes in the rotation of arm, then I first have to select the relevant bone, then I have to press the R key to rotate. After that, I have to judge that which axis I have to select, like the X axis or the Y axis, and only then I'll be able to make any changes. But how easy it would be if we just had a control here, which if I select and move up and down would make the arm and the bone rotate in the Y axis, and this thing is possible by creating drivers. To see this practically, let's say I add a circle in the scene. So I'll go to mesh and select a circle. Let's move it in the X axis and place this over here. Let's go to the top view to see the size and everything. I think we should scale this down. Press G to move it and place it over here. Then press Ctrl A to apply the scale because we just changed its size. Then create a duplicate and let's place it on the other side. Let's change the angle. After this, I'll select both the circles and move them down to the position of the arms over here and left click. Now let's say I want that the rotation in the y-axis of this bone should be controlled by this circle. So what I have to do is to go to the object properties with this armature selected. Then in the rotation in y-axis, if I right click, then it will show me an option to add a driver. And if I select this, then this window will appear where I can choose the variable object. So if I select this eyedropper tool and select the circle by left clicking on it, then to edit the driver properties, I'll right click and select edit driver. Then in the type location, I'll change this to Z location because I want that only if I move the circle up and down in the Z axis, it should cause a change in the Y axis rotation of the arm. Then this is how the things will happen. But now suppose I move this in the X axis, or let's say in the Y axis, then we won't see any other changes. This also means that you don't even need to remember which axis you have associated with the Y rotation of the arm, because if you just press G to move it up and down like this, then it won't consider the movements in the X and the Y axis, but it will only consider the Z axis location. So this thing is very useful to easily control the arm, like you just have to move this and the arm will rotate. Now similarly, let's do the same thing for the other side also. So I'll select this bone or the armature here. Then in the y-axis rotation, I'll right click to add a driver. And in the variable object, let's select this other circle. But now we need to set the z location as the parameter to be considered for the rotation. So I'll right click here again and edit driver. Then in the type, select the z location. And now if I select this and move this up and down, or even if I just press G to move this around, then the arm will rotate in the y-axis. Now even though everything looks perfectly fine, but let me show you one more thing. If I select the circle and move this in the z-axis like this, then you will notice that at one point the arm is rotating so much that it's even crossing this barrier that we created in the shoulder object. Like if I select this and move this down, then it's no longer considering this barrier that we created. And to fix this, we basically have to set a limit on how much this can move up and down. So to see how we do this, with this circle selected over here, I'll go to the constraints properties by clicking here, then add object constraint, and this will display you several options related to the constraints, but the one that we'll select is the limit location. This will allow us to set a limit on where can we move the object, and then it will control the rotation limit as well. So the axis that we are looking for here is the z axis, so I'll turn it on. And currently both the minimum and the maximum values are 0 meters, which means that if I try to move it in the z axis, it will not move. So if I go to minimum z axis and try to reduce it to, let's say, minus 10 meters, and then if I push it down, then we realize that it's a very high value. So we need to get something like minus 5, or maybe let's do one thing. I'll change this back to 0, then I'll disable this option, then I'll go to object data properties and change the z-axis location to the default 0, and then I can check it beforehand that how much do I need to move it in the z-axis to bring the arm to exactly this point. So I'll press G and Z to move it down till we reach over here like this, and this location is around minus 1.7. So I'll copy this, then I'll go to constraints, enable the z minimum and the maximum. Let's paste this value in the z minimum, and then for the maximum also I'll paste the same value, but I'll remove the negative sign. And now if I try to move it, then you will notice that the constraints are properly applying. Let's do the same thing for the other one also. So I'll select this, go to object constraints, select limit location, and turn on minimum z axis and the maximum z axis. Then in this one I'll enter minus 1.7, or basically that value that we copied before, then press enter, and in the maximum I'll use the same value but without the negative sign, and we'll see the same thing happening with this one as well. So basically this is how you can set up controls for your object. And to revise everything, we first added some bones, then we set them as the parent object so that they can influence the object in movement, rotating, and the scaling. Then we learned to create some controls which allowed us to easily move, rotate, or scale, or whatever thing is required to be done with the armature. And then we learn to apply some limits to it so that we don't get unnecessary results. Now the last thing that we have to do in this module is to create the main control that we can use to move the entire body together. So for this, I'll be adding a circle in the scene. So press Shift A, then go to Mesh and select a circle. Let's scale this up by pressing S. Let's also go to the top view to see if the scaling is correct or not. Then press Ctrl A and apply the scaling. After this, press G, Z and move this down over here. We'll keep it at the bottom part only, although this won't make any difference even if you keep it somewhere else, but it gets easy to use it over here so that when we move it, we can see the whole object moving properly. So after this step, the next thing that we have to do is to select all the body parts of the robot model, and we'll parent them to this circle. But we have to make sure that those objects that are already parented, like the arms, the neck of the robot, the head, and the hand, these won't be parented directly, but rather their bones or basically the armature will be parented. So to do this thing, let's go to the scene collection, select all these objects with the control key holded, and after this, with the shift key holded, I'll select this circle at the end that is present at the bottom, then press Ctrl P and select set parent to object. Now if I select this and try to move it above, then the arms are also rotating because we selected the circles along with it. So I think I should undo this and deselect the circles and then press Ctrl P again to set the parent to object, and then I'll move this up and down and we see the object moving like this. But we have another problem here which we need to solve, that let's say I move this in the y-axis over here, but now the controls are still here. So we want the controls also to move along with the object or the robot. So to fix this, I'll undo, then I'll select the circle and parent it to this bigger circle. So with the shift key holded, I selected this circle and press Ctrl P and set parent to object. Let's do the same thing with this one also. So I'll press Ctrl P and select object. And now if I try to move up or down, then you will notice that the robot is moving, the controls are moving, but along with that, the arms are also rotating, which is basically happening due to the movement of the controls in the z-axis. So in short, we now have another problem to solve, but you don't need to worry because this has a very easy fix. You just have to select the armature, or basically for which the circle was being used as the driver. So I'll select this bone or the armature, then go to rotation in the y-axis, right click and edit driver, and change the space from world to the local space. Let's do the same thing with this armature as well. So I'll go to rotation in the y-axis, then edit driver and change the space to the local space. And now if I select the circle and try to move it anywhere, then the arms will not rotate. The reason behind this is that every object in the scene has a world space and a local space. World space basically means its location with respect to the world origin, like the global axis, and its local space is basically with respect to its local origin, that is this origin point that you can see, which is marked as yellow color, and its local axis. Now the next thing that we're going to do is to create a control in the form of a circle object for the head and the neck part of the robot. So press Shift A, then go to Mesh and select the circle object. Let's move it up in the z-axis and place it over here. After this, I'll select the bone or the armature which is controlling the head, then press Ctrl Tab to enter the pose mode. And now with this one selected, if I try to make any change in the object properties, then you will notice that the same changes will be applied to both the bones because it controls the armature as a whole and not a single bone. So to see the controls of this individual bone, we have to press N to open the side toolbar, then select item category here, and here we find the individual parameters. Now see, we don't have anything to do with the location in any of the three axes. Like you can see that we won't make the head of the robot like this, and even the scaling, we won't really need this thing. So what you can do is that you can lock these values so that you don't accidentally change anything, and then in the rotation, we'll want these values like rotation in the x-axis, rotation in the y-axis, and rotation in the z-axis to move the head and the neck of the character. So we'll assign these values to the circular control with the driver settings. So first of all, for the rotation in x-axis, I'll right click here, then add driver. Then in the variable object, let's take this eyedropper tool and select the circle. Then again go to the x-axis rotation, right click, edit driver, and in the type, I'll change this to x rotation only. And in the space, keep selecting the world space. And then if I go to the object mode by pressing Ctrl Tab, then if I select this circle and try to rotate it by pressing R, then you will see that the head is also rotating in the x-axis. After this, let's again select this armature or the bone, press Ctrl Tab. Let's also enable the X-ray mode. And now I'll go to the rotation in the y-axis, add a driver, then in the object, select the required circle, change the type to Y rotation and keep the rest of the things as same. And at last I'll do the same thing with the rotation in z-axis, add a driver, select the object which is the circle, dot 003, and I'll keep the world space as the space, and in the type I'll change this to the Z rotation. After this, let's go back to the object mode, select the circle, and if I try to rotate it in the x-axis, then the head will rotate like this. If I rotate it in the y-axis, then the rotation happens like this, and similarly here is the rotation in the z-axis. Now in a similar way, we'll be creating one more circle that will be for the lower part, or basically for the neck. So I'll press Shift D to create a duplicate of this. Then I'll scale this down by pressing S so that we can select it easily and it will be easily identifiable. Then press Ctrl A to apply the scaling. And after this, I'll again select this bone or the armature. Then press Ctrl Tab for the pose mode. Select this bone and we'll repeat the same procedure. That is, I'll go to rotation in the x-axis, right click, add driver, then in the object, select circle.004 or whatever the object is in your case. Then in the type, select X rotation, and let's do the same thing for the other two parameters. After this, let's go back to the object mode by pressing Ctrl Tab. And if I now select this circle and try to rotate it in the x-axis, you will see the changes happening in the neck. If I try to rotate it in the y-axis, you will see this, and similarly in the z-axis. Although I don't think that this will be used very much because most of the times you'll be using this only for the rotation part. So I think that for now I should hide this, and we'll unhide it only if we need it in the scene. For now we'll go with this one only. Now I have selected this, and currently if I try to rotate, then you will see that it rotates very much. So it means that we have to set some limitations or constraints on its rotation. So for this, let's go to the object constraint properties for this circle, then add object constraint and select limit rotation. So first of all, we can see that if I try to rotate it in the x-axis, we can rotate it by something about 10 or 12% like you can see here. So I'll undo this and go to the x-axis. In the minimum, I'll type -11, and in the maximum, I'll be typing 11. Now if I try to rotate it in the x-axis, then the rotation will get restricted to 11 meters in both the negative and the positive x-axis. Similarly, let's check the same thing for the y-axis. Like I think it should be around 90 degrees only, because we don't want the robot to see complete 180 degrees. So I think I should keep this to -90, or maybe let's keep this to -80 and the maximum to 80 degrees. Now let's check by rotating in the y-axis, and it gets restricted like this. Similarly for the z-axis, let's check this, that the minimum should be around -15 or -16, and the maximum should be around 10 degrees, or maybe let's reduce it so that it does not overlap with the body. So we can keep it to 8. So I'll go to z-axis. In the minimum, I'll type -15 just to be safe, and in the maximum, I'll type 8. Let's now rotate it by pressing R and Z, and this is how the rotation is restricted. So you can press R to rotate it like this to check if everything is proper or not. And here I think that if I rotate it in the x-axis, then at some points the object might intersect or collide with the body, which we don't want to happen. So I'll slightly reduce the z-axis maximum to, let's say, 7 or maybe 6. And now I think it should work properly. So we are done with the rigging, and I think I should change these rotation values back to 0. We have the head of the robot rigged, we have the arms rigged, and we also have an overall control system that we can use to easily animate the object, make any changes, and one main control to move the object. And here we notice that this control is still missing here. So what I'll do is I'll select this circle, then with the shift key hold it, select this one, then press Ctrl P for the parent menu and set parent to object. Now, even though we won't be using the circle that we created, which is for the neck part basically, but I still think we should parent it to this bigger circle so that if later on we want to use it and we move the robot somewhere else, it will be easy to track it. So I'll select this, then with the shift key hold it, select this one, then press Ctrl P for the parent menu and set parent to object. Now if I select this circle and move it around, then all the body parts along with the controls will be moving. Now before saving this file, I'll check if all the controls are at their lowest positions or not. Like this one was not at the lowest position, so I moved it down in the z-axis. And apart from this, let's say you want these to be fixed in x and y axis positions. For example, if you move this around, it might get relocated to some other position that you might not want. So to ensure that this does not happen, you can click on this lock buttons for the x and y location, and if you try to move it now in the x and y axis, you will see that nothing happens. Similarly, I'll do the same thing with this one also, and for the z-axis I'll try to push it down, and it's already at its minimum position, so I won't make any other changes. Similarly for this one also, I think I should lock the x and y positions, and maybe also the z-axis, because it's not related to any driver or anything else. Let's do the same thing with this one also, because these are only for rotation and nothing will happen if we change their positions. And with this, we arrive to the end of the 6th module. In the next one, storyboard and scene planning. Welcome to the 7th module, Storyboarding and Scene Planning. This one is going to be a very short module where I'll explain you what storyboarding is and how it can be helpful, how much time should you give it, and also about how to plan your scene. So storyboarding usually sounds boring to a lot of people because most of us just think about a concept, then we open Blender and we right away start with animation. But the truth is, storyboarding saves us from several problems that we may encounter later on. It's basically like an animation blueprint. Before you actually animate something, you need to sketch out the important shots, like who the characters will be, what will the character do, what action will the character perform, and how the story will flow. It doesn't really have to be very pretty. It can just be a rough sketch of what the animation is about, because see, the goal of storyboarding is just to visualize the sequence before you actually invest your time and energy into modeling the stuff, working with the keyframes, adjusting the lighting, and rendering everything. So storyboarding might feel like some extra work initially, but it's actually the smartest way to start. You can storyboard on a paper pen, or you can use any 2D software like Krita, or even Blender has grease pencil. So you can use any of these for storyboarding. And then comes the second thing, which is scene planning. This is where you decide the technical stuff like camera angles, lighting direction, environment layout, where you'll be placing the assets. This is something that you can either do initially, but when the animation scenes are very complex, then in those cases, it's usually preferred to do the exact scene planning as and when the things keep happening. Like you get the main character, you get the other assets in the scene, and then you will decide how the lighting will work, which environment should you use, should you delete some assets or should you add some assets, and other related things. To summarize everything, you just need to remember that you first need to plan what animation you're going to create. For that, you will obviously use storyboarding, and then you have to plan the scene, like where the assets will be placed, how will the lighting and environment work, and related things. So this was a short module about storyboarding and scene planning. And in the next module, which is module number 8, we'll start with designing the environment for the robot project on which we were already working. Welcome to the module number 8 of the Blender 3D animation course, setting up the environment. In this module, we'll continue with the project of that robot as we'll set up the scene, and along with that we learn about importing assets from external websites, using them in your own projects, and the placement of different assets. So we are back in the scene where we created this robot model, and the first thing that I'm gonna do is to select the circle at the bottom, which is the control for moving the whole body of the robot 3D model, and I'll move this up in the Z-axis over here. And to be very precise, I'll go to the object data properties and I'll set the Z location to exact 0 meters. Now in this robot project that we are making, we'll basically have a sci-fi lab where we'll have this robot and we'll be making some animation with it. But in terms of the environment, what we need is basically a sci-fi lab. So now we have two ways from here. The first one is to actually model each and everything for the sci-fi lab, like the floor, the walls, then you can have some glass vessels, some cool tech related or some scientific things. But since we have already done a lot of modeling here while making this robot, and this is not really a modeling course but rather an animation course, so our main focus would not be on this. We'll be going for the second way that will make our work a lot easier, and it is to basically import the assets from some external website into the Blender software and then use it for our own project. Now there are many websites from where you can import the assets, but the one that is preferred by most of the people is sketchfab.com. Here I can search for any 3D model. Let's say I type lab and press enter, then this will display me all the 3D models and the scenes, and some of them will be free while the others can be paid. Like you can see this dollar sign on this particular asset, meaning that this one is a paid asset. Some of them has this download sign which indicates that you can download the asset, because you might also find some others which cannot be downloaded, like this one. You don't have any download button over here, so it won't be possible to download this 3D model. Now the one that we'll need should be something related to a sci-fi lab only, like we have this one. So let's take a look at this. Here we can see that we have this lab, and I think that this can be great for our project. So I'll scroll down and you can even check the license. Here it is mentioned that it is Creative Commons attribution, meaning that you can use these files for your own project, but you need to give the credit to the owner. So what I'll do is I'll download this 3D model by clicking here, and then it will ask me to log in. And once you do all that, this download page will appear, from where I'll choose the USDZ format. So I'll click on this download button, and once it is downloaded, we'll return back to the Blender file. And to import that asset in this file, you have to go to the file menu on the top left corner, then go to import and select universal scene description. Then select that particular folder. Within a few seconds, the asset will get added in the scene, and in the scene collection on the top right corner, you can see that the collection is named as scene. So if I have to move it as a whole, I'll left click to select this, then press G to move it around. So first of all, I think that we should rotate it in the Z axis by 90 degrees, or maybe let's rotate it in the Z axis by -90, and let's scale this up by pressing S like this. Let's change the angle to see how everything is looking, and I think that we should scale it up even more. So I'll press S to scale it up like this. For scaling, you can take the reference of the robot's height, and the sci-fi lab should be approximately twice the height of the robot. I think we should increase the scaling a little bit more like this and left click. Now before I begin making this course, the idea was basically that the robot will be in a sci-fi lab, then we'll have maybe a wall of glass in front of him where he will be finding a way to go out. So he will throw something on the glass and then the glass will shatter into pieces. But when I saw this sci-fi lab scene asset on the Sketchfab website with all these things, I realized that we can do one more very interesting thing, which is to place this robot inside this glass structure that you can see over here. We have this cylindrical glass, so we can keep this robot inside this. Then we'll create an animation where the robot will move up and down a few times. Then from above, it will pick up a ball, then it will throw it on the glass, which will make the glass to shatter, and then it will come out of this glass capsule. So to bring this animation into reality, we have set up this entire scene and also the robot here, and currently I don't think that there's anything else we need here as far as the environmental design is concerned. So we have everything now, and I think that we can now start with the module number 9, which is animating the full scene. Welcome to the module number 9 of the Blender 3D animation course, Animating the Full Scene. This module is the most important one out of all the modules in this course, because in this module, we'll actually be animating this complete scene of the robot in the sci-fi lab, and during this process, you will notice that we are using the principles and the concepts that we have studied till now in this course. And not just that, we'll also be looking at some new concepts, all of this packed with a lot of action, knowledge, and understanding of 3D animation. So here I am back in this scene where we have the robot and the sci-fi lab, and the first thing that I'm going to do is to select this circle which controls the robot, and we have to place this robot inside this cylindrical capsule that we have in this sci-fi lab. So to do this thing, let's first go to the top view by pressing 7 on the numpad. Then I'll select this top part of the sci-fi lab, which is basically the roof, and I'll be hiding it for now so that we can place the objects properly. Then I'll select the circle.002 in the scene collection, press G to move this, and I'll place it somewhere over here. We can adjust the final position later on. And after this, let's press Alt Z to turn on the X-ray mode, and I think I should move it slightly upwards over here. Then I'll go to the front view or maybe the side view and check if everything is proper or not. So you can see that we can slightly see some part of the capsule from here. Let's see it from here for more visibility. I think we should push it slightly backwards because we'll be animating the arms of this robot and they will be moving forward and backward. So it might be possible that the size of the cylindrical capsule won't be enough. But if that happens, we can scale this part so we don't need to worry about it very much. For now, I think that the placement of the robot looks completely perfect. So after this, the next thing that I'm going to do is to change this window to the timeline editor. So let's select the timeline, and for the number of frames, I'll enter the start value as 1, and for now we don't know how long the animation will be. Let's say 600. Now if I go to the render preview mode and zoom in here to see how the robot is looking, then we'll notice that this blue colored glass isn't really looking very nice because it's not really very transparent, and since our robot is the main character and we learnt in the principle of staging that it should be easy to spot the character and understand the animation, so it's really important that we change the material of this cylinder. Or maybe I think I should go to the edit mode first to take a look at the topology and its geometry, and here I can see that its geometry is not really very good. If I turn off the X-ray mode, then it's clearly visible that this mesh is made up of the tri-faces, that is, these have 3 vertices, which is not at all suggested for a better topology and geometry. So what I'll do is I'll delete this cylinder by pressing X and delete, and we'll be adding our own cylindrical object here, and then we'll apply some glass material to it. To add the cylinder, press Shift A, then go to mesh and add a cylinder object. Then press tab to enter the edit mode, press S to scale it up like this, and let's scale it up in the Z axis also. We'll adjust the final scaling once we place it over here. So press 7 on the numpad to go to the top view, press G to move this, and let's place it over here. After this, let's change the angle and I'll move it upwards in the Z axis like this. Now I'll go to the edit mode. I think I should slightly scale this down like this. Let's move it upwards over here, and then I'll again scale this up. Let's change the angle to see if it's proper or not, or if the position needs any changing. Like I think I should move this slightly in the Y axis over here, and also let's shift it slightly in the X axis like this. Let's take a look at the bottom part also. So I think I should scale this up in the z-axis. Let's again check from the top, and now I think that the cylinder is almost properly placed. Like I can just shift it slightly forward in the y-axis, and now it looks perfect. Then let's shade auto smooth by right clicking, and after this the next thing that we'll do is to give this some material. So let's go to the render preview mode, and currently it has the default white material applied, but to change this I'll switch this window to the shader editor, then create a new material, and instead of the principal BSDF node which I just deleted by pressing X, we'll be using the glass BSDF. So press shift A, then go to shader and select the glass BSDF node, connect the BSDF socket to the surface. This will make it look very weird because of the index of refraction value, but if I change this to 1, then we'll be able to see the original robot model without any refraction effect. Other than this, I'll change the distribution method to Beckman, but because of doing this, it's not really looking like a glass material, but it looks completely transparent as if there's nothing here. So to avoid this, I'll increase the roughness value to, let's say, complete 1, and we see a slight look of the glass material. To make this even better, I think I should keep the IOR value to something like 1.1, or maybe let's bring this down to 1.05. Maybe let's tweak it a little bit more. Let's change this to 1.02, and I think it's getting better. Let me try 1.015 or maybe 1.01, and I think that this material actually looks like a glass material. We can see its boundaries properly. It looks a little condensed, and it's giving the material a nearly perfect look. Now I think that we can also begin with animating the stuff, and we'll start with animating some properties in this glass BSDF node, because see, till now we have understood that you can animate different objects in the scene by adding the keyframes, but let's see how we can animate a property, for example color or this roughness value, and see it change frame by frame in the animation. So to do this thing, let's first get the timeline editor here. So with my cursor over here, I'll right click, then horizontal split and create a window, then change this window to the timeline editor, and I'll keep the pointer at the frame number 1. So now let's say I want the color of this glass to change from the blue color to transparent white. So what I'll do is I'll first change this color to blue, then after this with my cursor over color, I'll press the I key, and this will insert a keyframe at the frame number 1. Then if I take the pointer at the frame number 50 and then change this color to the white color, or I can press the backspace key to get it to the default position, and then with my cursor over the color again, if I press I, then this will insert another keyframe at the frame number 50. This means that we now get an animation of the transparent glass changing its color from blue to white like this. This can actually look great as the introductory part of the animation that we are going to create. So I think that we should go for this animation here. Also, I think that this IOR value is still very high, so I'll be changing this to 1.005 this time, and I guess it looks better now. Other than this, I'll return back to the solid view, press Alt Z to turn on the X-ray mode, and the next thing that we're gonna do is to create an animation of the robot moving up and down. So I'll first take the pointer at the frame number 1, where initially I'll be keeping it to somewhere around 5.28 meters in the z-axis over here, and I'll press the I key to insert a keyframe. Then I'll take the pointer to, let's say, frame number 40, and at this frame I'll slightly move it up in the z-axis. Let's say I move it to somewhere over here. Let's change the angle to see if everything is proper or not. Then I'll press I to insert another keyframe, and we want this animation of up and down movement to happen a few times in the starting. So what I'll do is I'll select these keyframes, press shift D, and I'll place them in such a way that the starting frame is at frame number 80 or maybe 81, and the ending at frame 120. After this, I'll again select both of these, press shift D to create duplicates, and I'll place them over here, one of them at the frame 160 and the other one at the frame 200. And we need to do the same thing till the frame number 320 or 360. So to repeat the same process again and again, you can use the shortcut which is to press shift R. That will repeat the last action that we did. So I press shift R twice, and I got these keyframes added in the timeline editor 2 more times. So I have the same animation till the frame number 360 of the robot moving up and down. Now this will give us a nice animation of the robot moving up and down after every few frames, and if needed, we'll add or reduce some of these keyframes if we want to make it longer or shorter. But for now, I think that we should have it till the frame number 360. After this, the next thing that we have to do is to think about how the animation will proceed. So initially, for the first few frames, only the robot will move up and down, and we won't be having any such other activity. Basically, we'll see the camera zooming into the robot, let's say till the first 150 or 200 frames. We'll also see the animation of the change in color of the cylinder from blue to white as we animated this property from the frame 1 to 50. And after that, somewhere around the frame number 300 or maybe 320, the robot will move up and it will rotate one of its arm to pick up a ball that will be there on the top of the cylinder, and then it will use that ball to break this glass and come out of it. So to create this animation, we'll have to animate this particular control. Basically it's Z location because that is controlling the rotation of this arm. So currently the robot is in the downward direction. So with this control selected, I'll press I to insert a keyframe at the frame number 325. Then we'll take this pointer to that particular point where the robot almost touches the top, like I think around frame number 350 or maybe 355. At this frame, I want this to rotate its arm in the Z axis. So I'll move this control up like this and left click. Here I'll press I. And I think that I should move this keyframe to frame number 350 because we'll be having the ball over here and it should be slightly visible in the camera also. So we won't be keeping it too high. Let's keep it to 349. And I think that now it looks better. Then after it picks the ball, the robot will begin to move down and somewhere around the frame number 385 or maybe 390, it will come down and we'll animate it in a little while. But till around here, I want the arm of the robot to be rotated like this. So I'll create a duplicate of this keyframe by pressing Shift T and we'll place it at the frame number 386, and we can adjust this later on after we animate the upward and downward movement again. So the last time we animated it till 360, and I think I'll need to duplicate these two keyframes at the end in such a way that the first one falls at the frame number 400 when it will return down to the default position or basically the rest position. And after this, I think that the robot will begin to throw the ball, and so it should not really move in the upward direction again. So I'll delete this keyframe over here by pressing X, and now what we have is the robot moving up and down. And then at somewhere around the frame 350, it rotates its arm to pick up the ball, and after that it comes down and then it will rotate its arm back over here in the middle. So for this, I'll take the pointer to, let's say, at the frame number 400 after it reaches down. We'll take a few frames as extra because we don't really want the animation to go super fast. And this is something that a lot of people ignore while animating something. Like if you don't give some gaps in between the keyframes, each and every action will happen very quickly. Like let's say, as soon as the robot comes down, if there are no frames between the next animation which is going to happen, then the viewer will not get time to understand what actually happened, and so it's not really a very good practice. So we have to avoid this thing, and as a result, you can see that the robot actually comes down at somewhere around frame number 397 or 398, but we'll move a few frames ahead, let's say at the frame number 402, and then I want this to come down like this. So I'll press I to insert another keyframe here, and this is how the animation will happen. It will first move up, where its arm will also be rotated upwards. It will pick up the ball and the arm will stay like this for a few frames, and just as it is about to move down, the arm will rotate as it will throw the ball, and it is at this particular frame only that the glass will shatter. But we'll deal with it later on because we first have to fix other things, like we have not yet animated the head of the robot. So to do this thing, we created these two controls where one of them is for the neck, and I don't really think that we'll require it, so I'll be hiding it for now. And I'll select this particular control which is for the overall head of the robot, so I can press R to rotate it or do the same thing in a particular axis. So initially in the first few frames, when the object moves up and down, there won't be any change in the rotation of head. Let's say at the frame number 100. So till here we won't have any changes, but after that we can rotate the head in such a way that will make it appear as if the robot is looking around in both the left and right directions. And to do this thing, I'll press the I key to insert a keyframe at this frame 100. Then I'll take the pointer to somewhere around 125, and at this frame I want this to rotate the head in the Y axis on this side. And if you want to see the object properly, I think we should hide this cylinder. We'll unhide it later on once you're done with animating. So we were rotating the head in the Y axis. I think we should keep this rotation in Y value to somewhere around -20 or -21, and then press I to insert a keyframe. So the head will rotate like this as it moves up, And then let me show you one thing. Let's say at the frame 150 or maybe at frame 160, I want this head to rotate in the other direction. So I'll go to the rotation in the y-axis and change this to positive 21 and press the I key. But if I now go to the frame 100 and try to show you the animation, then you will notice that it looks very unrealistic. Like the head first rotates in this direction and then it doesn't even stay there for a little while and it immediately rotates in the other direction. And that was the reason why I explained you to keep a gap with some frames where the object stays still in that position, and then after those frames the object will show the next action. So I'll select this keyframe over here and I'll press Shift D to create a duplicate, and I'll place this on the frame number 140 so that the head will be in this rotation for a little while. And after this, I'll take this keyframe over the frame number 165 or 170, or maybe I should keep this to 185 or 190. Let's see how fast or slow the animation is. And then again, with this keyframe selected, I'll create its duplicate and keep it till the frame number 200 to make sure that there is no change in the rotation. Then we'll want the object to return back to the default state, that is, with the head rotated in such a way that it points towards the center. So for this, I'll take the pointer at somewhere around the frame 250 or 255 as it just begins to move up. Let me keep it at frame 255 for now, and I'll change the rotation in the y-axis back to 0 and then press the I key. Now I'll again take the pointer back and press the space bar to see how the animation looks. So I think that the overall animation is looking nice as of now. And apart from this, if I change this window to the graph editor, then you can see that this is how the curves look. We have the default curves only, and according to me, there is nothing much to change in this because the easing in and out effects are actually giving it a very realistic look. But if you want the speeds to be consistent throughout or basically uniform, then you can select the frames and change the interpolation type to the linear method. You can press the T key for the interpolation menu, but I don't think that's required because that would make the movements look very unrealistic and robotic, but we don't want that to happen. That slight easing in and out effect is really looking good for the animation that we're trying to create. So we won't be making any changes here. And I'll get back to the timeline editor where we made the rotation like this at the frame number 255. And then I want that as it moves up to pick up the ball, that is somewhere around the frame 330 or 340, it should rotate its head up like this. And to make this happen, I'll first select this keyframe over here. Then I'll press Shift D to create a duplicate and I'll place this at the frame number 280 so that there's some gap or some empty keyframes here. Then I'll take the pointer to, let's say, at the frame number 330. And at this point, I want the head of the robot to be rotated in the z-axis like this. So I'll change this rotation value to something like -19 or maybe -18 and then press the I key to insert another keyframe. Let's take a look at how the animation appears now. And I think that as of now, there's nothing much to change in this. We have all the keyframes and the animations at almost the perfect timing. So I'll now take the timeline pointer to somewhere around frame 380 or 390, and at this point I want this keyframe to be duplicated. So I'll select this, press Shift D to create duplicate and place it over here, because here we'll have the robot moving up and I want that its head should still be rotated in the z-axis like this as if it's looking up to pick up the ball. So till the frame 390 we'll keep it like this and then it will throw the ball. So at the frame number 410 or 420, I'll insert another keyframe, but before that let me change the rotation in z-axis back to 0 and then press I to insert a keyframe. Let's take a look at the animation that we created. And I think that the overall animation is looking pretty good. We cannot be exactly sure right now that how the animation will turn out to be because it will depend on the timing of the glass breaking or shattering, but we still have the basic keyframes ready, and if needed, we'll make the changes in these according to the timing of the breaking glass. So we are done till here. And after this point, we'll be having the glass shattering. The next part of the animation is basically that once the glass breaks, the robot will come out of this capsule and it will land down on the plane and then it will look around and perform some actions with the eyes, but we'll deal with that later. First of all, I've selected this control, which is for moving the body, and you can see that we have animated it till the frame number 400 where it was moving up and down like this. And after that, it won't immediately move anywhere because we'll have the glass shattering animation. So we'll allow it to stay just like this for a few frames, let's say till the frame 440 or 450. So I'll press I to insert a keyframe here. And after this, we want it to first come forward in the x-axis. So let's say at the frame number 450 or 460, I move this forward in the x-axis. Let's say I place it over here, or maybe let's round off this value to 12. Also check this thing from the top view. I think we should keep this to 11 or 11.5 so that it's slightly more forward in the x-axis. Then press I to insert a keyframe here, and then it will move down. So let's say till around frame 465 or 470. It will come down in the z-axis like this. We can go to the front view to see the positioning of the robot. I think we should slightly reduce this, let's say to 0.5, and press I to insert another keyframe. So we'll have the animation of the robot coming down like this. And after this, I think we can now work on creating the glass shattering animation. So I'll take the pointer to, let's say, 480 frames, and I'll unhide the cylinder. Let's also turn on the X-ray mode because we'll need to see the movement of the robot. And here the robot will be moving up and down, then it will rotate its arm, pick up the ball, and after the frame number 376 or 380, or to be more precise, I think at the frame 389 or 390, the robot will again rotate its arm to basically throw the ball. And I think that somewhere around the frame 393, the ball should touch the glass and then it will break. So to ensure that the shattering animation will be exactly correct, we need to make the ball first and create the throwing animation. To model the ball, we'll be having a very simple UV sphere in the scene. To add it, press Shift A, then go to Mesh and select the UV sphere. Press Tab to enter the edit mode, and we'll scale this down by pressing S like this. Let's move it up in the Z axis to see its size, and let's then switch to the front or the side view depending on the scene. Press G to move this, and I'll place it over here. Then go to the top view to adjust its position in the X axis. So I'll press G, X, and let's place this over here. Now I'll change the angle. Let's zoom in to see where exactly it is placed and where it should be. So at around the frame number 389 or 385, we have the arm rotated in the upward direction. So the ball should touch the hand of the robot at this point. So I'll go to the top view by pressing 7 on the numpad. Let's zoom out, and here we have the ball selected, and over here we can see the arms. So I'll press G, X, and place this over here. Let's change the angle now, and we can see that now the ball is almost touching the hand of the robot. Let's replay the animation where the robot is at the maximum height. So I'll select the circle to check the keyframe, and I think it's keyframe 360. Yes. So I'll select this ball, and after this I'll move this up in the Z axis and place it over here. And the ball will stay at this particular position only for the first 350 or 360 frames depending on when the robot will pick it up and throw it. So I think that if I keep it to somewhere around 365, then I can insert a keyframe here. So till here, the ball will not move at all. And beyond this point, as the robot will move in the downward direction like this, the ball will also move down with it till the frame number 390, because after that the arm will rotate and the ball will be thrown. So I'll press G and Z to move this down like this, and left click, press I to insert another keyframe. After this, let's check how the animation looks and whether the ball is following the path of the hand or not. So I'll press the space bar to play the animation, and I think that at some points the ball is moving down too quickly. Like at the frame 377, you can see that it kinds of intersects with the hand. So we can fix this by moving it slightly up in the Z axis and inserting a keyframe here. Let's move forward in the animation, and we again notice the same thing happening. So I'll move this up again and press I for a keyframe again, and then at somewhere over here the animation will end. So I don't think that there's anything else to change here. Like till the frame number 390, the ball will follow the movement of the hand like this, and after this we have to create the animation where it will basically throw the ball. And here I think that we need to relocate it in the x-axis because you can see that it's not really at the exact correct position. So what I'll do is I'll take the pointer to the frame 364, and then I'll move this in the x-axis and place it back over here. Then I'll copy this value by pressing Ctrl C, then right click to replace the single keyframe, and then I'll take the pointer to the next keyframe, then paste this value in the X location, then right click and select replace single keyframe. Then I'll repeat the same process for the next two keyframes also. But here on the last one, I think that the placement of the ball is correct. But if I take the pointer to the left, like at the frame 387 or 388, then the placement in the x-axis is not correct. So what I'll do is I'll delete this keyframe by pressing X, and I'll add a new keyframe at the frame number 389 by moving this down in the z-axis over here. Press I to insert a keyframe, and now let's check this again. And this time I think that it actually looks very nice as the ball is properly following the movement of the hand. Also, I think I should apply the shade auto smooth to this ball to make it appear smooth. And let's also see this thing in the render preview mode. So we have the ball here that the robot will throw in the forward direction, but currently does not have any material. So to give this some material, let's change this window of the graph editor to the shader editor. So I'll select the shader editor from the list and create a new material. Also, I think that to apply the material properly, we need to focus on this UV sphere. And to do this, you can click the / button that will keep the focus only on the selected object. And we won't be making this very highly detailed. We'll only add some green color to it along with a very simple noise texture. So I'll press Shift A, then go to texture and select the noise texture. Let's place this over here. Take the factor socket and connect it to the base color. This will give us this texture over here, which we can change with the scale value. So I'll keep this to something very high, like 50. I'll also increase the detailing to 15. And then to apply some colors to it, we'll be using the color ramp node. So press Shift A, then go to converter and select color ramp. Let's place this over here. Then this part will control the black color and this one will control the white color. So with this pointer selected, I'll click here to change the color to something green. And for the second pointer, I think the black color is looking fine, so I won't be changing it. If you want, you can change this to anything else, like maybe blue or yellow, and you can even increase the brightness from here, and you'll see the color of the texture change like this. But for now, I think that I should go with the black color, so I'll change this to black, and I can even adjust the pointer's position to change the way how the texture appears. Also, to give this a 3D look or the bump effect, we'll be using the vector bump node here. So press Shift A, then go to vector and select bump. Let's place this over here. Now take the normal and connect it to the normal in the principal BSDF. And for the input, I'll take the factor socket of the noise texture and connect it to the height in the bump node. Now this is how the ball appears. You can control the bump strength from here, but I think I should keep this to 0.5 and now it looks better. So let's go back to the overall scene by pressing the / button again. Now I'll switch to the solid mode, and after this the next thing that we'll do is to create the throwing animation of the ball. So after the frame 389, the ball will be thrown and it will land somewhere over here because it will be thrown like this. And I think that the ending frame of the throwing animation will be somewhere around frame 420 or 425. So at this frame, I'll go to the top view and we'll place it over here. Let's also change the angle and move this down in the z-axis over here. Now if I press the I key to insert a keyframe and take the pointer here and try to scrub through the timeline, then you can see that this is how the throwing animation looks. To see it even more clearly, I'll zoom in and then take the pointer over here and see the animation. Here I think that the speed of the throw is very slow initially, which we can fix with the graph editor. So I'll change this window to the graph editor, then go to sphere action, and in the object transforms, I'll hide all the graphs except the X and the Z location. And after this, let's zoom into the graph to see everything properly. And here we have the graph where the throwing action will start from the frame 389. That is this particular point which is selected here. And if I press the T key to open the interpolation menu, I can change this to linear and then see how the animation looks. But I don't think that this will really be the correct solution because what we actually need is to change the graph of the x-axis. So I'll undo this by pressing Ctrl Z twice, and instead of this I should go for the x location graph, which is over here. So I'll zoom in and I'll select this pointer at the frame 389, or maybe I should select this handle, press R to rotate it, and I'll make it like this. Now I'll press the spacebar to see how the animation looks, and I think that this time the throwing animation is a lot better than before. We can also move this slightly downwards like this. Let's again view the animation. And I think we should go frame by frame to see where we get to see the error. Like over here, even though the hand has moved forward in the x-axis, the ball is still over there, which we can fix by moving this in the x-axis and adding a manual keyframe here. So I'll press I to insert a keyframe, and this will also change the graph because we'll have a steeper slope. Also, I can select this handle of the new keyframe that we have created and press R to rotate it like this for a faster animation. Now let's again go frame by frame to see if any adjustments are needed anywhere. But now I think that the throwing animation looks a lot better than before. Let's confirm this thing by taking the pointer to frame 360 and pressing the space bar to play the animation. So the throwing animation looks perfect for now. We won't be making any other changes. And the next thing that we're going to do now is to unhide the cylinder, or basically the glass that we're going to break. And I'll take the pointer to, let's say, frame 390 or maybe 393, where the ball just emerges out of the glass. And it is basically this exact frame where we want the glass to shatter. So in order to make the glass shatter, there can be two different methods. The first one can be to use the cell fracture extension or the add-on that is already present in Blender. You just have to install it by going to Edit, then Preferences, and there you will find the option to install the add-on. But in that case, we'll have to work on things like rigid body physics, and it will take up too much of our time. But the other method, which is much more convenient right now, is to use the quick explode method. To see how it will work, I'll first make sure that the cylinder is selected here, then go to Object Settings on the top, and in the Quick Effects you will see we have some options like Quick Fur, Quick Explode, Quick Smoke, and Quick Liquid. Out of these, I'll be selecting Quick Explode, and on doing this, if I now press the space bar to play the animation, then you will notice that we have a weird looking quick explosion effect added to the object, which obviously is not really looking very good, but we can fix this by making some changes in the object's geometry. Right now you can see that it's very low poly, and that's why we were seeing this result. But if we add some loop cuts here, if I press Ctrl R to add some loop cuts like this, let's say I add 60 loop cuts, then press left click and right click to cancel the movement, and press tab to return back to the object mode, then this will give us a cylinder with more geometry to work with. Apart from this, there is one more thing that we can do, which is to give some thickness to the cylinder object. This will help to make the glass look a lot more realistic than it is right now. So if I go to the edit mode, then select these two faces on the top and the bottom, press X to delete faces, then press A to select all, press E to extrude, then right click to cancel, and press S to scale these down. Then let's scale these up in the Z axis to level the faces as per the outer boundary, and then we'll return back to the object mode. Now if I again go to the frame number 390 and press the spacebar, then this is how the animation is looking. Obviously it does not really look like a glass even right now, but we can fix that by changing some of the settings in the modifier as well as the particles. But before that, I'll go to the edit mode, press A to select all, and I'll subdivide this one more time so that we have even more geometry than before. Let's try this one more time by clipping the pointer over here and pressing the spacebar, and this is how it looks. And now the first thing that I'm going to do is to go to the modifier properties, and in this explode modifier which is added, I'll enable the size option that will allow us to use the particle size, and after this I'll go to the particle settings, and currently we are seeing very less number of particles, so I'll increase the number to something very high, let's say 12,000, and this will add so many particles of glass in the scene, but currently their size is very small. So to fix this thing, what we have to do is basically create an instance object that will replace these particles, and then we can adjust its size from the particle settings. So to actually do this thing, I'll be adding a plane in the scene. So press Shift A, then go to Mesh and select the plane. Let's move it in the x-axis over here. Let's zoom out to see where it's positioned. And after this, I'll go to the edit mode. Let's scale this down by pressing S. Press E to extrude it up like this. We won't be making it too thick, but it should have some extrusion effect so that the glass will be visible in a much better way. Then press A to select all. Press Ctrl B to apply some bevel with some segments. And since the glass is broken, so we also need to make sure that we delete some parts of it. Like for example, I can add some loop cuts here. Let's add some loop cuts here as well. And then I can select some parts, press X to delete the faces. And this thing can be completely random depending on how you want the glass to look like. So these will basically be the broken pieces. I can select these faces and delete them as well. Let's select these over here also. So you can delete these random faces like this. And once all this is done, the next step will be to use this object as the instance object for the particle settings. Before that, I'll right click to apply Shade Auto Smooth, and let's also try to apply some subdivision. So I have used this modifier with the level viewport value set to 2, and I think I should slightly scale this down in the y-axis to give this a rectangular look like this. And now I think it looks fine. So the next thing that we'll do is to move this in the x-axis over here so that it won't come in the scene or the rendered version. And after this, I'll select these glass particles, then go to the particle settings, and to set that object as the instance, we'll scroll down and go to the render settings, change render as to object, and in the object choose the instance object, which is the plane in this case that we have added. And now if I zoom in, you will notice that we have the plane that we created as the particles, but currently all of them are having the same rotation and the same scaling that we don't need. So to make these look completely random and realistic, I'll go to the rotation properties over here and increase the randomize value to 1. This will make all the particles rotation completely random. And then to change the scaling, I can go to the scaling value and I'll change this to 0.08 to make these slightly more scaled up, but currently all of them are having the same scaling, and so we'll randomize the scaling as well with this value, and I'll change this to 1 for completely random scaling for all the particles. And I think I should increase the scaling even more, so I'll change this to 0.12 to have bigger particles of the glass, or else maybe I should bring it down to 0.1 only. Let's also take a look at the final rendered version, if it's really looking good or not. Like currently, I think the cylinder is not having any material, so it's not really giving a glass-like appearance. So to fix this, I'll change this window to the shader editor. Then I'll select the cylinder, or basically these particles. And because of using the quick explode, it applies this other material to the object, or basically these particles. But to get the old material back, I'll just take the BSDF socket in the glass BSDF node and connect it to the surface in the material output. Now let's deselect this, and even right now we are not able to see the proper glass material applied, which is happening because the plane that we're using as the instance object is not having the same material as the glass cylinder. So for the glass cylinder, we had the material.005, but if I select the plane, then it is not having any material applied. So I'll click here and type 005, then select this material, and it will now get applied to the plane object. And if I wait a few seconds for the rendering to get complete, or basically the scene to get better, we'll be able to see the particles having the transparent material, but because of the low index of refraction value, it doesn't really look very nice. So what I'll do is I'll first take the pointer to the frame number 392 where we had the original cylinder, which is not yet broken, and I'll animate the value of IOR, which is index of refraction. So I'll press I to insert a keyframe here, and then for the next frame, when the glass is broken, I'll change this value to something high. Let's say I change this to 2, and then this is how the glass particles will appear. We are able to see them appear much more clearly than before. And so let's add a keyframe here for the IOR value. So I'll press I to add a keyframe here. So to summarize this, we used the quick explode to shatter the glass, and then for the glass pieces we created the plane object, then we applied the material with the glass BSDF node, and then we animated the index of refraction value in order to see the transparency of the glass after shattering in a much better way. And now I think that most of the animation part is done, especially till the glass breaks like this. And even after that, we have the animation of the robot moving down. Like if I move the pointer over here, we'll see the robot moving down. But along with this, we can also make some animations with the head of the character. So I'll select this control over here, and till now we animated till around frame number 415, where the robot's head will come down like this. And I also think that I should hide these particles for now so that we can work on the animation part in an easy way. Now with this selected, if I go over here, then we see that the rotation of the head is in such a way that the robot is facing in the front direction. But in reality, if you take a close look at the scene, we have the glass falling downwards, and as a result, the animation can look much more natural and better if instead of facing forward, it actually begins to look in the downward direction as if it's watching the glass falling down. So what I can do is I'll go to the object properties by clicking here, and I'll change the Z rotation value to a positive number so that it begins to look in the downward direction. So I think 18 degrees should work, and then I'll press the I key to insert a keyframe. After this, the next thing that I'll do is to move this keyframe slightly towards right so that it's around frame 417. And after this, I don't want the rotation of the head to change till it comes down. So I'll take the pointer to somewhere around the frame number 470, or maybe let's take it to 480. And after that, I'll insert a keyframe over here by pressing I so that we won't have any change in the rotation of the head till this frame. But then it will come down, and to make the animation look better, I think the robot should rotate its head first to look here on the left side of the screen, then it should rotate its head on the right side of the screen, and then it should look in the middle. And to achieve this result, I'll take the pointer first to the frame number 501 or maybe 502. And here let's first rotate this in the Y axis, or maybe let's rotate it to this side first. And I'll also rotate it slightly in the X axis like this. Press I to insert a keyframe, and the rotation will happen like this. Now I'll keep the rotation like this for a few frames. Let's say till the frame number 510. So press Shift D to create a duplicate of this keyframe and move this over to the current frame, which is 510. After this, I'll take the pointer to 520, and this time I want to rotate this head of the robot on the other side. So I'll go to the Y-axis rotation and I'll reduce this to something like this. I think I should keep the value at -17 and press I to insert a keyframe. Then I'll create a duplicate of it and I'll place this over here at the frame number 528. And now let's take a look at the animation. So I have taken the pointer to the frame number 360, and then I'll press the spacebar to play the animation. So I think that the animation is more or less looking pretty nice. The only thing that I feel which we can change is the gap that we have here. Like from the frame 470 to 490, I guess we have a lot of gap here. So what I'll do is I'll select all these keyframes, press G to move them, and I'll place them over here. And then we'll have the animation like this. Then I'll take the pointer to frame 530, and at this frame number, I want the robot head to return back to the default position. So I'll change these rotation values, all three of them, to 0 degrees and press I to insert a keyframe. Then it will stay like this for the next 10 frames, let's say till frame number 540. Then after this, I want the robot to look in the upward direction. So I'll change the frame to frame 550, or maybe let's change this to 555. Then let's rotate this in the Z axis like this and press I to insert a keyframe. Then just like before, we'll keep this position as still for some more frames. So press Shift T to create a duplicate, and I'll place this at frame 566. After this, I will again make the head return back to the original state. So I can easily select these two keyframes here, press Shift T to create a duplicate, and let's place them over here in such a way that this animation of the head moving up and down will end at the frame 590. I also think that I should slightly increase the total length of the animation. So I'll change the end frames to 650 for now. And then at around frame number 610, I want the robot to look in front of the camera that I guess will be over here. Currently we don't have any camera in the scene. We'll be fixing that in the next module. But for now, I'll press R to rotate this in the Y axis, then left click, or maybe let's change this to something below 20, like 15 or maybe 12, because we can keep the camera like this. And let's also slightly change the rotation in the Z axis, like -3. We can later on adjust the camera position, and at that time if we need, we can even change the rotation values. But for now I think that these look absolutely fine. So I'll press I to insert a keyframe here. Now we have completed the animation of the robot head rotation after it comes out of the capsule. And the next thing that we're going to do is to go to the render view and check if something is missing or not. Like currently you can see that the robot is moving in the right direction, then in the left direction. But one thing which is missing is that the robot does not really have any expressions. And what we can do to fix this thing is to animate the eyes of the robot and change them from expressionless to the ones with emotions and expressions. So to do this thing, I first have to select the character head, then I'll go to the object mode, press tab to enter the edit mode. Let's also enable the X-ray mode so that we can see the eyes. And we have these faces over here which are circular. It might be difficult for you to select those faces, but you can see this dot over here which is dark colored, and if you click this, then the circular faces will get selected. And the concept that we'll be using to animate the eyes is the usage of shape keys. In Blender, whenever you have to animate something that is a part of the object, like in this case we have the character head in which we have several faces and geometry, but out of that we have to animate these two circular faces of the cylinder which are the eyes. Then in those cases we can use the shape keys, and then we can animate the thing and use them in the timeline editor. To see how we can actually do this thing, I'll be selecting this left eye. And yes, I'm not selecting the entire cylinder but only the front part of the eye. After this, let's go back to the object mode, and I have to check that at which exact frame does the robot rotate its head in this right side of the screen. So I think that at the frame number 492, this rotation happens, and as a result, at the frame 492, we'll be having the first animation of the eyes. Let's select this character head, press tab to enter the edit mode, and with this face selected over here, I'll go to the object data properties by clicking over here in the properties editor. And here you will find the option to create shape keys. But to create a shape key, you must be in the object mode. So first click on this plus icon to create the basis shape key. And this basically stores the default or the actual geometry of the object without the effect of any shape keys or any animation. And then if I click on the plus icon, then this will create the first shape key and we can animate it with the help of this value. Before we do anything else, we first have to ensure that this value is equal to 1, then press tab to enter the edit mode. And let's say I want that the animation should be such like both of these eyes should basically scale down in the Z axis and appear like this. So I'll just scale these down in the Z axis, let's say till this point, then return back to the object mode. And now what I'm going to do is to change this value back to 0. And if I change the angle, let's also go to the render preview mode in order to see the eyes properly. Then with the value equal to 0, in the shape key 1, the object will be at the default state. Basically the eyes will be at the default or the normal state. But if I begin to increase this value from 0 to 1, then you will notice then the eyes begin to scale down. And now we can use this value parameter and we can animate it to create this expression of the eyes. So with the pointer over frame 492, I'll change this value to 0. Then to animate, you can either click on this circle that will animate, or you can press the I key. And after this, I'll take the pointer to somewhere over the frame number 510 or maybe 505, and then I'll change this value to 1 and add another keyframe. This will animate the eyes like this, you can see. I can even play the animation by pressing the space bar to take a look at it. And since we are in the render preview mode, so it might drop some frames and the animation may not be visible very smoothly, but I think I should keep the pointer over here and use the arrow keys to play the animation slowly. So you can take a look at this. So this is how we animated the eyes of the robot character. Now the next thing that I'll do is to return back to the solid mode, and we want that when the head of the robot returns back to the default state or the original state, the eyes should also turn back to normal. So I'll take the pointer to frame number 530, or maybe let's change this to 527, and I'll insert a keyframe over here. Then for the other keyframe, I'll take the pointer to frame 535 and change this value to 0 and add the other keyframe. This will mean that first of all, we have the animation of the eyes being scaled down like this, then it stays like this for a little while, then the robot will rotate its head back to the default position and the eyes will also return back to the normal state. Now in the end, when the robot tilts its head towards the camera, we can add another shape key for the eyes where it will wink at the viewer or the camera. And to make such an animation with the shape keys, what I'll do is I'll take the pointer to the frame number 590, that is just before the character rotates its head to see the camera, and after that I'll change this mode to the solid mode, select the robot head, and we'll be creating one more keyframe. So click on the plus icon to create a new keyframe and it will be named as key 2. After this, change the value to 1 and press the tab key to enter the edit mode. Let's also enable the X-ray mode, and this time we'll only need to select this left eye, and I'll scale this down in the Z-axis like this. And this time the scaling in the Z-axis would be very low because we have to show the eye as if the robot is winking. After this, I'll return back to the object mode and we can now use this shape key value to animate the winking of the eye. So first of all, I'll take this value to 0, then insert a keyframe here, and then I'll take this to frame number 605 and change this value to 1, or maybe let's take this to 599, change this value to 1, add a keyframe here. Then to see how the animation looks, let's go to the render preview mode. And currently the robot is looking in the upward direction, but as we move a few keyframes ahead, then you will notice that the robot will rotate its head, and during this rotation it will also wink at the camera. But we still have to add one more keyframe where the eyes of the robot will be opened. So let's say at the frame number 610 or 11, I'll go to the value option in the key to selected and I'll reduce this down to 0 to get back to the original state, and then I'll insert one more keyframe here. With this, we just created a new animation with the help of shape keys where we have the robot's eye winking, and previously we created one more animation with the shape keys where the eyes of the robot were scaled down and scaled up like this. So you can even create some more shape keys with the eyes or maybe some other part of the robot's body, but for now I think that we don't need it for this animation, so I won't be doing anything else. And I'll go to the frame number 1 now, and let's see if there's anything left in the animation or if we have missed something or not. So I'll press Alt Z to turn on the X-ray mode, because initially we have this glass cylinder present over here, so we won't be able to see the animation on the robot. So I'll press Alt Z to turn on the X-ray mode. Then for the first few frames, the robot's body will be moving up and down, then it has the animation of the rotation of head, and then somewhere around the frame number 340 or 350, its hand will rotate like this to pick up the ball, and then at frame number 390 or 392, the robot will throw the ball on the glass, then the glass will shatter like this, which we can also see in the render viewport to check how it appears. And I think that it actually looks very nice. The only thing that we can change in this glass is the size of these particles after they break down. So I think I should select that plane that we used to create these particles. Then to keep the focus on the plane, I'll press the forward slash button, then go to the edit mode, press A to select all, and I'll scale this up in the Z axis and then return back to the complete scene. And yes, you can also adjust the particle size by going to the particle settings by clicking here, and then you can go to the render settings where you will find the option to change the scale. So you can increase or decrease this value depending on your exact requirement. So currently I've set this up to 0.09 and this is how it appears. After this, the animation will go on as these glass particles will fall in the downward direction. Then the robot will move forward in the x-axis and then it will come down in the z-axis. After this, we'll watch the robot rotating its head, and during this time we also have the animation of the eyes being scaled down, which we can check in the render preview mode. You can see that the eyes of the robot are being scaled down during these frames. After this, the robot will turn its head towards the front, and then after a few keyframes it will look above, and to end the animation it will finally look at the camera, where we'll also have the winking animation of the eyes. And with this I think that we have everything ready in the scene except for one thing that we'll do in the next module, and it is the camera animation. Because even after doing all this, if we don't have a camera in the scene to render this animation, or if we don't work on the camera animation properly, then there will be no use of creating all this, because you would either not be able to render the animation, it will not look good. So let's learn about the camera animation in the module number 10. Welcome to the 10th module of the Blender 3D animation course. Till now we have completed the majority of things in the robot project. We have animated the whole scene, and all what is left now is the camera animation. So let's begin with it. Now currently in this scene we have no cameras, and if you ever want to render an image or make an animation in Blender, you must have a camera to record the entire scene. So to add a camera here, let's press Shift A. Then in the add menu you will find the camera, and by default it will get placed at the position of the 3D cursor. So if I press 0 on the numpad, I'll obviously see nothing because of its placement. But there are a few methods of moving this camera around and getting it at the desired location. The first one is, while keeping the camera being selected, I can move this up by pressing G and Z and moving it up like this. And then if I press 0 on the numpad, I'll be able to see this view, which is the camera view. Another way can be to press 0 on the numpad, then click on this lock camera to view icon, and then if I zoom out and then use the shift key and the middle mouse button, then I can move around the viewport, and along with that the camera view will also change. So this is a very easy method which you can use to set up the camera. You can also use the scroll wheel to zoom in or out in increments, but if you want a smoother zoom in and zoom out, then just like you do in the viewport, you need to hold the control key, then press the middle mouse button, and then if you move the cursor up or down, then you will see a smooth zooming and zoom out. But if you want to come out of the camera view, then you would have to click on this lock icon again, so that this will disable the lock camera to view, and now you can change the view easily without the camera view being affected. Now in most of the cases people prefer to change the view with the lock camera to view method only, because it allows them to easily get the desired shots. But sometimes when you're working with very precise angles, like if you want the camera to be rotated in the z-axis by exact 90 degrees, or you want the camera to be at exact specific location only, then in those cases you can use the values in the object data properties to set the position of the camera. Like right now, the y-axis rotation is almost 0, but I can change this to exact 0. And the z-axis rotation is somewhere around minus 90 degrees, so I can keep this exact 90, and then you will also notice the change in rotation here. Also I can use the location values to change the location like this. So to begin with animating the camera now, I'll first go to the frame number 1, where we'll have the initial position of the camera. So in the starting, I'll be keeping the x-axis rotation value to 90, and I can change this value if I think I need to have something else as the rotation in x-axis, but for now I'll keep this to 90 only. Then in the y-axis rotation I'll change this to 0, and in the z-axis I think minus 90 should be fine. Now I need to move this back in the x-axis. You can check this thing over here that this direction is the x-axis in the front. So if I reduce this value to, let's say, minus 10 or minus 13, then we'll be able to zoom out. I also think that we should move slightly downwards in the z-axis like this. Then I'll slightly move in the y-axis to ensure that this glass and the robot inside it are basically at the center of the camera to attract the viewer's attention. Let's select the camera in the scene collection again, because we'll have to animate it by inserting the keyframes. So you must ensure that you have selected the camera here. Other than this, I think that I should slightly rotate in the x-axis like this, and then I'll slightly move this upwards in the z-axis. Also, I think that we should zoom out more, so you can use the scroll wheel to zoom out, or else you can use the x location value, and I think we should keep this to something around minus 28. Let's also go to the render preview mode, and yes, you might be seeing that here all the region except that in the camera view is not being rendered, and the reason why it's happening is I have turned on the render region tool in the output properties. By doing this, you can basically get the rendering done in the 3D viewport a lot faster, because then only the relevant region, which is in the camera view, will get rendered. So I think that for the first frame, this position of camera will be fine. We have the glass and the robot in the middle. So with the camera selected, I'll press the I key to insert a keyframe here. Then let's go back to the solid mode. and then I'll bring the pointer to, let's say, frame number 60, where if I go to the render preview mode, we'll be seeing the transparent glass material and the robot will be moving up and down. So here we'll have to zoom in. So I can hold the control key and the middle mouse button to zoom in like this. And let me also bring this up in the Z axis like this. Let's also slightly zoom out. And apart from this, I think we should slightly push it in the Y axis also to ensure that the cylinder and the robot stay in the middle. Then press I to insert a keyframe, and with this we have the first camera animation ready, where it basically zooms in like this. And if you remember, we learned previously that whenever you create any animation, it's not linear. Like initially the animation will be slow, then in the middle it will gain some speed, and then it will be slow again as it reaches the end. If you want to change this thing and get a uniform motion in the camera, you can just go to the graph editor, then to view the curve, let's scroll down and basically zoom out. And here we see one of the curves. To view all of them, I'll click here. Then in the object transforms, we have all of these enabled or basically unhidden over here. So what I'll do is to hide the rotations and the scaling. And here we see the X, Y and Z axis graph for the location. Then I'll select this pointer over here, press T to open the keyframe interpolation menu and change this to linear. This will ensure that the animation happens linearly, that is with a uniform speed. And I personally feel that when you're making camera animations, it's usually good to go with a uniform speed because otherwise it does not really look very natural. Now for the Y location also, I'll do the same thing. I'll press T to open the interpolation menu and change this to linear. And at last I'll select the Z axis over here, press T and change this to linear. Now after this, the camera will stay here for a little while the robot will be moving up and down, and then we'll have the shattering of the glass. So till now nothing will happen in the camera, but then at somewhere around the frame number 440 or maybe 450, to be accurate it's 442 I guess, the robot will begin to move in the forward X direction, and so we also need to push the camera back so that it can follow the robot's movement. So I'll first keep the pointer at the frame number 440, then press I to insert a keyframe here. Then I'll take the pointer to that position where the robot stops moving in the x-axis. So I think that frame is 458. Then I'll zoom out. Let's also push it slightly downwards to make sure that the robot is in the middle, and then press I to insert a keyframe. This will give us this camera animation of zoom out as the robot moves in the forward X direction. After this, it will begin to move in the downward direction. So around the frame 70, we'll also move the camera downwards in the Z axis. But by doing this, we have some objects in front of us that are blocking the view. So I'll simply hold the middle mouse button and change the view like this. You can adjust this view on your own. And after this, I'll press the I key to insert the other keyframe. Now we have this animation of the camera as the robot will move down. And apart from this, I don't think that there's anything else in the camera animation that we need to do. We can keep this camera at this position only for the remaining animation. When the robot will look at the camera and wink at it, let's check it one more time. So I'll go to the render preview mode, and we have the camera placed like this. We have the robot in the middle that we wanted, and then when the wink animation starts, we have the robot looking at the camera, so the angles are also perfect. And with this, I think that we are done with the project now. We have animated the camera as well and the entire scene. So let's disable the lock camera to view. And there's one more thing that I need to show. So with the camera selected, if I go to the object data properties over here, then here we find an option which is called depth of field. And if I enable this and go to the render preview mode, then this gives us a very useful setting called the focus distance. And rather than explaining in theory what it means, I'll directly change this value down to 0. And you will notice that we are not able to see anything. But if I now change this to, let's say, 1 meters, then we see that everything looks very blurry. And this is because the focus distance controls the visibility of an object from the camera view based on its distance. With a focus distance set to 1 meters, it means that the camera will be able to see only those objects clearly that are within the range of 1 meters. Beyond that, every object will be blurred, like we can see in this image right now. But if I increase this value to, let's say, 5 meters, then we see some less blur effect. And similarly, if I increase this to 10 meters, which is the default value, then we'll be able to see the objects in a much clearer way. You can even set a focus on object, like if you have a moving object in the scene and you want the focus to change depending on the position of that object, then you can use this option in the depth of field. Currently, I think that we can use this focus distance option in the beginning, where I can decrease this value to 0 meters, or maybe let's change this to 0.1. Then I'll insert a keyframe over here, and then I'll take the pointer to frame number 25 or maybe 30, and then I'll change this value to 10 meters and add another keyframe. Let's see how this looks, and I think that it's giving it a nice effect, as initially we have everything blurred out. Then as the camera moves forward, everything will begin to look much more clear. And with this, we now arrive to the end of the 10th module of the Blender 3D animation course. We are almost done with the entire project. Just one thing is remaining, which is lighting and final rendering. And we'll do this thing in the next module, which is the module number 11. Welcome to the 11th module, finalization of the scene, rendering, and conclusion. In this module, till now we have completed almost the entire project along with a simple camera animation, and now we have to see if any adjustments in the lighting are required and how we finally render this animation into a video file. So first of all, let's go to the render preview mode, and currently what we are seeing is not the actual lighting setup because the scene lights and the scene world are disabled. And this is what we'll actually see if we render the animation right now. Apart from this, we also had the floor of the sci-fi lab, which is hidden currently from the scene. So what I'll do is to select this scene, which is basically for the sci-fi lab. And if I click on this drop down to open it, I can go to meshes. Then in the Sketchfab model, I'll find this environment lab. And in this, we'll find several objects, out of which the 13th object is hidden. So I'll unhide this and we'll get the roof back. Now, just like the last project, we have a few ways of adding the lighting. The first method can be obviously to add the lights by pressing Shift A, going to the light category and selecting any of these lights and then adjusting it. The second method can be to use some HDRI, which is an environment texture. You can download it from some external website and use it instead of this color option in the world properties. Then the third option is to change this color to the white color, and this will give us a nice lighting in the scene. You can control the strength from here. Like you can keep this to 0.7 if you want some lesser lighting depending on what exactly is there in the project. For example, I think that we can keep this to 0.6 to give it a cinematic appearance. Let's also see it in the ending frames if it actually looks good or not. And I think that 0.6 strength looks fine. Other than this, we have one more method that we can use. But to explain that, I'll have to remove this. So I'll reduce the brightness for now like this. And that method is basically to use a plain object to emit light. To show you what I mean, I'll press Shift A, then go to Mesh and select a plane. Then I'll move it in the X-axis and place it over here. Let's also rotate this in the Y-axis by 90 degrees. And I'll scale this up, and let's also scale this in the Y-axis. So press SY and scale it up like this. Now I'll move it up in the Z-axis and let's slightly rotate it like this, as if it's being used for lighting setup. Currently it does not have any material, so it won't emit any light. But if I change this to the shader editor, create a new material, and then if I go to emission and if I increase the strength, then you will notice that the light that it emits can be used in the scene as well. And this method of lighting is not very widely used, but it can actually be a very great thing because it easily allows you to set up the lighting without the need of adding any point light or sunlight and then setting it up in the scene. You can directly use a mesh object, preferably a plane. Then you can give it some emission material and you can control the strength of the light from here. So if I decide to use this, I'll keep the strength to around 2 or 2.5 because I don't want too much light in the scene because it's a sci-fi lab scene. Let's check the ending part also if everything looks proper or not. Like here I can see that there is too much light which is reflecting on the glass or the screen of the robot. So what I'll do is I'll move it slightly upwards in the Z-axis and then again go to the camera view, and now it looks better. Let's check the same thing at somewhere around the frame number 417 if we see any error. And I don't really think that we need to fix anything else here. One last thing that we should check is when the glass shatters, does it refract the light properly or not? Because with the poor lighting, I don't really think the shattering of glass will look any good. And I actually think that the strength of the light should be slightly increased, let's say to 4, so that we'll be able to see the glass properly. Or else, along with the plane added, I'll go to the world properties and make this white as well. Then in the strength, I'll reduce this to 0.3 and this will give an overall lighting in the scene, but I'm keeping it to a very low strength because I do have a plane in the scene which is already emitting the light. So I won't go for a very high number here. And yes, you might have to adjust these values depending on your scene, what objects you have, how you have placed them, how much light you need, and other things. But for now, I think that the lighting part is perfect and we can finally render this scene. So first of all, let's go to the render settings, then ensure that the cycles render engine is selected. Then in render settings, I'll turn off the denoisy option, and in the maximum samples, you can keep this to 100 or 200 because the animation is going to be of 650 frames. So it will take up a lot of time to render. Even with a good graphic card, 45 minutes to 1.5 hours to render this complete animation. But if you have a low-end PC, it can take even 2 to 4 hours to render. So do ensure to keep the maximum samples value to something very reasonable. Like for now, I'll be keeping this to 256. And apart from this, there's nothing else here that we need to change. So let's go to the output properties, keep the resolution to 1920 pixels in the X-axis and 1080 pixels in the Y-axis. then in the frame range you can choose either 24 FPS or 30 FPS. The animation is already of 650 frames, so I think I should be going for 30 FPS because that will give me an animation of 20 or 22 seconds, which is a nice timing. Now you might be thinking that even though we are rendering an animation, but still we are given the option to choose an image format as the final output, which isn't really a mistake of Blender, and it can actually prove to be very helpful in some situations. For example, let's say you are rendering this complete animation and it will take around 1.5 to 2 hours. But if you choose the file format as the video and due to some error like power cut or the software crash, the rendering could not be completed till the last frame, the video will not get saved and you will have to re-render everything from scratch. But instead, if you choose the PNG file format, which is for the images, and then render each frame separately in the form of an image, then at least all those images that have been rendered will be saved and then you can later on render the rest of the animation. But it's just that you will have to use a video editing software later on to combine all those images and turn it into a video. But I still think it's a very useful method. It just takes 5 to 10 minutes extra to convert the images into a video. If you frequently face power cuts or software crashes due to any reason, for now I'll be keeping this to the video format only because I think that my device can handle it and I'm not expecting a power failure right now. The next thing that we have to do is to set the file path where the video or the images will be saved. So you can click on this folder icon and choose the folder where you want to save the rendered file. Then here you have the frame range where I have set this from 1 to 650. You can adjust these frames depending on how long your animation is. And apart from this, I don't think that there's anything else we need to change. And so we can begin with the rendering process. So click on render and select render animation. This will open the render page where the rendering is started for the first frame, and you can check the sample count here, and this might take up around 1 hour or even more time to render. So till then you can grab a snack or go out for a walk and then you can come back to check if the rendering is completed or not. So we'll see each other once this gets fully rendered. So I'm done with the rendering process and this is how the final result looks of 21-second animation, which might look simple, but during this journey of creating this complete animation, we learned a lot of new concepts related to modeling, animating stuff, importing assets, rigging and animating a character, creating controls. Then we covered the camera animation part, and in the previous project of the basketball, we even covered the 12 principles of animation. And with this, we finally arrived to the end of this course. I hope you learned some new concepts from this course and you will now be able to apply them in your own projects. Also, if you managed to complete this course and also rendered the complete scene, then you can share the rendered version of both the projects, that is the basketball one and this robot project, on the Discord server whose link is mentioned in the description of this video. And before ending, if you found this course helpful, then do hit the like button and don't forget to subscribe for more such courses, tutorials and related content. Thank you for watching and I'll see you in the next one.